Ladies and gentlemen, check, check. Good morning, ladies and gentlemen. In next few minutes, we'll be starting this amazing day. A very productive day, a long day ahead with very informative day. I request each one of you to please be seated. I hope you all are waiting. I think you all had breakfast, right? Can I hear the sound? Wonderful. Yes. Hello, everybody. Good morning, ladies and gentlemen. How are you all? How are you all? The energy is little bit down. Can I hear the energy of Idli Vada? Come on. How are you all? Wonderful, amazing. Good morning once again. A very warm welcome, respected dignitaries, distinguished guests, esteemed speakers, and my dear participants. This is me, MC Chandani. It's my pride and honor to welcome you all to this prestigious international conference on state-of-the-art health monitoring of structure hosted by Indian National Group of IABSE Karnataka Center here in the vibrant city of Bengaluru. I'm waiting for your round of applause. Thank you. Before we begin, let me take a moment to reflect on the legacy behind this remarkable gathering. Yes, the International Association of Bridge and Structural Engineering, founded in 1929 in Zurich. It's a globally respected body shaping the future of structural engineering. In India, the Indian National Group of IABSE connects our engineers with global expertise, encouraging innovation and collaboration. And right here, ING-IABSE Karnataka Center since 2019 has been bringing together brilliant minds to share the knowledge and a space to share that knowledge and drive progress in infrastructure. Today's conference focuses on one of the most critical and evolving domains in engineering, that's structural health monitoring. In the world where infrastructure is growing rapidly, ensuring safety, reliability, and sustainability of the structure is very important. Just it's mimic our body and our system. So to prevent or to check our bodies as we go to the doctors, and to check the fitness of structures, we consult our super engineers, and that's you all. So yes, the doctors of structures. With advancement of smart sensors, artificial intelligence, data analytics, digital twin technologies, structural health monitoring is transforming how we design, maintain, protect our infrastructure, how we maintain our body, how we design ourselves by drinking, by hydrating ourselves. In the same way, the structure, how we design, protect our infrastructure is most important, and today we are going to learn and take a lot of information from this session. This conference serves as a global platform where brilliant minds come together to share insights, innovation, and real-world applications, shaping the future of smarter and safer structures. Now, it gives me immense pleasure to start this amazing day with auspicious lighting the lamp. I request our dignitaries to please come forward to kickstart this amazing day with ceremonial lighting the lamp. so much. I now request Mr. R.K. Jaigopal, Managing Director of Struct Geotech Research Laboratories Private Limited, Bengaluru, to kindly grace the stage. I request Mr. R.K. Jaigopal, sir, to please take the stage. Can I get a huge round of applause, ladies and gentlemen, please? Thank you, sir. Now, let's dive in a most informative session. It's my honor to introduce our first principal keynote speaker, Dr. Harshavardhan Subbarao, President of International Association for Bridge and Structural Engineering, Zurich. And it's my proud to introduce him as a first Indian in nearly 100 years to hold this prestigious position with over 36 years of experience. Sir has been the mind behind the landmark infrastructure projects across India, including iconic cable-stayed bridges, metro structures, and complex engineering works. A global expert in bridge engineering, structural health, and advanced technologies like UHPC and CFRP. His contributions have shaped safer and smarter infrastructure, a recipient of several prestigious honors, including SP Joshi Memorial Award 2026. His journey is truly inspiring, sir, being the first Indian lead to lead the IABSE. It's not just an achievement, it's a moment of pride for entire nation. Come on, everybody, join me in welcoming Dr. Harshavardhan Subbarao, sir. Sir, stage is all yours.
I need a pointer, ma'am. A pointer.
This mic, put your mic on this.
I got it.
I'll be giving this mic as well.
This is okay. I don't need that. This is okay. How does he change the slides? From here? I got it.
I welcome the first Indian to become the President of IABSE. It's a proud moment for us here to request him to address the gathering with the principal keynote address. He's an expert in the structural engineering. I know him. In fact, basically, we should be very happy that he is from Karnataka, and he's basically his father is from Mysore. They served the palace of Mysore, their ancestors, and his father was the head of the Gammon Engineering. He's an extremely brilliant structural engineer. We should be lucky enough to hear from him about the structures and also about, in specific, the IABSEs, how to take it forward as far as we are concerned in the Karnataka state is concerned. Sir, stage is yours. Kindly go ahead.
ನಮಸ್ಕಾರ ಎಲ್ಲರೂ. ನಾನು ಇಲ್ಲೇ ಬ್ಯಾಂಗ್ಳೂರು ಹುಡುಗ, BMS ಕಾಲೇಜ್, ಇಂಡಿಯನ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಫ್ ಸೈನ್ಸಲ್ಲೇ ಓದಿರೋದು. ಪ್ರೊಫೆಸರ್ ಅನಂತಾಗಿ ಗೊತ್ತಿದೆ. ನಾನಿಲ್ಲಿ ಮೂರನೇ ಸತಿ ಬರ್ತಾ ಇರೋದು ಇಲ್ಲಿ ಕರ್ನಾಟಕ ಸೆಂಟ್ರಲ್ಲಿ, ಥರ್ಡ್ ಮೇಜರ್ ಇವೆಂಟ್. ಸೊ ಹ್ಯಾಟ್ಸ್ ಆಫ್ ಟು ಕರ್ನಾಟಕ ಸೆಂಟರ್. So, good morning, distinguished guests, colleagues and friends. I bring you greetings from the IABSE. The IABSE is the International Association of Bridge and Structural Engineering, headquartered in Zurich. It's a privilege to be here at this international conference of ING-IABSE in Bangalore, at the Karnataka Center. Today I will speak on health monitoring of structures with an emphasis on bridges. As engineers, we design structures to last decades, sometimes over a century, design life. But the real question is, how do we know they are actually performing over time? How do we know how they are performing over time? Is it measurable? Do we know? Can we quantify how well it's performing? This is where structural health monitoring becomes essential. Let me begin with a simple observation. In fact, even before that, I will just introduce the topics I'll be speaking on: an introduction, why SHM matters today, what is SHM, the current state in India, what is the architecture that you need, what does structural health monitoring all entail, what all do you need for it, then the sensors, then the data and the analytics that go into it, its application to bridges, how to plan, what are the limitations, what's the reality in terms of its use, the work of ING-IABSE, the work of the global IABSE body through its task group 5.11, which deals specifically in this topic alone. It's a global expertise with representation from more than 20 countries. Case studies, I will try and point out 2 case studies. One, signature cable stayed bridge in Delhi, which I was lucky enough to design. And the other, a rail-cum road bridge, Bogeybill Bridge, which was being alluded to earlier, Bogeybill Bridge. So I will try and cover those. And then I'll tell you about some future emerging trends and some sort of a concluding remarks. Let me begin with a simple observation. Across the world and also in India, we are dealing with aging infrastructure, increasing traffic intensity, and growing exposure to extreme events. There's, of course, the vagaries of climate change and the extreme events that are being forced upon us as the whole world is realizing the impact of climate change. Traditionally, we rely on periodic inspection. We go every 3 years, every 5 years, we have a maintenance schedule, or after monsoon, before monsoon, after monsoon. So there is a periodic inspection carried out to the structures. But what do these inspections tell us? They only tell us what we see. It's on the superficial, it's on the outside. SHM tells us what is happening continuously inside the structure, in the heart, inside the structure, what is happening inside. So structural health monitoring is essentially, and it is becoming a necessity. This structural health monitoring is becoming a necessity for good asset management and for getting the most out of your asset in the argument of sustainability. Get more for much less, or by doing less, get more. That concept of sustainability is very, very essential. That's where SHM finds its own home. You can see on the right the Hong Kong-Zhuhao link, which is 48 kilometers on long in the sea. And from the Hong Kong on one hand to Zhuhao and then to the Macau, this is an instrumented cable stay. You can see the various types of sensors that are used, and you can see the various sensors that are in use there. And you can also see why the sensors are put, the various different types of sensors. I'm not going to read in detail. You're going to get all that in the next lectures that will come. I'm just setting the scene, and especially for young students here, to try and understand what is the whole paradigm of SHM. Okay, so here we are instrumenting with inclinometers, with tilt meters, with strain gauges, with accelerometers, and so on, scour gauges, and so on. So a bridge requires to be instrumented, and then of course all that data is gathered, and it is kept in a central console, and that console sort of sends all that data, the logger sends all that data by LAN or by wireless link to a motorway management center or wherever this bridge or this asset is being managed to take decisions based upon the data you're getting and the analysis of the data that you make at the management center. So what is SHM? It's continuous or periodic data-driven assessment of structural condition. The core objective is detect damage early, predict the performance, future performance, and enable decision making to make correct decisions. The global status today with SHM, it's widely used in major critical infrastructure, like the one I just showed you. It's high-value assets, cable-stayed bridges, suspension bridges, very long crossings over Brahmaputra or Ganges or Coastal Road of Mumbai, Trans-Harbour Link of Mumbai. They are all instrumented with sensors, okay? And also when we repair, we need to know what is the efficacy of our repair and how well the repair has been done and monitor its status over some future time. For that also, post-repair and strengthening, we put sensors, we monitor. The growth is driven by increasing safety regulations globally, The digital transformation which has made handling big data and AI all very, very simple. And the whole transformation that is happening in the AI space and things like Python, etc., which are leading cloud, dealing with stuff in the cloud, putting everything for cloud, anybody can access anywhere, and the Internet of Things. All this has completely revolutionized in the last 10 years what is the paradigm of structural health monitoring. And of course, we have the growth driven by our aging infrastructure. In India, the status is somewhat, I wouldn't say different, but somewhat in the sense that whilst we are taking important steps like developing our own Indian bridge management system, an earlier attempt we had, which was not very fruitful, though it prioritized many of the structures for intervention, bridge structures for intervention all over the country, the decision-making modules and certain things were lacking in that IBMS, which are now being put in, and this IBMS will actually have a very good system of prioritizing as we start to use it. Apart from just inventory, it'll also have decision-making ability. So India is on that path, and Rajawat Sab is here, and this is a goal that the ministry has, and they are implementing it. They have appointed a certain consultant for putting that also into place. So increasingly, whether it's Signature Bridge, Bogeybill Bridge, Coastal Road, Trans-Harbour Link Mumbai, maybe metro structures which are being instrumented, railway bridges for acoustic. You'll hear in the next talk about the instrumentation and the work carried out for railway bridges by Professor Ananta. Then you will also understand that even today, we are largely relying on visual inspection, some NDT, and periodic surveys and things like that. Not continuous, discrete in time, not continuous, not into the heart of the structure. And there is a gap between the data we get, monitoring, and how we integrate it into the decision-making process, okay? The gap is not in data collection. It is in using data for engineering decisions. There's no point in data without it having some use and some decisions being made on it. No point over-collecting data, no point over-instrumenting things, okay? So every SHM system has three basic components. If you see the top figure out there, okay, you plan, then there are sensors, different types of sensors that you put in place. Then data acquisition, all those sensors go to a data acquisition unit, which has to be very rugged and robust and withstand all the vagaries of nature, dust, wind, cloud, storm, etc. It should not fail, otherwise you lose all the data. And so robustness and resilience of the data acquisition system and the sensors, the life and longevity of the sensors is critical, okay? Otherwise, you'll suddenly run out, or the sensors will fail, or the data acquisition will go bust because of bad weather, or a lightning strike, things like that. So the robustness is very important, and you have a data acquisition unit, then you have the processing, and then it can be on the site or off the site, as you can see there, okay? So structural health monitoring, the most important question is what we actually want to know. What is it we want to know? You know, is it the stress? Is it some fatigue is accumulated? How do I know how much fatigue accumulation has happened? How many stress changes happen? I can't by looking at it. I can't by taking some simple NDT equipment to do that. So if I'd been continuously monitoring, I'd have got the history of the vehicles and the stress changes over time. So fatigue is something which you cannot discretely monitor in any case. It is a continuous monitoring requirement, right? So these are the processes, and then you see here, and if you see there, if you see how the data goes, you pre-inspection, then you have sensor installations, then you have permanent monitoring, then you have data acquisition, and then you have your analytics on the data, and you report to the client. Thresholds have been set, they haven't been crossed, they have been crossed, what to do, how all the different sensors give you, are combined in knowledge, in connected time, not there, they have to be totally synchronized. All the various sensors are fully synchronized to the dot and second, to the millisecond. So that combined knowledge can be integrated and you can make a wise decision. Of course, an engineering judgment can never be offset by any kind of automation that you have. Engineering judgment will always rule. Okay? So you see here the kind of strain gauges, you see here the kind of strain gauges, the kind of vibrometers, where the anemometers will be probably at the top there, displacement sensors, inclinometers for inclination of this one, in case the foundations rotate or there's some settlement, and so on. And of course, these fellows will be, vibration will be very important for assessing the stiffness and changes and breakages that may happen in these cables, for example, the critical elements here in a suspension bridge. There you see a simple pasting of a strain gauge, linear strain gauge, connected to a data acquisition, connected to a system which would go directly to the data acquisition unit. The data acquisition unit will be invariably stationed on the bridge. Then it will use wide area network or LAN to beam to the client's office or wherever the data will be permanently stored, and you will utilize it for dynamic, for assessment. So typical, you have various types of sensors, as I told you. They're all fusing together because you use different sensors to make the same measurement. You can take displacement in 3 different ways, by LVDTs, by visual observation, by visual camera observations, etc. So you integrate them all, but they must all be time-stamped. The important thing is coherent time-stamping of all the data, yeah? So that you can combine it, fuse it, then you have to manage that data because data should not be lost. Everything is historical over time when you go for structural health monitoring. You want data which was 10 years ago, it should be available instantly. So the robustness of your data, its storage is critical. Then of course the analysis, today we are handling big data, we are making decisions, we have programming, we have something like cloud today which is very, very powerful if you know how to prompt it. You can make it do very, very many things including coding. You don't even need to know how to code if you use cloud. And you can get that in the analysis phase. The data becomes useful because you have something that is measurable, coherent, time-stamped and integrated. You are then able to then take that data and do something with it. Okay? The with it is to take decisions. And that is where, again, things like Python and all will help you in today's paradigm. Then, of course, reporting and alarming. You set thresholds. Displacement should not be more than L by 800 at the center, cantilever L by 300, etc. You're measuring it. So whenever it is coming to 50% of that, you get an amber signal. Whenever it is coming to 90% of that, you get a red signal. Whenever it exceeds that, you get a double red or a continuous red signal. So you can set it on your dashboard. All this will be in the form of graphs, data, charts, etc. on a simple dashboard, which today with the Internet of Things is as simple as on your phone. Entire signature bridge decisions and checking is done on a mobile phone sitting in Switzerland. The bridge is in Delhi. So this is the Internet of Things for you, and the ability to get the best people to do that work of assessment and understanding and dealing with the data. So the typical flow is from sensor to data acquisition to edge processing, edge computing. Then take all that data, store it in the cloud so it is there forever, it is never lost. You can't say the server broke down or the hard disk failed. That will never happen in a cloud. Cloud has multiple backup anyway. And then the dashboards, a typical dashboard like this, giving the frequency of the bridge, static or dynamic sensors. Here we are talking about dynamic sensors and dynamic signature of the bridge, its mode, its frequency, its damping characteristics, how those change with time. That gives a clue. Suppose a cable breaks or a hanger breaks on a suspension bridge. It will change the stiffness, it will change that, and it will be instrumented, it will pick it up, and these signatures will change. And if you set the thresholds, the alarms will go off on your dashboard. So finally, what you want is to do something with the data, which is like this. Okay? It should be presented in a manner which makes decision-making easy, and human judgment will always prevail above whatever anything a machine is telling you. So take, for example, the sensors. There are different types. They're static type. They are dynamic type sensors for measuring dynamic properties, for measuring static properties. So you have various types of strain gauges which you can put here. I'm just showing you something on a simple truss bridge, say in the Himalaya. And here you can see the type of sensors, the computer-based visual check. Then you may also have displacement sensors separately. And they can both be coherent in the same timestamp and give you a clear understanding of displacements over time. History is very important, keeping that history. Then you see radar interferometry also again, okay, for deflection sensing. So different ways of detecting deflection, combining them all at the same millisecond to give you a coherent judgment. So redundancy in the approach is very much built in. whatever property you want to measure, you must have a redundancy. If you have an electrical system, you must use a electromechanical system or a mechanical system, if you have an electrical system, and so on. So even the method of that sensor could be a piezoelectric crystal, for example, maybe a different form of sensor to an LVDT, and things like that. So you have redundancy in both the way the sensor works, the principle of the sensor, as well as the types of sensors that you are using. And here, of course, you have, for example, a Bragg sensor, which I will come to in a little while. So advanced sensors today, apart from our strain gauges, tilt meters, crack sensors, and piezometers, etc., are fiber optic sensors. These fiber optic sensors use photonic principles, and they are a cable that runs very thin cable, and light works at the speed of light. So along an entire length of the structure, you can monitor at any discrete point you want at all over the entire length, the temperature, the strain, so it is a distributed sensing, if you like, over an entire length. So this is very important with this development of this, and the principle is totally photonic. It is not to do with electrical, mechanical, or piezo, for example. Then you have acoustic emission, which is a new technique in the last 10, 15 years. It got very popular. And acoustic emission will tell you if a cable has broken, there's a sudden crack somewhere in the box girder, 30 meters down its length. Or if in the acoustic emission signature, you are able to detect a sudden popping of the strands of a cable number 26 tendon inside the girder, box girder. 2-3 wires snap. It sets off an acoustic emission signature and immediately alerts on the dashboard a signal. So these are the ways the sensors are good. GNSS, of course, got to do with global positioning navigation systems. So you actually can geotag every location of the structure. Now, if you combine them with LIDAR and 3D, which you see on the right-hand side, out here, you can see here, all these things. If you combine satellite, drone, LIDAR, thermal photography, underwater for scour, and condition underwater, and build all this with artificial intelligence, and you build up a digital twin model, which I will come to soon. And you can actually use this to a far better extent. We can actually work on the digital twin model rather than on the real model and do what-if scenarios using virtual instrumentation, the same instrumentation virtually implanted onto the structure. Without even needing to physically instrument it, we can instrument the digital twin, save a lot of money, and utilize it. So today that is also possible going forward. What do the sensors look like? They are, once the behavior becomes measurable, okay, it is only when you use the right sensor and combined and time aligned. The combinations of sensors and time aligned to get that property you want measured. Say like displacement or strain or temperature. So most SHM projects use a mix of sensors to capture both slow changes like settlement, thermal, strain, and fast events like traffic, impact, vibration, and correlate them to understand load paths and structural conditions. So you have strain gauges, you have force transducers, you have acceleration tilt sensors, you have displacement transducers, LVDT type or string pots type, you have temperature sensors or thermocouples, you have fiber optic sensors like grating sensors, and then you have acoustic emission. Now, all are different things. They work differently, they work in different principles. They all will give you continuous data from now till the sensor fails or the acquisition unit fails. So the robustness of these sensors and the acquisition unit is critical. Storage is never a problem because we are now on the cloud. So those problems of hard disk breakdown and losing data will never happen. The failure will be at these two stages, non-robustness of the sensor and the data acquisition unit. So then you go to large civil assets. This is a particular company, one of the leaders in the field amongst others, called Gartner, and you can see here, where they're using and the level of protection, the quality of robustness to IP66 that they have to build into their sensor. I mean, the quality assurance of their robustness and, if you say, resilience of their sensors is very, very high. Okay. And a typical scheme, I won't go into this, I can share this presentation with everyone. They're welcome to take copies. And you can see the various types of instrumentation that may be done on a crossing, monitoring weather, wind, temperature, ambient temperature, relative humidity, then monitoring, wind, vane motion systems, monitoring the number of vehicles crossing, and so on with visual camera systems, and using AI to correlate all this into a coherent mass for decision making. Of course, through the decision modules, etc., that are to be built in. And storing everything on the cloud. I mean, I can get the data of my bridge sitting in Timbuktu. It doesn't make, I don't have to physically be there at the bridge. Okay. So not every point can be reached by a cable, so we also have wireless sensors. So your system has to be able to work between digital, analog, and wireless, and seamlessly integrate all these. So you need DA converters and things like that. But in fact, the sensors work wireless, cable, or like drag sensors. They're all different. That works on photo principles. They're all different, and you have to have an analyzer, an acquisition unit and analyzer system which can look at, understand, and see all those, correlate between all those, and come to common decisions for your assessment, to your dashboard, for example. So time synchronized measurements, I keep stressing, this is where all systems fail. Nobody does time-stamped measurements that easily, and this is one of the most important principles of structural health monitoring. So the solution can support vibration, force, strain, temperature, and more deflection, scour, so many things that are critical to a bridge with very low power. Power is very important. What happens if power fails? You lose your data? So reliability of the power supply and out there ready deployment, either a solar battery system or backup, you have to design in this redundancy. So good and robust system can have many wireless and analytic sensors, etc., and all can be housed into a common collection unit. So secure cloud storage, project-related dashboards, and limit-based alarms set at the design stage itself. When the designer is there, it is important that the designer set the threshold values. Nobody else is going to do it. So the designer has to set the threshold values for exceedance and the levels of alarm, yellow, orange, red, or amber, whatever, double red, or however. You have a gradation, and you can set the values that at 50% of threshold, I'll get a small warning. At 90% of threshold, I'll get a different color light or a different warning. And if it goes between 90 and 110, I will get a double red warning. I've exceeded. Okay? So like that, you can set that and you can implement all these. Whatever system you have, you should be able to design in your own algorithms to understand the data. So this open source and open, many people make their patented things and you're not able to then integrate and use different sensors and different software. So openness in the software is also very, very critical for you to combine the correct type of sensors into the system. So time control allows synchronization of all sensors and stores the data locally. Then you've got your an integrator, you've got these various integrators, weather stations, all these, how to build in robustness into those systems. And whether you have IP cameras, you can't have a camera which will fail. You need to have a very, very high quality, industrial quality camera, which even if it rains, even if it gets wet, even if there's moisture, it doesn't stop to work. So these are very, very important things which are not just the property to be measured, the robustness of the systems that you put in is what I'm stressing here. The rugged data acquisition unit has to be rugged. It has to be stored in a place where, like we say, for example, in Signature Bridge, it is inside the hollow leg of the pier, at the base of the pylon. It is inside a pylon leg. It is in a secure place. It does not face rain, wind, relative humidity that much as it would if it were mounted outside. So you have to specifically take care that the housing unit, which houses all your data acquired locally, is well protected. So the platform should offer robust data logging, visualization, alarming, and analysis tools, along with open interfaces for seamless system integration and interoperability. You have a dashboard like this, okay? You have acoustic emission on the right-hand side, showing the signatures over time of the various acoustic emissions, and you see in the top left-hand, suddenly there's a drop. So that's an alarm set off, as per the AE system which we're monitoring. And we integrate this into all the other strain gauges, deflection, all that we're monitoring acoustic emission now becomes an additional adjunct to add on to that. And it is a continuous system. It's not a discrete spot-based system. It will monitor the entire length of the girder for you. You don't have to, instrument it at discrete locations, just like the garage sensor. So easily integration, and the fiber brake grating sensors, the Bragg's grating as we call it, we can take temperature, it can sense changes in pressure, it can change changes in strain, etc. We measure pressure, strain, temperature, acceleration, displacement, shape sensors from this one wire-like thing that runs through the structure. At where you want it to run, you can deviate it, take it, etc., and works on photon principle. It is not affected by electricity. It is not affected by any changes. So data is measurement, data decision. That's what I mean. There's no point data on its own. And you have different, say for example, in my hangers and cables, I will want the parameter that I want to measure is how much load they are under, how much tension they are under, right? So vibration can give me, from vibration it can switch to stiffness, and from stiffness I can understand whether my structure is becoming softer or it is remaining the same with time, and I can make inference upon my structural behavior, overall structural behavior. So data pipeline, very important, data acquisition, storage, processing. The key point is SHM is data-centric engineering. It is engineering. It is not just collection of data. And from data to decision, features extraction, pattern recognition, damage detection, and the overall mask of AI and machine learning, which is increasingly used today to make this data to decision far simpler for us. Something which even 3-4 years ago was not possible. So the handling of big data, training, machine learning, and the use of AI, and the need not to be able to even know how to code and to create open interfaces between all these various softwares, sensors, for example, will allow you to work in a completely different way than what you're doing just say 2 to 3 years ago. So this is the future that is happening as we speak. What are the challenges? You over-instrument. You get too much data, data overload. Then you have a lot of noise. There is noise in temperature. Signal has noise. It's not a steady thing. There's noise around the basic value of the signal over time. There will be noise up and down, amplitude of noise. We have to filter out the noise. Okay? You have to be clever enough to know how to set that filtration out and get the noise out of traffic or temperature, for example.
2 more minutes.
Data is not equal to information. 2 minutes left. The application to bridges, I need 5, 7 minutes. So the load rating, fatigue monitoring, cable force tracking, and long-term deflections are typical uses, very typical uses and critical uses for bridges. Apart from other things, these are critical uses. Fatigue is a silent killer, you'll never know, and especially for steel bridges. Here I'm giving an example of an arch bridge, and you can see the type of sensors, you can see the requirements, where they're instrumented on the hangers and on the tie and the cross beams. So hangers for force monitoring, arch super strain and temperature, decking, deflection, vibration. Similarly, you can see the drag sensors, where they're located, how they're instrumented onto a bridge, which is an arch bridge. Arch bridges, the hangers are very critical, and the rib stress, the arch rib stress is very critical. So force in the hanger to be monitored and arch rib. Here I'm showing you what a typical monitoring of a suspension bridge would look like. I'm going to share all this with all of you also. This is mostly for information and setting the scene. Golden Gate Bridge is a classic example of how a non-instrumented at start structure was to be instrumented later by intervention, and what we learned from it, And what we learned by processing the data that we got in recent time, sensors were installed, the data was collected for wind speed, seismic activity, highly seismic zone California, and traffic load data, traffic lorries had changed over time. And the benefits is the improved structural integrity, reduced maintenance cost, and of course the cables which were corroding, which we could not see, we could not know inside the cable, that we were able to detect. Okay? And saved an estimated 5 million in repairs at that time when it was done. So monitoring on iconic bridges like this helped transition SHM from research to real engineering applications. Okay? SHM enables understanding of global behavior under very real loads. So when to plan at the design stage, it's best to plan at design stage. Earlier, you plan introducing an SHM, the better is tender and design, and the designer is a key person to set the thresholds. of exceedance. Then design philosophy, what do we want to measure, what do we want to know, how we measure it, what are the required accuracy, what is the redundancy and robustness in the system. SHM must not be purpose-driven, okay? Must be purpose-driven, not sensor-driven. Just instrumenting it blindly has no sense. You must know what you're looking for and target those locations and that type of instrumentation. Limitations, historically it was very high cost. Costs have collapsed. In fact, costs of data storage have become very, very cheap. Data interpretation gap. We don't know how to interpret the data of some of these things. There's over-instrumentation sometimes, and these systems many a time fail due to lack of clear objectives, what we want to measure, why, etc. So, clear objectives. The work of IABSE is in its task group, what we call 5.1, Structural Health Monitor to Bridges from Research to Practice. Okay, they are coming up, they realized that there is a huge gap between research and practice, and they want to bridge that gap, okay, by coming up with an international guideline document, okay. And it will also have recommendations for asset management workflows, data management, application, installation, everything complete. It will be an overall guideline document which can be used globally by the best experts in the world writing that document. It is already in process. It will take about 2 years for it to finally come out, from now as I see it. And here is the person who's a chair, and you can see Sachin from South Africa is also of Indian origin, is the vice chair of this. And these are the ideas of this to come out with a white paper shortly, looking at the global, what is happening all over the world, and to bridge the gap between research and practice and how they want to move ahead. Okay, I'll give you 2 case studies. We have how much time? Can you add signature?
Only half minute.
I can't in that much time. So signature bridge is a bridge I worked on. It was instrumented at the tender stage itself. What we wanted was laid down, the specs, the BOQ, the technical requirements, everything was laid down in the tender, and then it was instrumented. And I'll just quickly take you through the schematic of how it was instrumented. And there you can see the bridge talks on the right you see the office of the client. The bridge talks wirelessly to the office of the client where all the data is housed and stored. It beams up in the net. It goes into what I call luminiferous ether. It goes up into and anywhere in the world you can monitor the state of this bridge today. And it is being monitored for the past few years by a company called Madiba, who installed all the various sensors. I won't get into all the various details, but broadly, I'm just showing you how such a bridge was instrumented and what type of seismic zone 4, displacement sensors. Tilting is very important because of the asymmetric cable stay bridge. It's a very asymmetric cable stay bridge, and it's almost like it is out of balance, you know. And as my friend Hegde says, it appears to always be in perpetual motion. So, this instrumentation became very critical because it's a steel pylon. It's a steel orthotropic deck. It is, temperature issues for steel, fatigue issues for steel. The whole pylon is itself in steel under full compression. So all these issues became important, and we had to instrument this very judiciously. It is not over-instrumented at all. It is instrumented beautifully, and this is a lesson for all to learn about how to do something right, how to do the instrumentation right, and how the warnings were set, and where it helps us. It helps us in terms of increasing safety, maintenance, earthquake monitoring, and ensuring a long service life. Challenges faced and overcome, limited amount of sensor data management and electronics in the site. Delhi, we lose electricity now and again, and all those kind of problems were overcome. And it shows that the project demonstrates how modern sensor technologies can help manage large infrastructure safely and effectively. Okay, detects damage early and supports efficient maintenance. So these were all the goals. The rail-cum road bridge, India's first rail-cum road bridge, Bogeybill, which is fully welded and has a composite road deck. So the road is composite at the top, okay? And it's a fully welded, so when two welds cross each other, long direction and cross direction, it becomes what we call a very high hotspot zone. So stress concentration goes up, stress riser goes up, and you have a tension situation, especially if it's on the tension side, where you will have a lot of fatigue accumulation over time. And say if it's a weld or fatigue-prone detail, it will go much earlier than what you think its design life should be as a steel element 100 years. It may fail even at 20, 30 years due to accumulation of fatigue and its effect upon that fatigue detail over time. So this became very important, and this bridge was launched 10 spans from one side. And the first and the last spans in this 10-span launch, it was push launch from one side. So on one part of it. So there they had to do extra instrumentation, both for the front and for the back, where extra strengthening was carried out. And 2 more spans elsewhere in those 36 or 32 spans, whatever, 125 meter each span is 125 meter long, was done. And here we could see we monitored fatigue, we have monitored large deformation and buckling of elements, etc., out of planeness happening. We can catch that incipient out of plane. We have picked up certain elements, and there are only 4 spans out of nearly 36 which are instrumented. It's not instrumentation of the whole bridge. So that is important, which ones you chose, how we chose those 4. Okay, and vibration becomes important in a railway bridge, excess dynamic effects due to the train, and also in pedestrian bridges and steel bridges in particular are plane to, and we have to also monitor vibration. Okay, so the launching I explained to you, the launching, so even during construction, monitoring was done. Yeah, just a few minutes, I'll finish. Now, so the monitoring system was installed for checking safety and stability at all times, and for both highway and railway loading, various types of sensors and instruments were used. 921 sensors of 21 different types on 4 chosen spans were used for this particular bogie beam. And you can see the working, how the data is collected, then the data is transmitted to, and then analysis can be done using that data, and the design parameters itself are being verified. And fatigue accumulation is being gathered to provide historical record for the future, and we developed a real understanding of fatigue and fatigue details, which have now been instrumented for rail-cum-road bridge. Okay? So these are some of the very important features that were there, and of course, it helps to ensure we get our service life of 100 or 120 years. And being in a seismic zone 5, it is a very particular requirement to instrument. The challenges always have to be overcome. You're working in a harsh environment over the Brahmaputra, very tough river to work on and over. There's a lot of data management and continuous management of that data. And very long steel trusses have their own problems, especially with respect to temperature and so on. So again, this is a project which demonstrates the importance of sensors and real-time monitoring, large infra projects. In our own country, this is being done. A very effective system has been put in place. What are the emerging trends going forward? AI and machine learning, use of digital twins, so that once you build the digital twin, you can instrument the digital twin virtually, and you can understand behavior on the virtual twin. But there has to be a feedback loop for your digital twin has to be correlated to your FE model, so you correlate all the data with it. Yeah, you calibrate it. You calibrate your digital twin and the FE data, FE model you have to be coherent, and then you can play around only with the digital twin. What's the future? Just 2 minutes to conclude. The vision for the future: real-time decision systems, predictive maintenance, autonomous monitoring, SHM for smart infrastructure. Key takeaways: SHM is moving from inspection to intelligence, decision-making and intelligence. Bridge needs targeted monitoring. We need to monitor, we need to develop good and targeted monitoring systems. Don't do excessive instrumentation. The future is data plus AI plus engineering judgment. Before I close, I just want to read something which I had written today morning. I don't know if I find it, and if I do, I'm lucky. Yeah. So I'm going to leave you with some, closing thoughts, right? Structures will not, in the future, structures will not just be monitored. They will communicate their condition to you. In fact, even it will suggest we should do this. You as an engineer can then exercise your judgment. It is reaching that stage today. They will communicate their condition to you. Okay. Let me leave you with a few thoughts. SHM is not about installing sensors. It's about enabling decisions. Okay, we're talking about decision making. The sensor is an adjunct. The decision making is to be enabled. As engineers, our responsibility not end with design and construction. It extends to performance, safety, long-term sustainability. So SHM is the powerful predictive tool to support this responsibility the engineers have. Thank you very much. I look forward to any questions you may have or in the break.
We are a little bit going late, and we can, any question and answers outside while in the tea break we can take. And Dr. Harsha, your insight into the SHM is extraordinary. And as you said, you should not structure talking to an engineer, but I say an engineer talking to the structure. Like it is a doctor holding its two-way. Yeah, doctor holding the hand and trying to know the disease instantly. Like that, I normally tell our other structural engineers, when you go to the site, hold the bridge, talk to the structure in such a way that you will find out any disease, like your cough or the fever, whatever is there. You can easily make out from any structure what it is undergoing. And one more point you made, fiber Bragg rating. That's not much. Alok Bhaumik Savidar, fiber Bragg rating we have used in Calcutta. It is extremely useful. It is very useful. Kindly note down fiber Bragg rating. You can measure strains and many other parameters using that continuously. It is about 2 mm thick fiber, and you can install many of the sensors into it. Then one more point, actually, in fact, I took from last your lectures. Life of the sensors, whatever the sensors you are going to place inside, is not equal to the life of our structure. So on that, we will have to talk to these sensor people to see that their life is enhanced to that of, it may not be possible, but they must try. It is just like our expansion joints and bearings, where these two parts are not equal to the life of the structure. And as far as this conference is concerned, as you said, anybody can see the readings in the SHM from anywhere in the world. Right now, our conference is being telecast throughout the world. In fact, your Zurich office has already given the details to all their members so that in live they can see our conference and hear whatever we are doing it. Go ahead.
Thank you, sir. Thank you so much, Dr. Ashavardhan Subbarao, sir, for giving an invaluable insights about data analytics and structural health monitoring. Every day, as we all know, new technologies emerges in this rapidly evolving era, and we have to think ahead. And the passion towards shaping young minds is truly inspiring. Thank you so much. And now request Mr. Mohan, sir, to honor our esteemed speaker with a flower bouquet. Come on, everybody, please give a huge round of applause. Thanks again. Thank you, sir. Ladies and gentlemen, it's a true privilege and proud moment to introduce the personality who has not just built only structures but shaped young minds and inspired generations. Yes, Professor Ananta Ramaswamy, a distinguished professor from the Indian Institute of Science, is a name that resonates with excellence, dedication, and innovation in the field of civil engineering. With decades of relentless contribution to research, teaching and nation building. His work in structural engineering, advanced materials and infrastructure safety has made a lasting impact, not just academia, but in the real world that we live today. He has authored 100 plus research publications in leading international journals, conferences and book chapters. He has led and contributed 20 plus major sponsors research projects collaborating with prestigious organizations like ISRO, DST, BRNS and international institutions. He has held multiple prestigious editorial positions. He is not just an academician but a visionary leader who continues to push the boundaries of engineering and inspiring young minds to dream bigger, bolder and build stronger. It's an honor to have you here, sir. Thank you so much. Please take a stage, and stage is all yours now.
Professor, before here, to the audiences, one information is myself, Jay Prasad Saab, Anant Ramaswamy and my teacher, B.R. Srinivasmurthy. All four, we got 4 medals from Indian Roads Congress for one of the bridge we were rehabilitated similarly in Bangalore. And the whole design was done by the institute, especially under Anant Ramaswamy. It was an excellent thing, and already about 20 years passed, and it is expected not less than 78 years life for the structure. Sir, please go ahead, sir.
Thank you. Thank you all for giving me this opportunity to talk to all of you. My presentation today will look at a couple of things. One, to look at tools for condition assessment. Much of it has already been presented by Dr. Harsha, and some examples that motivate you, both old structures and new structures. What has been talked about is new structures, but what we need to also know is what is the current condition of things that exist. So a brief example of that, and some other challenges that we came across. Please do stop me if I overrun on time. We have a habit of doing that. Okay, so the first one is something that we did some years ago, but connected with railway bridges. These are old bridges where they wanted to increase the axle load from 22 to 25, and they aspire to go higher. So this is something that we were involved in the Southwestern Railway region. I guess similar projects were also given to various other organizations in India, where they were looking at different regions for bridge monitoring. So the challenge was, of course, these bridges were built back in the 1880s. I will just show you. One of them is this Dudh Sagar waterfall bridge, built in the 1870s by the Portuguese, and then handed over to the Brits. And then rezonation and changes in gauge from narrow gauge to meter gauge to broad gauge to double lining. So many things came in this particular bridge. If you go and look at it, it's on a curved alignment with a gradient 1 in 30. And the double lining put the whole thing out of symmetry with the arch barrel. So that was another intriguing feature. And of course, there were no drawings. So we had to actually do some measurement at site to get a rudimentary model to start with, and then with measurements using known loads and ambient traffic and goods traffic, get an assessment of the current condition. So unlike health monitoring, this was an exercise in condition assessment, which was episodic. When you streamline it and do it continuously, it becomes health monitoring, which we didn't get into. This was itself a task. You can see this is actually a 7-span arch, of which 5 were partially closed, and only 2 were active with the water going through. So we had to instrument the 2 from beneath and also from above in a manner that we could get a sense of what is happening. And of course, the railways were interested in looking at various kinds of signals, strains, LVDTs, accelerometers, tilt, acoustic emission, temperature, and they had their own set of loads. They wanted static and dynamic, measured and unmeasured, diagnostics performance with NDT and acoustic emission, Cores and samples were limited because it was a live bridge. So one of the things we ended up doing was modeling. And of course, you will see on the left side, we have put springs to kind of say that those are partially closed arches, and we were trying to estimate the parameters that reflect the possible partial movement in the lateral direction. The challenge in bridge monitoring was primarily to understand the bearings. The railways was keen to understand that if we brake, if we accelerate, the kind of tractive efforts that are imposed on the rail and transmitted to the bearings is the key. The rails themselves are upgraded periodically, the sleepers are upgraded, the connections are upgraded, but in the bridge your bearing is the key element there, and they were interested in knowing how the loads transfer to the bearings. So we had to instrument different regions all the way up to the bearing to get a sense of what this system was actually doing. And of course we couldn't core sample. This was a stone facing masonry arch bridge with internal rubble filling. And when we started measuring and then subsequently modeling, we were able to model it close enough, but there are issues inside that you really don't get an understanding of because there were many interventions over the 100+ years in gauge conversion, in maintenance. They have made changes and the documents are not there. So, for example, this is two-span. You can see the plan view. We ended up locating accelerometers, strain gauges, LVDTs from below with an independent support from the ground, and then also the tilt on those piers. And then AE systems that Dr. Harsha was mentioning. We also mounted 8 censored, wired acoustic sensor, just like the way you use a stethoscope on a human system or an ECG system to kind of track your heart. This is something similar where you are trying to get a coordinated assessment of any event that is taking place inside, and you would have to filter the sounds or noise below which you drop off and high frequency stuff that you may have to subsequently diagnose out to say that it is static or something else. One of the biggest challenges in field instrumentation is the power source. Our our data acquisition system was powered on batteries, and periodically we would charge the batteries with a AC voltage line that is there, which had a 55 cycle noise. So we couldn't really run it on the free power source available, but had to switch back and forth to our own system while we were acquiring information. This is another suite of bridges. This one is near Hospet, the truss bridge. So you can also see how we instrumented it in the water canal using drove a post and had it instrumented, and then subsequently we had 2 different kinds of LVDTs, the plunger spring type and the capacitance type. What you see here is a capacitance type. You also see other bridges, the Toranagalu bridge, where the iron ore belt was one of their primary requests because they were trying to increase the axle load in that region. And we were able to do some amount of instrumentation and monitoring and model updating. So while one challenge is instrumentation and it's fast forward, the other challenge is model development and it's fast forward in terms of filtering, in terms of model updating, and so on. There is a tandem of developments in structural health monitoring, both in terms of the way you measure and the way you model, and then the way you talk to each other. Hybrid simulation is another science that is developing. For example, in labs, you can test components and then have the whole model sit on your system and feedback from the measurement to the model and from the model to the system, so that you can handle certain features that are otherwise not measurable. This is another bridge with a 40-meter height. We were not able to measure deflection. So what we ended up doing is go into the bridge. That means from the middle pier, we walked, had planks put, walked into the box, and then added strain gauges at various heights so that you would get a curvature information along the span and use that to kind of estimate the deflection that is being developed as the train moved. So we actually had a design train in this that we eventually developed. What you see up there is one such example. Sleepers that we knew were meeting certain weights, a suite of such things from 200 tons to 100 tons with gradation, and then box and wagons which were loaded to 25 ton, an engine which we had some idea of its axle loads, and then speeds. So we did influence line, we did a speed test to get the dynamic augment, and then we moved to a full-fledged 58 box goods train with multiple engines. Given the gradient, the train itself was very intimidating to see, with 7 engines, 5 in the middle, 2 in the front, 1 in the back, to kind of give it the necessary stability. And then the challenge that RDSO set up was brake on the bridge, start from zero on the bridge to kind of get a measure of what is the forces going into the bearing. Eventually, during that test, we had a coupler failure and we had railway tracks cabbing. Because it slipped, the engine has a way of putting sandblast, and then when you start tracking, it develops the necessary tractive force, but it also does a little bit of damage. So they had to change those rails almost immediately because it is a live section. So to cut a long story short, we were able to do some amount of instrumentation, selective, based on the kind of suite of tests. One particular test was also called the brake binding test. The last 4 wagons are locked, so it has to be dragged and not rolled. So that kind of puts all kinds of tractive force on the bridge system. I moved to another problem. This was posed to us by the nuclear industry. They have a lot of these nuclear power plants with, now of course you're talking about fast breeder reactor, but this is an older system where they had the calandra inside, the primary containment which was pre-stressing, and the secondary containment which is RCC. One of the biggest problems with concrete is loss of pre-stress. Creep, shrinkage, relaxation will drive all the pre-stress or a good share of it away from it. So they have these nuclear power plants which are more than 50 years old, and the cost of decommissioning is as much or more than the cost of commissioning a new plant. And the question posed to us is, how can we estimate the extent of pre-stress loss that is taking place? Suppose you have the mixes available to you, make those mixes, conduct a suite of experiments at different conditions of humidity, temperature, combinations, calibrate your model, and then make an assessment on representative slab sections that will tell us what is the kind of pre-stress losses that take place if they are treated in similar condition. So I will just take you through the kind of model that was developed is multi-physics. So the concrete, as it hardens, will hydrate, will lose some of the moisture. There will be drying, it will lose some of the moisture. So there is a process much like our bones. If you have bad posture, over time you will have bad posture. So it is important that you get a sense of a system where there is no feedback like our central nervous system, but only through actual measurements. So you get a sense of the kind of model that we had to develop. One that looked at relative humidity inside the concrete, which looked at temperature inside the concrete, because as reaction takes place, there is a rise in temperature, which eventually dissipates. So the conditions outside and the conditions inside both matter. Humidity, temperature, vapor pressure, capillary pressure, and displacements. And the coupling that has to be built in so as to look at it in a multi-scale, multi-physics framework. Because I bring in multi-physics and multi-scale because it is also a fact that if I concrete poorly, all my aggregates will be one side and all my paste will be on the other side. Good concreting is something that distributes everything and you get a homogeneous material. So that is something that drives the kind of measurements that you get. Bad concreting will give you bad results and you will have to worry about it forever. So going forward, the kind of features that we built in: vapor pressure, chemical bound water, nonlinear properties, dry air, evolution, and then the processes: hydration, evaporation, condensation, desorption, etc. And the upscaling from micro, where the paste mixes develop, to meso, where the aggregate adds up, and the homogenization that we call concrete. So there are different studies that have been done, and we got into it and developed a model which looked at all of these processes, from solid to liquid to vapor, and the coupling across these physical phenomena, in order to be able to look at what is driving it. There is gas pressure, capillary pressure, temperature, displacement, and hydration. Hydration is like a load. As it hydrates, it changes the system. When you start mechanically loading, is added on in a coupled manner, so that your current condition therefore determines how much deformation takes place. You look at our code, creep coefficient at 3 years is 1.01, but if you load it at 28 days, your creep coefficient is 1.55. It is basically something that represents the whole process, and this is something that takes the whole thing forward systematically. So we had a lab, we have done this kind of testing in that walk-in moisture cum temperature control chamber, and we did some studies, both creep, shrinkage. First part, what I show you, is the kind of experiments that we did, and subsequently we also built in the model to look at it. Properties of, here I will stop and just tell you that the concretes that they asked us to look across: heavy density concrete, where you are replacing the granite with iron ore aggregate, and you also have iron ore sand plus regular sand, so that the density of your mix is controlled. Otherwise, your iron ore aggregate will simply sink to the bottom and you won't get a homogeneous mix. So then we looked at normal M30 concrete, fly ash replacement, fly ash and silica fume replacement, self-compacting concrete. So the matrix of different kinds of concrete that were used then and are continuously being used were considered as part of this test program. And subsequently we studied shrinkage and creep, and also the kind of parameters that played a role in these mixes, so as to be able to monitor. And you can see that our ability to monitor improved with the refinement we brought into the modeling. So you are able to actually get a measure of all of it. And most important, we also, in the process of the test protocol, weighed and measured changes in water loss. For shrinkage, if you want to get an assessment of the ultimate shrinkage, you must have data on the kind of water loss that is taking place. So that was something that we integrated into this, and we were able to predict shrinkage for different kinds of concrete. And subsequently, we looked at also the literature to find out if there are experiments that we could use as a reference, so that we don't get projected as biased with our own data. So this is one such example we found in the literature. Somebody had cast a beam, loaded it, and held the load for 1 year under certain conditions, and also measured the fluctuating humidity and temperature in that controlled environment. And they did this for 3 different kinds of concrete: one with normal aggregate, one with recycled aggregate, and one other example that I will show you. And then we looked at, from our model, what we could measure, because everything we couldn't actually measure and we had to look at what we got and calibrate it with what was reported. So what you see here is an example of what they reported. The 3 different dotted curves tell you that they have normal concrete, they have recycled, and they have recycled fine. Okay, so they recycled fine, recycled coarse, and they used normal. What you see in that data is your normal is right in the middle. When you start changing to recycled coarse or fine, it sucks some of the water in your system and it alters your overall behavior. So you need to actually have a good idea of what is the kind of moisture content you need to correct for if you are going to get the kind of concrete you want with normal if you are using recycled material. But to cut a long story short, we were able to model that. We actually had to do some additional numerical tools. For example, we had a large database from Northwestern which we used for calibrating the model, and then subsequently given the parametric distribution. You see, when you model, there is randomness. Your aggregates are random, your mixing process is random, the cement content is random, your conditions at which you are mixing is random. There are so many such parameters that feed in which are all random. Therefore, the outcomes are also likely to differ based on the randomness that prevails in this. So we had to have some statistical way in which we could report the mean value, the red line that you see or the yellow that you see, which is again giving you a confidence band around the mean to tell you that if my data is like this and my model is like this, my model is able to predict with plus minus 95% confidence bandwidth on my mean, which requires several simulations with parametric variation so as to be able to produce the kind of outcomes and then give you a kind of significance of your data and validation of your data model with the kind of experiments that were reported. Then we went ahead to look at the nuclear industry's requests. They gave us beam dimensions and slab dimensions. We have our, what you see down in the middle, hopefully the laser works. Okay, in the middle one you are seeing a slab 1.5 meter by 1.5 meter by 500 mm thick. So the idea there is that because of the thickness, the drying process is delayed. It is not like your normal beam or column that you construct in a building site, which dries up much faster. And therefore, we were interested in looking at creep and shrinkage in this with the idea of trying to get an assessment of pre-stress loss. And the test that we used was crack opening method. We had introduced a notch and then we would load it at various stages to find out at what stage there is the deviation to suggest the crack is opening. And therefore predict the load at which this crack is opening and then put the slab back into the chamber where we had controlled humidity and temperature. This is a kind of test we conducted over a couple of years. And based on that, we had data on creep and shrinkage. We had combined other tests that we had for validating our model, and then we used the model on this to get an assessment of what is happening to the post-tensioning. And based on that, we were able to validate the model for 5 years meaningfully so as to project for 50 years. See, if I have data for 5 years, I could predict for 10 years, 20 years, 30 years. If I have more data, I can predict for longer. So one part of the exercise was to understand how much data I need in order to predict for how long, and then use it and make a projection. So what you see is for 50 years, you can get a catch on what is the kind of losses that are taking place and why you need to safeguard yourself. Okay, so this is the second set of information I thought I should share with you, because a lot of post-tensioning is being done, a lot of metro work is being done. People are doing it in full speed ahead. So you also need to remember that post-tensioning comes with its own problem because we grout it. It's not that we grease it and keep it and we can pull out the wire and put in a fresh set of wires. Or we should make room for dummies which we can go and pull at a later stage. So pre-stress can be as much as 50%. The last problem that I will touch upon very briefly, I've got my red flag from behind, is on high temperature. This is an area that is important today as we go forward. Fire is something that we have always looked at as in the background, but fire is a load. People don't understand that mechanical loads are there, dead load, live load, partial live load, and along with it you have a fire. So there are critical components of your building or system that may damage more rapidly than you consider. If you look at many of the codes, they'll say, okay, you have a 2-hour rating if you meet a certain isotherm. But that isotherm assumes that the connections or the joints are outside the fire zone. But that's not the case. The fire zone is right there alongside, and therefore that gets damaged alongside with the rest of the system. And what you thought was 2-hour time zone becomes 30 minutes. I won't go into that detail. I'll simply move forward quickly here to show you that we did NDT and other kinds of tests to get an assessment of rapid degradation that takes place in concrete, and move to one final kind of test that we did. You can see, for example, with FRP coating. See, FRP itself will come away the next fire comes. So you really need a material that strengthens it with FRP, but insulates the FRP from a future fire. If you want to, you need a 1-2 punch. And therefore we looked at geopolymers. So we went ahead and did some testing. I will just skip through all the slides given the time warning I have received. We put a geopolymer concrete on top, fired it, cooled it, removed the geopolymer and tested it. And you will see that the geopolymer actually gives you additional time. You are seeing the kind of things that you have at control getting replicated at temperatures as high as 500, 700. Of course, fires go higher, but you have a little bit more time than you had without the insulation to the strengthening that you put in place. Okay, so SHM works. SHM plus model is important. Important thing is the engineer behind it, the decision-making process. Science in, science out, garbage in, garbage out. Thank you.
Sir, it was an excellent eye-opener, especially when we called you from the Indian Institute of Science, where we have a lot of respect towards your institution. And I still remember about 3-4 years back, one of the aqueduct went into distress. And when people came to you, you told no, we don't do it, please look for somebody else. And that's really appreciated, because the Indian Institute of Science is a world-class level organization, institution, where the research of that level is being done. And these ordinary aqueducts and all can be taken care by our regular engineers. And that's the way I think even the small WL square by 8 is now going to the bigger institutions, whereby these our other government organizations, they distract your research, wherein you are supposed to be in par with the best in the world. And I don't know, my request to the government organization, whatever small designs, proof checkings, or whatever such things can also be given to the same people who they have passed out from the institute or IITs, instead of giving to the IITs. With this, Professor, thank you very much for your eye-opener. And now let me hand over this to...
Please come, sir. Sir.
Thank you so much, Anand sir, for the very insightful and enlightening session. Yes, ladies and gentlemen, let's take a moment to appreciate our sponsors. Without them, this day wouldn't be possible. Have a look towards the LED screen.
In the heart of Krishna district, over a century ago, one man's vision changed the course of a community. Mr. K. Kotaya built irrigation canals not as a contractor by profession, but during the farming off-season, driven by a belief that infrastructure changes lives. From humble agricultural roots, KMV was born, a journey of growth deeply grounded in these values. Decades later, in 2007,
Thank you so much. And now request Dr. Harshavardhan sir and Ananta Ramaswamy sir to please take the stage, and we are absolutely honored to have you with us today. And I now request Mohan sir to please give the momentum and honor to our esteemed speaker of the first session. Come on everyone, please give a huge round of applause to our esteemed speaker. Dr. Harshavardhan sir is now felicitating by Mr. Burji. They are receiving a memento and flower bouquet from our organization. Come on everybody, please give a huge round of applause and appreciate their presence. And they are receiving Mysore sandal. It's a pride of our Karnataka. And Harshavardhan sir is also basically from Mysore. It's truly honor. And now request Mr. Ananta Ramaswamy sir to please receive the honor from our delegates. Thank you so much, sir, for giving your precious time. Come on everyone, please give a huge round of applause. And he is also receiving the momentum and gift hamper from Mr. Jai Gopalji. Thank you so much. Okay, so one more wonderful thing that I'm gonna share now. Yeah. Yes, so you'll get very happy because we are skipping a tea break now. Yes, it's not a joke, ladies and gentlemen. Believe it or not, we are delighted to share that this conference is being watched across the world, and we just got a message from Brindika Bose all the way from Switzerland and appreciating our seminar as a brilliant seminar and conveying that she is watching live from Switzerland. And we are really honored and proud to be present here to watch live now. Right? Please give a huge round of applause to yourselves for making this happen. Thank you so much. Okay. So I request each one of you to please wear an ID card. And also for the students, it's an important announcement. Tomorrow, attendance of the students is compulsory. And students, please wear the ID card. Thank you. So as we all know, today's theme, structural health monitoring, is especially fascinating because just like we go for a regular checkups to detect problems early, engineers today are giving structures for the same level of care. Using smart sensors, data analytics, real-time monitor, we can now listen to the bridge, understand the building, and predict before they become failures. And it's no longer just construction, it's a continuous care. So to start this session and to start an inaugural program, the conference is going to be very, very informative. So are you all excited? Come on, can I get a huge round of applause from your side? To set the formal tone for this prestigious occasion and to celebrate the spirit of progress, innovation, let us begin with the invocation song. I would like to call Manasa for the invocation song. With a huge round of applause, let's welcome Manasa on stage. Manasa, idhar you can go ahead. So if you want this one, you can hold that. It's fine. जय गणेश गणनाथ दयानिधे जय गणेश गणनाथ दयानिधे सकल विघ्न कर दूर हमारे सकल विघ्न कर दूर हमारे जय गणेश गणनाथ दयानिधे लंबोदर गजवदन मनोहर लंबोदर गजवदन मनोहर कर त्रिशूल परशुवर धारी कर त्रिशूल परशुवर धारी ब्रह्माधिक सुर ध्यानत मन में ब्रह्माधिक सुर ध्यानत मन में ऋषि मुनि गण सब दास तुम्हारे ऋषि मुनि गण सब दास तुम्हारे जय गणेश गणनाथ दयानिधे जय गणेश गणनाथ दयानिधे सकल विघ्न कर दूर हमारे सकल विघ्न कर दूर हमारे जय गणेश गणनाथ दयानिधे. Thank you. Thank you so much, Manasa, for setting a auspicious tone for this wonderful conference. We'll now continue by honoring the rich heritage and culture of our stage with the Karnataka state song. I request each one of you to please kindly rise and respect.
पतंग
And now with a deep sense of pride and patriotism, let us present Vande Mataram, a tribute to our beloved nation. Play.
Vande Mataram, Vande Mataram, Sujalam Sukhalam, Malayaj Sheetalam, Sasya Shyamalam Mataram, Vande Mataram, Shubhra Jyotsna Pulakitayamini, Pullakusumita Drumadala Shobhini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Bolo Bharat Mata ki, Bolo Bharat Mata ki, Vande, Vande. Thank you so much. Please take your seats.
Bouquet to Manasa, singer. One bouquet.
I now request Ms. Vinita Madam to please appreciate our singer Manasa Ma'am, who has sung the invocation song. Come on everyone, please give a huge round of applause when someone is appreciating. Thank you so much. So, light symbolizes knowledge, wisdom, and new beginnings. To mark the formal inauguration of this conference, I now request our esteemed dignitaries to kindly come forward for the ceremonial lamp lighting. And now request our esteemed dignitaries. First invite, it gives me immense pleasure to have him with us today. Mr. V.K. Rajawat, sir, Director General, Road Development and Special Secretary, Government of India, to kindly grace the stage. Come on, everyone, please give a huge round of applause and join me in welcoming V.K. Rajawat, sir, Director General, Road Development and Special Secretary, Government of India. And now invite Shri Burji, ING-IABSE, Karnataka Center to kindly join us on stage. And now request Shri Jai Prasad, ING-IABSE, to kindly grace the stage. I now request Shri R.K. Jai Gopal, ING-IABSE, Karnataka Center, to kindly join us on stage. And now invite Shri Lakshman Singh, KRIDE, to kindly grace the stage. Shri Lakshman sir, please come up on stage. Come on everyone, with a huge round of applause, let's welcome Lakshman sir on stage. Is he present? Is not there. And I request Dr. Harshavardhan Subbarao sir, President, International Association for Bridge and Structural Engineering, IABSE Zurich, to kindly come forward and grace the stage. And now request all our dignitaries to please light up the ceremonial lamp. Candle is here.
Shubham kurutvam kalyanam, arogyam dhanasampada. Shubham kurutvam kalyanam, arogyam.
Come on everyone, please give a huge round of applause. May this light guide us towards the knowledge, innovation and excellence.
Deepajyotir namostute, Deepajyotir namostute, Deepajyotir parabrahma, Deepajyotir janardana, Deepajyotir parabrahma, Deepajyotir janardana, Deepo haratu me papam, Sandhya deepa namostute. O deepa brahma rupastvam, Jyotisha
Thanks to all the dignitaries over the stage. To begin the inaugural address, I now invite Shri Burji Sir, representing ING-IABSE Karnataka Center, to address the gathering.
Dignitaries on the dais, Shri V.K. Rajawat, DGRD and Special Secretary to Government of India, MOTH, Dr. Harshavardhan Subbarao, President IABSE of Headquarters Zurich, Mr. R. Jayaprasad, and Mr. R.K. Jayagopal, and eminent and distinguished engineers gathered here, and our guests who are participating in this international seminar online. My heartfelt welcome to Sri V.K. Rajawat, Director General, Road Development and Special Secretary. Sir, it is our pleasure and an honor to have you here with us as chief guest for this international seminar. In spite of your busy schedules, you have agreed to accept as chief guest here for this wonderful occasion. I welcome you on behalf of the Karnataka chapter of ING-IABSE, sir. And also a warm welcome to Dr. Harshavardhan, sir. Already he has been welcomed and already given a keynote address also to all the engineers here. Anyway, on behalf of Karnataka chapter, I welcome him also, sir. And I welcome our R. Jayaprasad, former engineer-in-chief and also chairman of several state-level committees, and he is our backbone, and also he is also referred to as Pitama in engineering here for Karnataka government activities. So with his initiation, we could able to do some activities in this organization and supported by Mr. R. Jayagopal also. I welcome Sri R.K. Jayagopal, Secretary ING-IABSE. On behalf of the ING-IABSE, I welcome the speakers as well as all the engineers who have come from government organization, NHAI, Government of Karnataka and Government of India, and students who are representing from different institutions, KRIDE, BMRCL, and all practicing engineers and consultants. And I also invite the media. As you know, today's topic we already started regarding the health monitoring of bridges. And today we will be having in-depth knowledge we are going to have now. I think we expect our keynote speakers and all the speakers to enlighten us about the advanced technologies and share their experiences and challenges ahead in this health monitoring of structures. And just about the IABSE, I think all of you know, as already explained by our MC here, IABSE is a scientific and technical association comprising of members from about 100 countries, and it was founded in 1929. Its headquarters is in Zurich, Switzerland. And it is our privilege and happy to know our first-time president who is with us now. Please give him a good round of applause. And this ING, that is Indian Group of IABSE, that was formed in 1957 under the patronage of our Government of India, MORTH, and its headquarters in Delhi. And our Karnataka chapter started in 2019. And this is a regional chapter. It is formed to bring together all the academicians and practicing engineers together in sharing of their experiences and knowledge. And to inform a little bit of the events which have been taken place here in the Karnataka Center, really we have convened about more than 7 events plus 2 workshops on behalf of the Karnataka Center. Just to name them, first event was on 7th of December 2019. That was a technical talk on bidirectional payload testing. And second event on 23rd of January 2020, that was regarding replacement of stone pitching, riprap, and latest global trends in the bridges, deck water proofing for concrete and steel bridges. And third event happened on 22nd of October 2020, learning from failures, RE walls, design deficiency and rehabilitation. And fourth event on 5th of December 2020, that is again a technical talk on construction, sequence specialized testing methods adopted in cable stayed bridge at River Zuari, that is at Goa. Fifth event on 16th November 22, that was one-day seminar. That was on resilient maintenance and rehabilitation of critical structures. And sixth event on 21st of March 2024. That we have covered the topics on underwater investigation and rehabilitation of structures, sensitive investigations using sophisticated measuring instruments, rehabilitation of 65-year-old suspended span, Normandy Bridge at France, given by our Jai Gopal. Seventh event on 9th of January 2025, we conducted a workshop that is for the introduction of limit state design of bridge foundations, design and construction of UHPFRC, ultra high performance fiber reinforced long span bridges, construction of for long span girders, introduction of wireless method in instrumentation in state pile loading testing, quality control by cross-hole sonic testing of piles. And the 8th event on 7th of May 2025, that was a workshop on the use of sophisticated software in the design of bridges and structures. And regarding the topics to be discussed, our Jai Gopal Secretary would address the gathering here. I once again welcome one and all to this seminar. Thank you.
Thank you, Buji sir, for such a warm welcome, and I wholeheartedly welcoming you to the conference. Come on, everyone, please give a huge round of applause. Now, it's my proud privilege to introduce a distinguished engineer, visionary leader, and a dedicated public servant, Sri Ramakrishna Jai Prasad, whose remarkable contribution to the field of civil engineering and national highways developments spans over 4 decades. And now request sir to please share his thoughts about this conference. Its passion towards the civil engineering is truly commendable and inspiring to all of us.
I had suggested my young friend to have oil. That's what I checked. Good. Respected DGRT of Ministry of Transport and Additional Secretary, our own Supervisor, Chairman of the ING-IABSE, or the main organization, young engineers, students and distinguished friends, particularly P.C. Rai, has come, and I thank him and his madam also for gracing the occasion. We are lucky to have Karnataka Center of ING-IABSE here. We should remember I.K. Pandey was instrumental in getting Karnataka Center. The idea of opening Karnataka Center is that our state is well known for producing brilliant engineers with Sir M.V. in the forefront. All of you must have been made known about Sir M. Visvesvaraya, his achievements. When I was in middle school, Sir M.'s biography was our Nandi trial. That is where I got impressed that I should become an engineer, and I have. Every one of you should have some aim. I want to become specialist in bridge, roads, structure, and so on. It is my privilege that I lived in the same era of Sir M.V. Maybe he didn't know that, or he didn't want to see us become engineers because he passed away the same year, 1962, when we graduated. The motive of starting State Center is for dissipation of knowledge, more so to younger ones, by seniors and guide them. Sir, I appeal to the senior engineer to take your junior along with you. Please don't go with a raised head with your counterpart. Look to them, train them, teach them. They need basic guidance in what engineering is, what bridge engineering is. We also propose to have a seminar in Dharwad, wherein we have a association of structural engineers with 150 practicing engineers. I pray that thank you for your time, and also I pray that whatever is discussed in the morning and subsequent 2 days will help you to improve your knowledge and have some aim in life. I wish you all the best of life, and I thank the dignitaries on the dais for giving me an opportunity. Thank you.
Thank you so much, sir, for sharing your kind words. Come on, everybody, please give a huge round of applause. ಎಲ್ಲ ಕೈ ಉರಿತಾ ಇದೆ ಅನ್ಸುತ್ತೆ ಅಲ್ವಾ ಕ್ಲಾಪ್ ಮಾಡಿ. Okay, thank you so much. Now, it's my honor to invite Mr. R.K. Jayagopal. Is a renowned structural engineer with over 47 years of experience in bridge and structural engineering. He is the chairman of the Technical Advisory Committee of B-SMILE Greater Bengaluru Authority and a managing director of Struct Geotech Research Laboratories Private Limited. May I now request Mr. R.K. Jayagopal sir to kindly take the mic and address the gathering. So you look so young, and I couldn't believe that you have a 47 years of experience.
Thank you. It is the privilege of our Karnataka Center to have our Director General of Road Development, MRTH head, the head of the all roads here today. We are overwhelmed and we are extremely happy when I got the message from the Ministry of Road Transport Highways headquarters to that he is coming and to the conference. We feel extremely happy, sir. And such encouragement will certainly push us into carrying out further good conferences. Then, Sir Jayaprasad sir, actually he is the backbone of all our activity. I'm totally surprised actually at the age of about 83, 84, still he pushes us, do some seminars, do some exercise, do workshops, carry out, bring a new technology, whatever it comes from the abroad. Or last time, in fact, he inquired about not less than 10 times when I went to Copenhagen to get some good speakers also. Then we have Mr. Burji. He is a speed master where he pushes all of us to carry out the works, whatever we are already doing. And of course, here we have the KRDCL and not less than our president, Mr. Harshavardhan Subbarao, which we have already told, he is very much encouraging. Coming to this present strength of, I would like to tell you about the audience. It is exceeding about 400, but what I see here is approximately, but registered has already crossed 500. 500, many engineering colleges, departmental engineers, private engineers, and the conference program is live telecast. In fact, Brundika Bose, who is from the Zurich, she already sent a message that we are already looking at your conference. Excellent, she has told. And more and above that, she told, when I went there last time, she told how we were able to carry out such a big conferences of exceeding 400, 500 people without charging any money on the audience, because IABSE depends on such audience only. Here, absolutely free. What we want, the entire committee, our committee is gather as much of technical knowledge as possible. That's the only thing. We don't charge anything. And going back slightly, after relentless efforts for about 2 years, we got ING-IABSE on 9th May 2019. 2019 we got. Before that, 2017, I was struggling hard, convincing the ING-IABSE Delhi to give us a branch in Karnataka. They said, no, we are not giving because that's not the practice. But with a lot of pressure, all our earlier DGs who were there at that position, ministry, especially Mr. I.K. Pandey, Mr. G. Sharan, Mr. N.K. Sinha, of course we have our R.K. Pandey here. They made a resolution to give a branch to the center, and to whatever they expected, we are exceeding their expectations. As of now, as our president has said, we have done many very good conferences, especially the technicals, like the limit set design of foundations, where still we are, IRC is concluding their, that IRC 78 is getting into the limit set design from our regular designs. And bidirectional pilot testing, which we have gone through. Then many other structural, like recently we did that software program, Sophistic, especially we conducted in one of the engineering colleges in Bangalore. It was excellent. Then conference on emerging technologies for design, construction and maintenance of ultra durable structures program conducted on 30/31/2025 attracted full capacity audience. The theme of the program was to enhance the durability to 200 years. which way? In IRC, we fix 100 years, whereas what we learned from Japan, we went to Japan, learned something where the bridges are built for 200 and beyond years. Based on my attending the IABSE conference in Tokyo, we cannot keep on constructing costly structures with low durability. In fact, the program on July 25 was in Japan. It was an extraordinary. We have dwelt with AI, digital twins, IoT. Last year, these AI, digital twins and IoT were the subjects what we dwelt here. And even now, living that IA, balance all being deliberated in Copenhagen. I am happy to say that KRDCL Technical Committee, where we are sitting here, this is the office of the KRDCL. We are in the 5th floor, whereas they are in the 2nd floor. I am one of the members. And Jay Prasad, he is the chair. We have introduced many subjects, short and sharp subjects like settlement behind the abutments. We have introduced some special arrangement where to arrest such settlements. And also we have taken care to change the joints, expansion joints to strips from strip steel to slab seal. Because strip seal gives a lot of noise. And being chairman of the technical committee of B-Smile, it is a Greater Bangalore Authority, we have introduced 112 kilometer length of urban roads, urban elevated road using ultra-high performance concrete. In fact, this ultra-high performance concrete was suggested by our MORTH Minister Nitin Gadkari ji to our Deputy Chief Minister to go ahead with such technology which is latest. To the surprise of the fact that even the ultra-high performance concrete, it costs about 1 lakh rupees. For your information, it's about 1 lakh rupees per cubic meter. Whereas your M40, 35, they are all around 10,000 rupees per cubic meter. Then the cost will enhance. You may think that cost will enhance. Whereas in the B-Smile for the corporation, when we straight away work it out for 1 kilometer length of the road, with this ultra-high performance concrete, there is no change of the cost at all when compared to your M35 grade precious concrete. Because you are not going for the mid-level substructures. Foundation and substructures are eliminated and you are getting a 100-meter length of single span. So therein you save a lot and the cost comes down to same 10,000 rupees per cubic meter. So that's a fact which we have found out, and it is being it has gone to the cabinet committee for tendering and all. The present international conference has present what we have now for 2 days. We have 19 speakers, which has 4 number of speakers from abroad, 1 from Germany, 1 from UK, 2 from Switzerland. The subjects and the speakers are exceptionally good. In fact, we will have to observe the essence of the subject thoroughly. One specific subject I would like to tell here is usage of cosmic rays in our investigation of the structures. That is a absolutely new subject which I got it from the Copenhagen. And the conference has 4 from Karnataka, from out of Karnataka. As such, 11 speakers are from Karnataka only, which amounts to about 58% of the local talent being used here. In fact, I didn't know at all. I didn't know. Once we just completed all the exercise, how many are from abroad, how many are from out of Karnataka, and how many are from local, then I would like to tell you here, unless until such a talent is there, how do you expect the Karnataka, Bangalore becomes the software capital of India? It cannot be. So 58%, it's a good number. Then it's a hope that the audience will observe and enjoy the structural engineering, especially pertaining to the health monitoring. The entire conference with food and beverages, knowledge kit, kindly read those two books. One is Souvenir, one is Abundance magazine. Our chief editor is sitting here only, Mr. Hegde, who has done an excellent job in compiling that beautiful book. And I also would like to tell here one Mr. Ramesh Naika from IIT Dharwad. He has completed a souvenir. The articles what he has put there in the souvenir exceeds any other article which comes in our regular journals. Such a beautifully he has done. Kindly take some time, read that thoroughly. It will be really absolutely useful. Now with this talk, I would like to complete my small history about the work done here by our center and today's whatever progress we have achieved here. Thank you.
Thank you so much, Jai Gopal ji, for walking us through the conference and also the insights about the conferences. Okay, yes, ladies and gentlemen, it's a moment of great pride and honor to welcome our chief guest for today. Shri V.K. Rajawat, a distinguished technocrat and one of the key driving forces behind India's informative infrastructure growth, currently serving as the Director General Road Transport, Road Development and Special Secretary at the Ministry of Road Transport and Highways, Government of India. He has been instrumental in shaping the nation's highway network with visionary leadership and unmatched expertise. From spearheading landmark projects like Delhi-Mumbai Expressway during his tenure at NHAI, to advancing innovative infrastructure such as roadways through NHLML. His contribution are truly redefining connectivity across the country. Sir, your presence today truly inspires all of us who aspire to build a stronger, smarter India. On behalf of everyone present here, I extend my warm welcome with a huge round of applause, ladies and gentlemen. May I now request you to please speak few words, but not limited to few. Kindly share the info.
Good afternoon to everybody, dignitaries on the dais. It's my warm greeting and best wishes to the Karnataka Center of ING-IABSE on the successful organization of this important conference on health monitoring of structures. The theme is highly relevant in today's context in light of the unfortunate incidents of structural distress and collapse witnessed in recent years. The collapse of the Kali Bridge near Karwar on a vital trunk road in Karnataka is a state reminder of the urgent need for systematic and compulsory structural health monitoring across the country. Just as human health requires regular diagnosis and monitoring, the health of a structure must be assessed continuously so that timely preventive and remedial measures can be undertaken. Established in 2019, the Karnataka Center has in a short span conducted several major programs of impressive scale and impact, as already told by the earlier speakers. I am delighted to note that one of its events attracted nearly 600 participants, far exceeding the seating capacity and attendance that rivals even the international conference. It is a matter of pride that the present international president of IABSE, Mr. Subbarao, who hails from Karnataka as well, inaugurated this center in 2019 and is now witnessing its remarkable progress and stature. Situated in Bangalore, the intellectual hub and software capital of India, the center benefits immensely from the city's vision, ecosystem of innovation and technology. Bangaluru's global leadership in software exports and the pioneering initiatives of the Karnataka Road Development Corporation and Infrastructure Development provides a fertile environment for advancing modern engineering practice. Here I would like to request the participants and the speakers to tell something about the data safety, because now with this system we are acquiring the huge data of our vulnerable structures. And in the today's world of cyber tech and all those things, I think from the government perspective, there is need to have a proper security system for the safety of our data so that it should not be cyber attacked and pilfered to the other hostile countries. So I would like that some speakers should throw light on this of the safety of the data. Further, Dr. B.C. Rai just informed me that this system was initially installed in the Manvi Bridge in Goa under the aegis of the ministry long back, and also some system is also installed in metro in Kolkata in 1998. So this has now moved further, that we are going towards AI and other diagnostics tools is already there. I would also like to acknowledge the commendable leadership of Mr. R.K. Jayagopal, who is an EC and MC member of the main branch in Delhi, has played a key role in strengthening the linkage between the headquarters in Zurich, Delhi and Bangalore. His dedicated efforts have ensured that state-of-the-art program and global perspectives are brought to Karnataka. It is particularly encouraging to note that the center organized a program last year on advanced topics such as artificial intelligence, digital twins, and the Internet of Things technologies that are only now finding their ways into the mainstream structural engineering practices. This reflects the center's forward-looking vision and establishes it as one of the most progressive and dynamic centers within the IABSE globally. I once again congratulate the Karnataka Center for its outstanding contribution and wish the conference a very success. Thank you.
Thank you, sir. Thank you so much for your kind words and presence. And now, ladies and gentlemen, we are releasing a book of International Conference on State-of-the-Art Health Monitoring Structure, Indian Group, Karnataka Center. Come on with a huge round of applause. Now, V.K. Rajawat, sir, is launching the official book of Indian National Group, International Association of Bridge and Structural Engineering, Karnataka Center. Sovereign. Souvenir. So the book of Souvenir is being launched and releasing by our chief guest, V.K. Rajawat, sir. Come on, everyone, please join me. Thank you so much. And now request Mr. Jai Gopal ji to please felicitate our chief guest. Music. We are honoring our chief guest, V.K. Rajawat, sir. Thank you so much for giving us your invaluable time and being present here for us. Thank you so much for your gracious presence, sir. Receiving a gift hamper from Dr. Harshavardhan, and from all our dignitaries are felicitating our chief guest. Come on, everyone, please join me in appreciating with a huge round of applause, ladies and gentlemen. As we come to the close of this inauguration ceremony, I request everyone to kindly rise for the national anthem and give a respect for our nation. Sorry.
Yeah, if you can just sit for 2 minutes and listen to me, I'd be grateful. Okay, to all the dignitaries on the diet, so as that I don't waste so much time, I thank you all for being here and gracing this occasion, for allowing me to be with you. Jai Gopal, thanks very much. And to KRDCL and to the Karnataka Center, all the very best going forward from IABSE. I want to particularly thank, apart from Rajaut Saab, everybody knows him. Everybody knows Jai Prasad, his energy is infallible. Burji, you know him, he's been buzzing around everywhere here today. So Jai Gopal is that indomitable spirit. He's always at IABSE events trying to find out whom to catch to give a talk or where he can make some connection with some involvement so that you get benefit to this state. I'm very proud that I'm a part of this state. Born here, went to BMS College, went to Indian Institute of Sciences, and I have a great sense of pride that I became a president of this global body by being, my roots are here. So I am very grateful to be here today. I want to particularly thank and honor by standing in IABSE we have something called honorary member. It's the highest level that the entire the entire executive committee will choose. So in a year, we have select number. Amongst them in India, we have two very important members, Chakravarti Saab, who is not here today with us, but I'd like BC Roy Saab to please stand, because this is the highest honor this body can give anyone. I'd also want to use this occasion to honor Alok Bhomik, Vice President of IABSE. Alok, if you can stand and people can see you. He was earlier instrumental in setting up our BNS magazine, BNS journal, and handed over the reins recently to VN Hegde, who's now the editor. Hegde, can you stand? Also a product of this state. So this is what I wanted to share with you all. IABSE has a lot to offer. We have a national group body which has about 40-50 national groups. Yeah, 40-50 national groups. And we have number of task groups. If you go to the IABSE website, especially the young students and young engineers, there's a lot to get. You can join the task groups. The meetings are online, so there's no money to be paid. You will get knowledge, you can participate, you can contribute to the development of documents, papers, workshops, and it's a global. So this is how you grow. Professionally, this is how you grow. You sit with some of the greatest engineers, learn from them, contribute to them, and you come up with various documents that the IABSE produces, for example, or a workshop like this one. Then I want to tell you about the next IABSE event, which is going to be held in Guwahati. So the dates are, look, the dates, April 22nd to 24th, we are bringing the entire world of IABSE down to Guwahati, where we have booked a complete resort. So it's a new experience, not city type, but in a resort, in the nature, etc. So it's very exciting for us. And we are going to see number of those bridges, buildings, etc., which the Northeast, where our VK Rajawat Saab was there in NHIDCL, putting a lot of effort into Northeast of India for its upliftment, its its infrastructure, its colleges, its schooling, and complete, total infrastructure development. So we thought it best that we will bring this entire global bodies symposium. We have two events every year, a symposium in April or so, and in September or so, we have a Congress. So these are two fixed events. The next one is in Incheon in September, and in April, we are coming to, the Congress is in Incheon, in Seoul, near Seoul, in Korea. And then the next one is, of course, in Guwahati in the next year. And thereafter, we go to Milan. So this body is all, we are having events all over the world. And we have a lot of good information, documents, chances to grow. And I would request all young engineers to kindly participate. If you're here in Karnataka, be involved with Karnataka Center. Join as student members, even those who are practicing members. There's a lot you can get from IABSE. My whole professional career and growth, largely I owe to my development. Lot of it I owe to IABSE, my involvement with IABSE from very many years. So on that note, I want to say that even in this Indian national group of IABSE, we're doing a lot of things. We are organizing events, we are having an annual day, we are having guest speakers, we are organizing webinars. Recently, you can organize a webinar if you like. If you can get together and have a topic, you can organize your own webinar and IABSE will host it. So there are many opportunities for you in IABSE, especially for young engineers. So my appeal is, please take this opportunity, go to the website, look it up, and see how you can involve yourself with IABSE. Thank you.
We take this opportunity to present a bouquet to B.C. Rai.
It gives me immense pleasure to present a bouquet, flower bouquet, and respect of honor to Alok ji.
One more gentleman, Mr. Bhowmik. I thank him for accepting the memento and the bouquet.
Thank you so much, sir.
I take this opportunity to inform all of you that we have message from our own PWD minister, which is in the souvenir. We thank the minister for his good gesture. Thank you.
Thank you, sir. Thank you so much.
Thanks.
ಒಂದು ಸೆಷನ್ ಮಾಡೋಣ
NP ಶರ್ಮಾ ಸಾಕ ನಿಮ್ದು ಆಮೇಲೆ ಸೆಷನ್ ಒಂದರಲ್ಲೇ ಇರೋಲ್ಲ ಅದನ್ನು ಸೆಷನ್ ಒಂದರಲ್ಲೇ ಇರೋದಲ್ಲ ಅದನ್ನು
ಒಂದರಲ್ಲೇ ಬಟ್ ಆಲ್ರೆಡಿ ವಿ ಆರ್ ಲೇಟ್ ರನ್ನಿಂಗ್
ಒನ್ ಆಗಿದೆ ಸೊ ಸ್ಪೀಕರ್ ಒನ್ನ ಕರೆದು ಬಿಡೋಣ
ಕರೆದು ಬಿಡೋಣ
ಇವಾಗ ಬುರ್ಜಿ ಸರು ನಾಗೇಶ್ ಸರು ಡಯಾಸ್ ಮೇಲೆ ಕೂತಿರ್ತಾರಲ್ವಾ ಚೇರ್ಮನ್ಸ್
ಓಕೆ
ಅದಾದ್ಮೇಲೆ ಇವಾಗ ಬರೀ ಶರ್ಮಾ ಆಮೇಲೆ ಜಯ ಗೋಪಾಲ್ ನೀವು
ಅಲ್ಲ ಅದು ಲಂಚ್ ಬಿಟ್ಟು
ಬಿಟ್ಬೋಣ ಇವಾಗ ಹೋಗೋಣ Yes. So for the next 2 days, we will witness insightful keynote sessions, technical presentations, discussions, and knowledge sharing by some of our esteemed guests and experts from across the globe. And please make use of this opportunity. So let us begin this journey of knowledge, innovation, and inspiration. So yes, we now take a brief moment to acknowledge our valued sponsors who supports this event. Can I have a VT?
In the heart of Krishna district, over a century ago, one man's vision changed the course of a community. Mr. K. Kotaya built irrigation canals not as a contractor by profession, but during the farming off-season, driven by a belief that infrastructure changes lives. From humble agricultural roots, KMV was born, a journey of growth deeply grounded in these values. Decades later, in 2007, that legacy was formalized by Mr. KMV Prasad Rao, who laid the foundation for KMV Projects Limited. Then, in 2009, came a moment that changed the trajectory, the ING-IABSE Hyderabad project, delivered in 9 months, ahead of industry expectations, and signaled KMV's emergence. From a turnover of 5 crore rupees in 2001 to 3,222 crores today. From 400 employees in 2011 to more than 2,700 plus. From one district to over 1,200 project locations across 16 plus states. 30 million square feet of built area across the nation. Each number, not a statistic, but a measure of discipline compounding over time. A company that, at 3,222 crores turnover, still traces its operating values to a man who built canals in the farming off-season. That continuity is not nostalgia. It is the definition of staying grounded. From the ground beneath cities to the skylines above them, KMV builds across every layer of infrastructure. Each vertical, a different challenge. One unified capability. KMV's edge was never a single capability. It was the ability to run dozens of them simultaneously across the country at the same standard. Buildings has been the core of KMV for decades, and in that time, the best campus, Bangalore and Jaipur. Agiri, Kalyani. KMV delivered all 3 in parallel, each an 11-building campus, each housing 5 specialty operation theaters, each capable of serving thousands of patients every single day. In Aizol, deep in the hills of Mizoram, a 100-bedded teaching hospital, Raipans, built under terrain constraints and near total remoteness. Because healthcare cannot wait for easier terrain. Cities grow, communities need homes, and governments need an EPC contractor who can deliver at a scale that matches the demand. Across Andhra Pradesh, KMV built 76 lakh square feet of affordable housing under the AP Tidco Housing program. 19,000 plus apartments across 14 locations simultaneously using monolithic shear wall technology. Not one campus, 14 running in parallel. In Bangalore, the ING-IABSE program, mass housing at scale using aluminium formwork systems across 5 locations with speed and repeatability built into the construction method itself. Because a nation's housing need doesn't wait. And KMV has proven it can move at that pace. Precision is not optional in aviation infrastructure. Every element, alignment, surface tolerance, structural load, has a consequence that goes beyond construction. KMV's first entry into aviation came with the Puducherry Airport Terminal, an early signal of a capability that would grow significantly. Shivamoga Airport told a different story, a terminal building shaped around a lotus pattern standing seam roof, dual shade lacquered glass walls carrying local heritage in artwork. On February 27, 2023, the airport was inaugurated by the Prime Minister of India. Goa's Manohar International Airport, runway and taxiway. Most notable in the sector is a structure known across the industry for engineering precision at scale, India's first elevated cross taxiway at Indira Gandhi International Airport in Delhi. Also, KMV's first 1,000 crore plus project, marking its strong presence in the heavy infrastructure vertical. Not every structure is a building. Some of the most impactful projects KMV has delivered are the ones people walk through, cycle along, or gather around. The Healthway Solar Cycling Track in Hyderabad, India's first solar cycling track. A design and build project. 60 megawatts of power generation, 23 kilometers of cycling infrastructure, 15 amenities, transforming 64 acres into a solar-powered public space. The riverfront development in Shivamoga, 2.5 kilometers of promenade, open-air theatre and landscape public waterfront. The integrated sports complex in Habali, certified to FIFA and FIH international competition standards. Urban infrastructure that doesn't just support life in cities, it defines it. Modern industry demands facilities built to the tolerance of the machine, not the building. From aerospace manufacturing plants for Safran aircraft engines to Skyroot Aerospace's integrated facility, India's first private sector rocket design, manufacturing and testing hub. Each built for a client who cannot afford a margin of error. KMV's first metro project came in Jaipur, a defining entry into urban transportation infrastructure. From there, the scope expanded, and so did the ambition. 66 kilometers of national highway on NH 365, the Khammam to Devarapalli Greenfield Highway, and then the Raipur-Visakhapatnam Expressway, a 2.7 kilometer twin tube tunnel, 14 meters wide. For a company entering tunneling for the first time, this was not a cautious next step. It was a statement that KMV had the confidence to enter a sector others had spent years building into.
Give a thunderous round of applause, because this journey is truly inspiring. Now, let's move towards the next session. Are you all ready? There's no sound. Are you all hungry? You want break? No. We want next session, right? I think they all are excited for the next session to learn more. Okay, everyone, let's activate. Okay, come on. I'll say hi and you have to say hello loudly by raising your right hand. Everybody. Okay, are we ready? Hi. Hi. Come on, each one of you. Roof harogbeku, hang sound barbeku. Come on. Hi. High energy, come on. Hi. Okay, this is 3 out of 10 somewhere. Okay, let's go. Now, for the next session, I would like to introduce the session chairman, a distinguished personality whose vast experience and contribution to public infrastructure truly stands out. Shri M.B. Burji, former additional secretary to the government of Karnataka and chief engineer, has had an illustrious career spanning multiple key departments. His leadership has shaped critical projects across the Public Works Department, Karnataka Roads Development Corporation Limited, Karnataka Industrial Areas Development Board, Bruhat Bengaluru Mahanagarapalike, and Karnataka Police Housing Corporation. Even today, his expertise continues to guide the state's infrastructure growth, serving as a member of several high-level committees including KRDCL, Minor Irrigation Department, and the Infrastructure Development Department. He also contributes as an independent engineer, DRB member, and conciliator for major projects including those of BAM RCL. A true pillar in the field of engineering and governance, his journey reflects dedication, vision, and impact. Ladies and gentlemen, please give him a warm welcome with a huge round of applause. Thank you, sir. And now it's my pleasure to invite Session Deputy Chairman Shri B.V. Nagesh, a highly respected structural and bridge engineering expert with decades of rich experience, a civil engineer from NIE Mysore and an MTech graduate from IIT Madras. He is currently the principal consultant at Nagesh Consultants, Bengaluru, leading impactful projects in bridge and structural engineering, with contributions to numerous elevated roads, flyovers, and major infrastructure developments, along with the prestigious recognition including ACCE Eminent Engineer Award 2024. He continues to inspire both industry and academia. May I now request him to take the stage. He is already on the stage. Please give him a huge round of applause. Thank you, sir. And now, I would like to invite our first speaker. So are we ready? Yes, let's invite our esteemed speaker, Shri N.P. Sharma, a civil engineer and transport planning expert with over 37 years of experience, having played a vital role in planning, designing, and execution of major metro projects across India, including Bengaluru Metro. He is widely respected for his technical excellence and visionary leadership, currently serving as Associate Director Infrastructure at Design Tree, Bengaluru. Shri Sharma's contribution has shaped modern urban transport system in our country. May I now request him to please kindly take the mic, and stage is all yours, sir. Thank you so much.
Color mic is fine. You get it? Because I can't stand and okay.
Yes.
Of course, thank you, Jayagopal sir, for inviting me to talk. Actually, I am taking a podium stage of workshop. This was after 1 year, so because of my personal reasons, I don't know about it. And I'm very happy to be back at the stage. And I thank, when Arvind spoke to me that, can you talk on problem? Well, can you hear me? Talk to me on monitoring of structures. And whenever I was giving a presentation on tunneling and many other things, those were only a couple of slides of monitoring which I was giving. A full-fledged presentation. And I was very happy to do it because I want to share my experience which we had in Bengaluru Metro. First of all, I'll do my pranams to B.C. Roy sir, my first boss in CS. 86, 87, and CS gave me such great projects in 2 years. Vehicle speed moderation, road use charges. We identified the National Highway Golden Quadrilateral. In fact, I had prepared a transparent sheet where I had marked red, green, blue, high density, low density corridors, etc. And that was declared as Golden Quadrilateral by PM Vajpayee. I kept that sheet for a long time. Recently, I threw it out because it's only a sentimental value. I had kept it. And of course, I had some fantastic projects within 2 years there, and that was a great career. Of course, I left and of course went to write much further ahead. Now, actually, when I prepared my presentation, I had 72 slides. And Arvind gave me the schedule, and I found my old friend Suprav Sab, the president, of course, who is my old friend for the last 42 years. Is the keynote speaker and next presented by Professor. I deleted 32 slides, which included all this, what is instrumentation, what are the instruments used, are all the fantastic lecture which he has given, IoT, all those things, I deleted it, and I thought actually I should address to the students here, the young engineers, more than actually what we are all, because we all know about all what we are doing. So from that point of view, it will be more of a storytelling rather than actually a very, very few technical, beautiful lectures which we had already earlier done, because I don't want anybody to sleep before lunch or not see WhatsApps. Thank you very much. Can we start, sir? Of course, I was ex-Design Tree Director. Now I am Tata Consultants Engineers. Thank you very much. Can we start? Now, green is for forward. actually, I will touch upon, this is the underground network. Of course, I will talk about Bangalore Metro. Of course, I will talk exactly what, as a chief engineer Bangalore Metro, we experienced how the monitoring was done and how exactly it was very useful for us in fantastic accidents, which are very beautiful incidents where actually we avoided very big accidents. First of all, when the Bangalore Metro was started, actually, somebody told me actually, Bangalore is sitting on a rock and tunneling, why you have to go tunneling, etc., etc. So many things were done. Of course, Hegde Saab is here, he knows about it. Hebbal flyover, 58 piers, all 58 piers, completely friction free, no rock. Remember, sir? Of course, I had some incidents. Arvind knows about it. ROB flyover of ITC. Across the railway, one side of the pillar is 4-meter open foundation. Across the railway, then the next, the same span, 19-meter pipe. Of course, I had the experience of many flyovers like this, and I knew about it. Only one person told me that, yeah, you are going underground metro, you are planning in Bangalore Metro. It is not easy. It was BSc Rao, was the only person who had told me. And believe it or not, the tunneling in Bangalore was one of the very, very difficult. I'll tell you why it is so. And for us, one of the few foreign consultants from the contractor side of that told that was one of the most difficult works they had done in the world. One of the most difficult works. Why? Because of mixed strata. So this is, of course, the map. I'll skip this. Of course, everybody knows about East, West, North, South corridor. This is the Bangalore Metro map. Now, I'll quickly go through this issues and problems with instrumentation. The instrumentation portion I was completely skipped because Subra has given us such a fantastic overview of the entire instrumentation, incidents and way forward, which I wanted to give it. Now, complexities in geology, big strata in tunneling, boulders and hard rocks, boring machines to vibrate excessively when cutting and ground subsidence and potential damage to nearby structures. Because my topic is actually what are the problems we faced during tunneling with respect to monitoring of buildings and structures. Waterlogged, high pressures causing ground settle in sinkholes. We had a lot of sinkholes. We had to go through a very particular, of course, people from Bangalore know it. We had to go through City Market and Chickpet, very old area of Bangalore. And we had very high, and of course, in second phase, we had to go to Shivaji Nagar. And we had a lot of problems actually. T-beams are particularly struck old buried objects such as garbage dumps, etc. Damage of cutter tools extensively because of the hard rock of almost 340 MPa. In fact, we thought actually the cutter will be bigger size if it is rock, if it is, but actually in case of when the soil, it went to the soil, the aberration was cutting off the cutters more than actually what we had in the rock. So we had to increase the size of the cutters depth when we are going in soil and thin it when it is a rock. It was actually a ulta phenomenon we thought what it was. Issues in central areas. We had very narrow roads, closely spaced buildings, all we call as the vataras in Bangalore. We had high water table, changing geology, a lot of borewells, 117 borewells and 152 wells were there. In fact, we had to identify them with a very difficult, it was below bedrooms of many of these houses. We had to identify it, and of course we had a lot of archaeological monuments, such as Tipu Sultan, even the Victoria Hospital, etc., etc. So we had to go through all these things. Now, monitoring and technical changes, real-time accuracy, ensuring that automated deformation of monitoring systems, other sensors provide real-time accurate data to detect premature building development. Now, if you have got a structure which has got a foundation and a frame structure, we can model it. It is easy to model it and see how it behaves under a particular system. Suppose if you have got old structures which are mud structures without any foundations attached to each other, how can you model it? It was not easy for us to do any modeling on those structures and how to monitor that. That was the biggest challenge we had in our structures. Of course, we had a lot of buildings. Another problem is pile foundations. I had to take the alignment through to avoid pile foundations. We had only one building which I got pile foundations, fortunately, in that area. And of course, I changed the alignment and tried to avoid pile foundations. But we had a lot of basements. And very old basements, and we were not very clear actually due to vibrations how it behaves, because that was not able to be modeled in computer. Of course, we had an extensive building condition survey we did. Each and every building 2 kilometers around the alignment was done. Foundation details, basements, information about wells and wells, special structure archaeological well, flyover. We had to pass CC circle flyover, and the span was around 25 meters or so, and I had to take my 2 tunnels in between the 2 pillars. Fortunately, there were no drawings in BBMP. Then I went to, of course, somewhere L&T, and I got the drawings, and fortunately it was friction piles, not friction piles, it was end-bearing piles. And the gap between the edge of my tunnel and the pier cap edge was only 3 meters, and that too in a diagonal fashion. So we had to pass through it, and corporation told, shall we stop the traffic on the flyover? Without rain, somebody asked me actually in Kannada, hey, don't worry about it, it is all free. It is end-bearing piles, we'll take care of it. We had extensive monitoring instruments in that actually to see how vibrations are taken, what are the effect of that, and of course even the any deviation in the, of course, any over excavation of the soil around the pile, etc., etc. Of course, though it was not matter in the friction pile, it was very, very interesting for us to do that. That was one of the things which we had to do. I have got each one we had 2 slides. I skipped everything. I'll tell, of course, all of you of Bangalore. I can tell you Central College. Central College, actually, they told actually this is a C.V. Raman's room where he found out actually some formula, etc., etc. Don't touch that. It's hardly 1 meter from that room. UVC. Many people, my sister-in-law is a professor there, she told, old building, at least they will build a new building. You had to go very close to UVC. BSNL building, GPO, HL quarter, and KSA stadium. All these are very sensitive structures, and we had to go very close to them. And we had and believe it or not, actually, all our stations are bottom-up construction in Bangalore, because unlike Delhi, we have hard rock, varying right from 0 to 25 meters. And in fact, we have done almost 3,500 blasts in Vidhan Soda and Central College every day in the morning, 5:45. We cannot bring the detonator early in the morning, we have to bring just done and blast it. And each blast had to be modeled. Of course, we had NIRAM along with working with us. And of course, nobody would have heard any blast happening in Bangalore Metro when it was built. Almost 3,500 blasts every day we had done. I'll show you some photographs of GPO. And we had to take a right turn from Vidhan Soda to GPO towards Kaban Park side. And 2 tunnels sandwiched between GPO building and Vishwesvaraya Tower. Now, the minimum radius of a TBM, is 240 meters, so we had to take it, and we cannot take a right angle turn. I had taken straightly ahead actually, and then gone below the Rajbhavan building, and nobody told, don't tell anything that it is going below Rajbhavan compound, not building, compound. And we did the work actually. I'll tell you something. See, public safety concerns, vibrations and cracks. Residents frequently reported cracks appearing due to TBM movement. Excavation to vacate buildings. In fact, the first building I had to cross was actually Sharda Hotel. If you go from Santosh Theatre and take a right turn, there is a Sharda Hotel in the end. The foundation is only 2 meters, and he has built 6 floors illegally. We were real damn afraid actually how it is standing, because of only its symmetry it was standing. So I had to do, in fact, I told him, what is your occupancy? He told 60%, I'll give you 100% occupancy, vacate for 15 days till the TBM passes. So of course we had to do strutting, and we were really perplexed actually, it went off fast very quick. Now this is actually an example of what I am telling you actually. This is majestic. station. See the hard rock variation. It varies from 11.5 to 23 meters within a span of 135 meters. That is the type of variation you have got. And the most important thing is actually the beauty of this majestic, this is Central College. That means we have got from zero hard rock, we had to go up to 20 meters. We had to go up to 20 meters down, 340 MPa granite. Why I told you about all these things is actually, why it was important to talk about the geology is actually, it had an impact on the monitoring systems, it had an impact on tunneling, it had an impact on the type of structures we have to build, etc., etc. Of course, I don't want to get into this. Of course, Tipu Sultan, Paris Tipu Sultan, 460 circle, there's a big Raj Kalway, just after Chikwet, railway yard. The entire 10 platforms of railway yard, we had to go below that. And the headroom which we got on out of the 5 platforms, the headroom above the TBA was only 3 meters. Because we could not go down because we had to come up a Magdi road. The levels did not permit us. Every track, we had taken a block. Extensive monitoring was done. Of course, I don't want to get into the monitoring what we did there, so that the track is, other adjacent tracks are not affected. And of course, you know, any deflection or any settlement will warp the tracks and railway. They cannot close any track. SPC is such an important this one. It was a fantastic experience, especially Hari Babu, the CEO of the Southwestern Railway was there. As I say, they really cooperated. Almost every day we had a meeting to pass through that. And the one which saved us was the instrumentation, to monitor those things. I'll finish in only 3 minutes, sir. Of course, these are all, I don't want to get into these things. I have told you already, he has given a tilt meter, deflection meter, crack meters, etc. Sir, I will only get into this, only two incidences. This was the one which we passed, TBA passed, and we had to monitor it. This is very important. See, this is a boulder right in the face of below the city civil code. Of course, we had done all the strutting, etc., etc., done this one. Now, almost at 18 meters down, 18 to 19 meters, we have provided lock bolt in the design. You know, actually, in the praxis analysis, we get different bending moments at every level, and based on that, we do the supports. The contractor went up to 18 meters and thought, actually, only 1 meter, why to do the lock bolting, let me do quickly excavation and concrete it. What happened? See here, you can see the tilt, king post buckled. You know, the instrumentation was done, monitoring was done such a manner, any tilt or any other deflection beyond 50%, deputy CE will get my error. And as a CE, I will get after 70%. I got a call at 12:45 in the night. And believe it or not, actually, this boulder started moving forward. And if we had delayed by another half an hour, the entire civil court would have collapsed. You imagine what would have been, I would have been in jail, perhaps maybe. What helped was our monitoring system, which helped us to avoid this calamity. That's the, of course, I am telling you a live example how monitoring helped us in avoiding such calamities, and it was fantastic actually. These are the type of cracks we are encountering, and every time we had to install crack meters and many other instruments. This is a very big stampa in Venkatramana Swami temple, and it is almost 30 feet high, and we had to go right below this. So here also extensive instrumentation is done, and then we saw that safe passage for this actually. Because we had such type of problems. This is the last slide, sir, and this is the most important. This is the HAL building, and 3 meters from the HAL building, I had to go 22 meters deep. And they told they should not touch this building. And how to do that actually? We had installed that light, you can see these lights, that yellow lights. It was so monitored that if the light is green, that means there are no deflections in the instrumentation. If the light is yellow, there is a warning. Light is red, it is. So we were sitting and watching it from the office. But the down below, the person who is working 15 meters below, the labor also could see that. In spite of all this instrumentation we did and successfully we did, we had a tow failure. Because the barricading around it was removed in the night for a lorry to come. And the drain was blocked. And the entire water seeped in. And it got behind the soldier pile, and they had tow failure. So that was the thing, and actually, but ultimately we could finish all this work only because of instrumentation helped us to monitor the entire work. We had almost 1,862 instrumentation, struck meters, altimeters, deflection meters installed during the construction of tunnel. And since the paucity of time, I'll tell mitigation, pre-construction surveys, detailed inspection of building conditions before tunneling, instrumentation, etc., etc. Now, instrumentation is not given importance in Indian metro projects, training of engineers and monitoring of structures. Model code of, sir, actually I request Jai Gopal's model code of monitoring structures, especially tunneling, high-rise building, high water tank adjacent to each other, etc., vibrations, etc., coming to the picture. Instrumentation, insertion in structure at night, of course, Subra will take it forward. They are building a model code, he told me actually, the global code for that actually is very important for us to follow because actually, and also he talked about IoT, last thing, the digital twin. Digital twin is very, very important because we have so many structures and we cannot insert anything now and we have to model it. And I request Jai Gopal and Jai Prasad sir that how to bring the maintenance revolving fund so that we can install all these things and maintain our structures. Otherwise, we will be in the same stage of where actually Germany and other places where they are replacing the entire structures and replacing the whole thing, though they have got monitoring systems. Only thing I want to tell the youngsters actually that, of course, these presentations are very, very highly important, and it shows that actually civil engineering is not a silos. We have to be a multidisciplinary engineer as you grow, and people who are interested civil engineering to software, now software has no role, come to application engineering civil. It is IoT or we have got AI or anything. There is enough scope for you, and you can become as good, better than those software who write only software for good companies. Thank you very much. Of course, it's a very short presentation because the time is short, and I have only given you some incidences, only a couple of incidences where actually monitoring really helped us, and we should take this forward. And IABSE will, I hope, that we'll see that actually the model code of conduct comes in, and especially the digital twin has to be installed, how we have to implement that in all our bridge structures. Thank you very much for that.
Hello.
Long press.
Thank you very much, Sharma ji. So, MP Sharma gave us a good explanation about the difficulties he has encountered during construction of the tunnels while constructing metro lines. And he explained how difficulties were there to protect the old and important structures while taking up tunneling work. And he also explained that TBMs were struck and cutters also were broken. And the geographical status of Bangalore is very peculiar. Somewhere it is very good soil, somewhere it is boulders, and most of it is rocky soil, as you say. So in most of the tunnels, you have encountered only the rocky soil, I believe. You also explained that to a depth of about 20 meters, you have to cut the rocky soil only. And most of the works were taken up, tunneling works were taken up at Central College, KSCA, Vidhana Soda, and near High Court, Kabban Park Station. And also one experience you explained about the studs were getting yielded and how cut and construction work was happened. It was really nice. Thank you so much. And I will just hand over to Nagesh to talk few words.
Thanks, Dr. Sharma, for a wonderful presentation. And of course, most of the things have been explained by my colleague, Dr. Gurjita. And one thing I would like to say is cutting the tunnel along a corridor with old building, closely spaced building, okay, and only the owner has the value for that. A lot of attachments will be there. And ensuring the safety of such building, apart from the iconic building, was a big challenge, and it has been achieved by the metro under the leadership of Sri Sharma. What I suggest is please kindly bring out a wonderful manual on how to monitor the safety of building while the tunnel is being constructed under such a building, so that it will be an eye-opener and it will be a wonderful literature for future customers. Thank you.
Thank you, Sharma ji, for enlightening and inspiring presentation. I would like to call you on stage. Can I have please Sharma ji on stage? Yeah. I'd like to request Jai Prasad sir to please honor our esteemed speaker. And I also request to have Professor Manoranjan Parida, Professor IIT Roorkee. He has supervised 34 PhD theses and published more than 500 papers in journals. He has provided consultancy for urban road infrastructure projects, intercity corridors, rural roads and expressways in the country. We are absolutely honored to have him on this conference. With a huge round of applause, let's welcome Manoranjan sir on stage. Thank you, Sharma ji, for sharing an insightful presentation for us and making us develop all the things which we don't know and learning about the things, and we are happy to learn. Is it so? Hungry. Thank you, sir. Thank you so much. And I would like to have Manoranjan sir on stage, please. And you are open to ask doubts and questions regarding whatever and whichever after the break, after the lunch. So they are nodding their head very happily. Just really for I'll have lunch. Thank you, Manoranjan sir. It's such an honor to have the legendary visionary leader here with us today. He has supervised 34 PhD theses and published more than 500 papers. He has provided consultancy for urban road infrastructure projects, intercity corridors, rural roads and expressways in the country. We are absolutely honored to have you here with us today, sir. Thank you so much for giving us your valuable, precious time. We are honoring Professor Manoranjan Parida from Indian Group Karnataka Center. We are absolutely honored to have a visionary leader here with us today. Thank you so much. receiving a gift hampers from yes, a golden gift for a glowing skin. We are proud to honor you and to have you here with us today.
Mr. Professor Parida, actually, IIT Roorkee honored professor and ex-director of Central Road Research Institute. In fact, he was the man who corrected the drone document to its fullest extent. In fact, it is probably going for the VSS in the coming months. And he has given enough of input to the document so that it will not come back from the Indian Roads Congress. So my sincere thanks to the professor, and he is a CRRI ex-director. Plenty of work he has done as far as the roads and bridges transportation is concerned. One round of applause, please. Yes, certainly. He is he is a past president of Indian Roads Congress. That is a coveted position what we held. In fact, that was left out. Sorry for that. Thank you. Thank you, sir. Please, sir. Please, sir. Please.
So good afternoon, everyone. So I just want to thank ING-IABSE Karnataka Center for this honor. I was at Bangalore for the BMRCL project. I'm doing a project that's waiting of travel demand estimation for the double-decker of Bangalore Metro, some 15.6 kilometer. And I have been in touch. Out of his 47 years professional life, I interacted with him 15 years. So in H8 committee, Urban Roads and Streets committee, we have been in touch, and the drone-based monitoring work was reviewed at CRI. And this is a wonderful program. I'm sure it's going to be very useful for the young engineers, and it will motivate the new generation of engineers to be attracted to the challenging domain of structural engineering. So all the best to the center, and thanks once again for this recognition. I am deeply honored, humbled to receive this felicitation. Thank you.
Thank you, sir. Thank you so much. Yes, you're allowed to ask any doubts, questions of anything and everything. I know, I'm pretty sure all of you are hungry. Please have a lunch. I'm expecting a huge noise from you guys. Please come back at 2:15, sharp 2:15. Thank you so much. Please come back at exact 2:15.
Fifth floor VIPs, 7th floor for delegates.
Yes.
Yes.
I hope. Check, check. Hello everyone. ಊಟ ಆಗಿಲ್ಲ?
Chief member engineer BDA. Engineering member. Co-chair is M. Ganesh. M. Ganesh, engineer in chief, Government of Karnataka Public Hospital.
Government of Karnataka.
Karnataka.
ಆಮೇಲೆ
Engineer in chief.
ಓಕೆ
Retired. Iವರು retired.
ಓಕೆ.
ಇವರು ಕರೆನ್ಸಿ ಇಲ್ಲ, ಅವರು ಇಲ್ಲ.
Yes. Good afternoon, ladies and gentlemen. All set? Had your lunch? I hope all of you had a good lunch. Can I get a huge shout out now? Let me test the energy now. Come on, everyone. Oh, wonderful, wonderful, wonderful. Okay, so welcome to the second of International Conference, State of the Heart, Health Monitoring of Structures. So yes, I hope all of you are set to next informative session. Let's go forward. Now, it gives me immense pleasure to welcome the next speaker, Mr. R.K. Jayagopal sir on stage, the renowned structural engineer with over 47 years of experience in bridge and structural engineering. Is a managing director of Struct Geotech Research Laboratories Private Limited, Bengaluru. Is also a recipient of the prestigious IRC Medal for Bridge Rehabilitation. May I request Mr. R.K. Jayagopal sir to please kindly come on stage. And now I would like to request our chairman to welcome Dr. H.R. Shantarajana, member engineering BDA, to please come up on the stage. So the session chairman is Dr. H.R. Shantarajana, member engineering BDA. The co-chairman M. Ganesh, engineering in chief, Government of Karnataka. With a huge round of applause, let's welcome M. Ganesh sir on stage.
ಎಕ್ಸಾಮ್ ನೀವು ಟೀಚರು ಸ್ವಲ್ಪ ಕೇಳಬೇಕು ಕ್ವಶನ್.
ಯಾರು
ಅಲ್ಲ ಕಳಿ Good afternoon to my fellow engineers here. My talk about the future of structural health monitoring, leveraging on the satellite technology for bridge maintenance. This was conceived actually based on the drone document which I sent it. It didn't go through once, twice in the BSS. So I told the BSS chair, I am not going to go ahead with the drone document. Let me go with much higher technology here. And I told them also it will be presented in the IABSE main conference. By luckily what happened, this was approved in the main, this one last Copenhagen, and they were very happy. In fact, our structural engineers, majority of the structural engineers, 99.9% structural didn't knew about this, about the structural health monitoring by the satellites. In fact, we made a collaboration with, she's, our lady Aisha Begum is here only. Begum, just 1 minute. She is from Indian, ISRO Hyderabad. And ISRO Hyderabad is making a collaborative project in addition to the Public Works Department here in one of the bridges which had a sag. In fact, we wanted to start with this one project, and they are very happy. Only thing is they want to verify the whatever data obtained from the satellite to the site, almost whatever it is like a verification of the validation of the document of the measurements what we receive. To my fellow audiences, 3 o'clock actually we have already fixed for a VC from Germany. That's again one of the best subject where AI and the digital twins are put into the health monitoring. That's an excellent subject, and please excuse me, I will be running the slides, and my next speaker is Mr. Madhav. I request him also to run the speed so that 3 o'clock we make available for the German lady to go through, because it's our, we went on morning, it got delayed. That this is an innovative approach, offers capabilities that other rival traditional methods like robotics, artificial intelligence, micro-piezoelectric sensors, including drones, cannot provide. It is simply from the sky, you send waves and get back and measure the deflections or cover or whatever. Then satellites equipped with radar sensors can detect even the slightest movement or the deformation of bridge structures caused by heavily loaded vehicles, aging, thermal, and many other factors like that. The ability is to gather extensive data remotely without need for a site sensors. You need a site sensor. We don't need, as far as satellite is concerned, any site sensor. The capability not only reduces the cost of associated with traditional contact type sensors, but also facilitates continuous health monitoring and multiple health monitoring. At a time, you can monitor so many of the sites. That has got some problems also, like any other. The satellite flying over the bridge will also not have the life equivalent to the bridge. Morning with Dr. Harsha, I was mentioning the whatever sensors, age of sensor is not equal to the bridge age. Here also, the satellite age just cannot be equivalent to our bridge or whatever building's age. The application of high resolution C-band radar imagery analyzed through persistent scatterer interferometric synthetic aperture radar, INSAR. They call it as INSAR. They can't understand the other continuous phases as our friend has told. INSAR means they will understand. Yes, INSAR is related to the satellite. The method enables high density measurements over expensive areas. And these are the actual satellite payloads, what you see there. These are the payloads what is there in the satellite. That's the reason simplicity is very much there. And that's the reason you have so many unicorns and so many engineers getting into the satellite and the rockets like that. It is completely simplified. The multispectral and long-wave thermal infrared LWIR sensors are mounted on the payload section of Earth observation satellite. Earth observation satellites are geosynchronous. It goes through the same location, showing the same area on the ground like that. They have many types. And electrical, how the satellite has got 3 parts. One is bus platform. Bus platform is for power, whatever bus bars we call. Same way, payload consisting of instruments, cameras, varieties of cameras. It sends the pictures, then altitude control. Then we have the payload consisting of instruments and storage systems, data relay mechanisms. Now that has improved a lot because storage and all, we do it on the ground nowadays. And multispectral cameras are typically optical sensors. That plays a major role here. Coupled devices, the complementary metal oxide, these are all, I cannot expand and tell you, these are all color coded. It has got its own bandwidth, showing either the temperature or the stresses, etc. Additional payloads installed in satellite are, I don't want to go more into that. Sentinel, there is again different types, echo stress. She will be able to give probably tomorrow all these details. Then we have the Trishna, that is our satellite, Indian satellite, dedicated for thermal monitoring of land and infrastructure. And these are the equipments what they normally keep in the satellite. The Earth and man-made structures emit infrared radiation. We measure the infrared radiation for various purposes. The LWIR sensors measure this thermal emission in 8 to 14 micrometers band. Let me not detail, but I want to show you the pictures. These are the equipments what they use in the satellites. Again, interferograms require there is a comparison of 2 images on a regular basis. How much the movement happened, how much distress happened. That way they compare the 2 pictures. Let me skip because of the shortage of the time. The limitation and disadvantages. Depending on the satellite availability, data acquisition frequency depends on the satellite orbit. Example, Sentinel 1:6-12, 6 or down to 12 days period, it comes around the Earth. Then cloud cover, then humidity interference, optical or thermal imagery can be obstructed. Lower temporal resolutions. Then we have the data processing is complex. It is not so easy. It is a quite complex job. Requires advanced algorithms and advanced even computing also. Validation needed must be combined. In fact, she was very particular that in case if at all we do the job, in case if they give the data, we will have to just validate it from the site. That is Pandupura. Our friend is here only who has designed the bridge, Arvind Salacha. That has got some many problems. So we are trying to integrate with the ISRO. Then integration with the codes and standards. Let me not go through this. Their codes and standards are getting updated here. Then there are real world studies. Multispectral LWIR satellite imagery has been applied in bridges like Milau Viaduct. Then we have the Brooklyn Bridge. We have Sing Ma Bridge in Hong Kong. Then Indian pilot studies have also been conducted in Krishna. Then Cartosat data is prepared for thermal monitoring of urban infrastructure, like the bridges in Ganga River Basin. I think tomorrow she will be able to give much more data than this. Then we have that working principle. Let me not go through thoroughly into that because of the time constraint. How this structural health monitoring, even a slightest horizontal movement of your pylon, that your suspension bridge or your cable stayed bridge, even a slightest, the tip moves, it gives an indication that something is going wrong here, to have a check at that. As far as the bigger bridges are concerned. Smaller bridges also you can predict. Tomorrow she will be able to give those details. Like whatever you see here, from the top you can see the horizontal movement and the vertical movement also. You don't need to put any sensor there. Like this horizontal and vertical movements can be done. Then, of course, vibration monitoring can be done. Definitely it will have environmental influence on surrounding conditions. Then integration has to be done for that measurement to the actual like validation. The SHM helps in bridge rescue and maintenance. Certainly, if something is going wrong, we can easily find out the reasons and go for the rescue operations. Then Indian advancement in satellite technology. ISRO, Cartosat and RISAT satellites are the satellites they are using right now. These satellites are equipped with radar imaging capabilities and have been used in the monitoring land deformation, that is earthquakes and all. Urban development projects, INSAR has been explored for monitoring metro rail projects and urban infrastructures like Delhi and Mumbai. Then disaster management, of course, disaster management, it's absolutely required and is being used in the Uttarakhand and Himalayan regions. This is exactly the bridge which I was telling in Pandupura near Mysore. The experience what we gained probably maybe after 1 or 2 months or the next technical session, we should be able to give the calibrated thing, how much physically it goes down or how much we get from the ISRO headquarters. And if the government to the ISRO things goes well, in fact here in our Jayaprasad sir has already told, that is the case, we will shift over giving some additional details to the Mangaluru side, wherein we have distress conditions are more as far as the bridges are concerned. Here, this is the bridge actually. This has got to a settlement mid-span deflection of about 160 mm. And National Highways, our RO was here only. He was interested in checking this thoroughly, why things have gone wrong and all. And of course, the load tests have been carried out at least 4 times to verify, not to get into the trouble. And finally, the validation thing has come now, and it is expected that we go through the validation and apply it to the other bridges also. In concluding, satellite-based structural monitoring represents a significant advancement in the infrastructure management through in fact, you have in Spain, you have in France, you have in other advanced countries, they do this satellite measurement of the SHM. And in fact, this has been told in the PRC. PRC also, our other members, they bring the data. Then, although the satellite monitoring cannot yet replace the ground-based instrumentation for real-time vibration assessment, it provides an efficient, cost-effective and scalable solution for long-term regional bridge monitoring. Integrating satellite observation with conventional, combining both the SHM data establishes a powerful framework for predictive maintenance, safety evaluation and sustainable management of the bridge infrastructure. In fact, we have sent so many satellites into the space. We being civil engineers, we should demand for, what I say is we should demand for a dedicated 1 or 2 satellites which will give us so that we can send the data and get back the data, including all our national highways, our chief of the national highways here only. In fact, we can tell him to talk to these ISRO people. In fact, in Bangalore, we have a headquarters. Tomorrow, one of them will be giving a lecture also. One Bhimrajappa, he is from here only, Bangalore. So we can expect some good integration of the satellite data, whatever already obtained, and validation of the existing one in the bridge at site. Thank you all. Question and answer, kindly let us meet at the tea time, and you can ask, because 3 o'clock, a good lecture from the Germany we can expect. And before that, our friend is also, Madhava is here. He can complete, yeah. 1 minute, sir.
Thank you so much, Jai Gopalji. I would like, thanks to chairmen and co-chairmen for joining us. So I'd like to welcome the next session chairman, Mahendra Aras sir, on stage with a huge round of applause. And session deputy chairman, Shri Kumar, yes, with a huge round of applause. Let's welcome Shri Kumar sir on stage. Yes, so we have Mr. Madhav sir right here. It's a proud privilege to invite him here on this conference. A highly respected engineer and administrator, brings with him decades of rich experience in civil engineer and he has held several key leadership positions in the government of Karnataka, including Chief Engineer for the prestigious Ethinole project and Nodal Officer for the World Bank-supported Dam Rehabilitation and Improvement Project. And his expertise as a vast technical knowledge and visionary leadership and commitment to the engineering excellence. We are truly privileged to have him with us here today with a huge round of applause. Let's give him a stage.
ಮೂರು ಗಂಟೆಗೆ ಬಿಟ್ಟರೆ ಸಾಕು ನೀವು ಅಲ್ಲಿ ತನಕ ಲಾಸ್ಟ್ ಗಂಟೆಗೆ ಜಾಸ್ತಿ
3 o'clock I have to cut.
ಕಟ್
So, good evening to all. So, my presentation is structural monitoring of aging dams. Since I have worked in the dam rehabilitation improvement program under the World Bank assistance in Karnataka as a project director and a nodal officer. So, almost from 2014 to 2023 till my retirement, I was looking after this project. So, here I think in the monitoring of this structural monitoring of aging dams is one of the important aspects. I think it is totally different from the other structures. So this is briefly, I'll go through the slides. So this is large dams in India. So this is almost 50% of the dams are located in Maharashtra. And Karnataka, we stands almost fifth in the merit, around 231 dams as per National Register for Large Dams 2019. So this is dam failures in India. So because earlier dams designed based on some parameters, but there are about 36 dams failures have been reported in India. And the worst was in Machu 2 dam failure in Gujarat in 1979, killed around 2,000 people. So In Karnataka, we have not reported any failures of the dams. So this is age of Indian large dams. Almost more than 100 years, you can see 293 dams. And we are concentrating under the World Bank assistance, the program. Those dams completed 100 or more than 50, we are concentrating priority basis. There are about 73 dams spread over across India. Coming to Karnataka, so here there are about 231 dams. I'm not going to talk all those things. I'm only concentrating on the major irrigation department, what we are maintaining around 75 medium and large dams. So this is age of large dams in Karnataka. There are dams more than 100 years, is 31 in Karnataka. And in Karnataka, there are 12 the national importance dams. So that is the highest in the entire India. So Almaty, Krishnarasagar and other 12 dams are located in Karnataka. So this is recently 2021 Dam Safety Act has been enacted. So in that, there is a clear provision for this provisions of this instrumentation. Because in the act, there is a penal provision is also included if the dam owner don't maintain this instrumentation, and so there will be a punishment for the dam owners. That is the class they have introduced recently. So introduction. So why monitoring of dams? So here thousands of dams are reaching or exceeding their design life of 50 plus years. What are the risks, the potential for catastrophic failure, loss of life, economic damage? This is we have observed in major failures. So our goal of this SHM is early detection of structural defects to prevent the accidents. So shifting from reactive maintenance to proactive data-driven monitoring. So till now we have monitored manually, and all the readings are recorded manually, and it is in the form of a manual data. So this, what are the challenges of aging dams? One, material degradation, foundation issues, environmental challenges, instrumentation obsolescence, and the last one is deterioration of hydromechanical components. Probably in Karnataka, this was reported in Tungabhadra Dam recently, the Tungabhadra Dam, where the age of that gate was almost 77 years, so they could not replace in time. But because of that failure, so we have almost lost one season crop for the entire basin. So these are the 4 pillars of serious health monitoring: safety and risk assessment, identifying the structural weakness, because dam is a homogeneous or heterogeneous dams. So we can encounter all types of dams in our the country. Structural behavior monitoring, this is also another important, measuring deformation and displacement. This is where displacement we can use of our INSAR satellite technology. Seepage and hydraulic monitoring, this is worst enemy for all our dams. Seepage is the culprit which will damage or the overtopping of the dams takes place. So because of that, we have to control the seepage through the body and also the foundation. Whenever it is alarming, so beyond the permissible limit, then we have to take the preventive measures. Environmental monitoring, analyzing temperature, rainfall, and seismic activities. So these are all the instruments normally we use in the dams, especially piezometers to measure the pressure. But now in all our old dams, we have installed the manual type of piezometers. Now we have changed over all into the real-time data collection. Inclinometers, extensometers, and crack meters, strain gauges. So the seepage monitoring, V-notch, geodetic and remote sensing monitoring, automated data acquisition system. This is also we are using in all our dams. So this is advanced monitoring techniques. What are the technological approaches? Automated data acquisition system, real-time data logging instead of manual readings. And fiber optic sensor, so that is distributed strain temperature sensing, high precision monitoring of large areas. And the GNSS and GPS receivers. This is what I think Jacob also are telling, satellite SAR, the technology. And recently, so we have started using this drone in one of our dam in Karnataka, that is aerial inspection of hard to reach cracks and surface degradation. So this is another geophysical investigation. So when we started the grouting of rehabilitation of our old dams, so much data was not available with the dam owners. So how to calculate the grouting material, what technology we have to use, whether to go for a membrane technology or to go for the body grouting, so on. But unfortunately, to support that, we don't have the historical data to arrive the exact the grouting material and the cost. So nowadays, we are also going into this geophysical method for all our dams. Before taking up any rehabilitation, these are all the mandatory, we have made it. So this is geophysical investigation, especially we used for leak path detection, internal erosion, identification zone of water accumulation, cavity or the sinkhole, and concrete degradation. So here the list of geophysical methods. One method will not suitable for all the dams. So it is combination of concrete dam is something, and earthen embankments, masonry dams, which are the technologies we have to use. Because this is the area where we are not getting the knowledge for the dam engineers in the field. Which technology we have to use? Unfortunately, in the field also, there are less players in the market getting good technology for our, investigation is very, very difficult. We are facing the problem. So this is one of the, saturation masonry dam at the crest of the masonry dam. So we have taken this, the tomography, and we have analyzed for the weak zones. So especially the blue and the green shows the weak spots where saturation is moved. So this is one we have proposed for this Almaty Dam in collaboration with the Niriksan from the Canada. So we are going for a drone, the aerial inspection for the downstream of the dam where the human is not accessible, even in the upstream also where human is not possible. We are going to use this technology. I think shortly we are going to start this the data collection and also this the evaluation. So this is delimitation. So using that technology, we can quantify exactly what are the width of the cracks and what are the spots we can clearly identify. Because visual observation, we cannot do all these things because of the height of the dam. So recently, the underwater survey, I think we have started in Karnataka for all the dams. Wherever the water level below MDDL, mean drawdown level, so we could not assess what the damages exactly happened. This is an unmanned the robot we have used to capture the entire surface of the dam. So this is how entire dam below the MDDL for the entire length, what we can say below the storage level, dead storage level, we have captured the entire the dam profile. This is how the joints are get dilapidated conditions, more cavities are there. So this is the video we have taken. See in the KRS dam. So we have taken this photo below MDDL. So this is the level of the cavities was formed. So this technology was helpful in assessing the exact quantities for this. For this, we have taken up underwater pointing for the entire dam surface below MDDL, and also we have carried out for other 2 dams. The first time in India, I think in dams, we have carried out this work in Karnataka. So this is the key parameters to monitor: seepage, deformation, cracking strain, seismic response, acceleration during the earthquakes. Karnataka is the only state we have installed the seismometers in the vicinity of the dam for all our iconic dams or the national importance dam, and we are getting a real-time data every day. So this is data analysis and interpretation. I will not go into the much details. I think already they have dealt. So this is the World Bank project. With this objective, we have taken up this project. This was taken up in 19 states in entire India, and an allocation of almost 10,500 crores. So 19 states are participating. So majority, 86% of the money will go for rehabilitation and improvement of dams and associated appurtenances. That includes replacement of instrumentation and also this monitoring of the health monitoring of the dams. Other components, institution strengthening, training, and other things. So in Karnataka, there is one case study for 12 dams. We have taken up this the real-time structural monitoring of 12 dams in Karnataka. These are all the major dams we have taken up. So with the Encardio company, so they supplied this equipment through the tendering process. They have come. So these are all the instruments installed now. So whatever earlier was there, we all remote, because those are all the manual reading instruments. So we installed all these real-time data capturing equipments, including siren also we have incorporated in this. So seismic stations, seismological stations. So in addition to the seismometers, we have also accelerometers we have inserted in the body of the dam as per the IS code. So we've installed these instruments in all the dams, and Karnataka State Natural Disaster Monitoring is the nodal agency for earthquake-related studies and real-time data we are getting every hour. So KSMDC has installed 14 VSAT-enabled seismic monitoring stations in the state, which include 10 major dam site locations. All these dams, we are getting the data, and it is. So this is the project for 12 dams. We have installed 12 dams for the remote locations, how it is connected, geotechnical, lift pressure meter. All these are real time. I think we are getting the data. It will be processed as per the procedure. Yes, so these are all the equipments. I'm not going to explain. Yes, this is the central control monitor unit established in each dam. These are all some of the equipments installed in the dam, including siren. This is about settlement marker. This is uplift sensor. Wherever the uplift pressure is more than the design pressure, there will be overturning of the dams. So continuous monitoring of uplift pressure is important. For that, we installed the sensor. And V notch is for the seepage. This is a tilt meter and a VSAT. This is automatic water level recorders. This is about a strong motion accelerometer and giant meter. This is about data center at each site. So this is the graph we are getting continuously reading in a real time for the tilt meter and giant meter. So this is the Bhadra. We have done one similar project with the collaboration of the Delta Race Netherlands government. So we installed the sensors in the dam body. This is in the saddle portion also we have installed. So this is the position instruments. So this is the overview of dam instrumentation for the Bhadra Dam. So this is my conclusion. Serious health monitoring is non-negotiable for aging infrastructure. Adopting automation and AI reduces human error and ensure timely intervention. Proactive SHM ensures sustainable water management and disaster management. With this, I think I will conclude my talk. Thank you.
Thank you, Madhav sir, for such an informative session. Due to time constraint, we'll be felicitating all the dignitaries after the next speaker. Yes, join me in welcoming Ms. Yvonne Christine Gunriben, a Deputy Head of Division for Civil Engineering Structures at Federal Ministry for Transport, Germany, an internationally respected expert in bridge engineering, sustainability, resilience, and quality assurance. She plays a key role in shaping engineering standards and policies in Germany and across Europe. She is actively involved in several national and international bridge and infrastructure committees with an extensive global experience and leadership in transport infrastructure. We are honored to have her here with us today with a huge round of applause. Let's welcome our first women speaker on.
Hello, everybody. So I'm just going forward. So thank you very much for the nice introduction. Today I will speak about structural health monitoring from our Nibelungen Bridge, and I will show you my presentation. So let's speak a little bit first about the bridge status in Germany. So I'm now away from you above more or less 6,000 kilometers, and on the right-hand side you see the main network, main road network of Germany. So the red lines are the motorways. At the ministry, we are more or less responsible for the federal trunk roads. That means we are responsible for all the motorways and all the national routes. So there we got about 40,000 bridges, and normally we speak about 52,000 partial bridge structures, as normally in the motorways we have separated structures for every direction. So in Germany, we are facing, especially after the reunion of Eastern and Western Germany, a high increase of heavy-duty trucks. And for sure, I mean, it's everywhere the same. The load levels also developed. And as you have seen in the slide before, the most bridges were built in the 60s and 70s in Western Germany. And so they are more or less have a load level in the middle of this slide. And this brings me to this presentation. So in the 1950s, everything was very fine. There was not much traffic on the motorways. But nowadays, we are facing a really high increase of heavy-duty trucks, especially across Europe. And you see more or less our structures are too thin because they are old structures and don't have the level we need today. So many of the bridges in Western Germany are now working over the limit. And therefore, we are made a big modernization program here in Germany. And there you see where we got bridges along the motorways, and we made a new index, which we are calling the load-bearing index, which shows us the load level we need and the difference for the load level we got. So you see, especially in Western Germany, many orange and red dots. That means that there we have the most, or there we need more or less the most bridge modernization in Germany. And this is the same map, but for the national routes, so it's more distributed all over the Republic. And here we got a special one, which I want to present you today. So there in the western region of Rhineland-Pfalz, we will talk now about the structural health monitoring from the Nibelungen Bridge. So the Nibelungen Bridge, let me tell you, was first built as the Ernst Ludwig Bridge in 1900. It lasted till the last days of the Second World War. So all the arches, you see, the wonderful arches were destroyed at the end of the days of the Second World War. And in Germany, many bridges were destroyed, so they were rebuilt very fast. And so the middle part of this bridge was built in 1952 by Ulrich Finsterwalder. You see him down there. And Ulrich Finsterwalder, he was the first one who made cantilevered pre-stressed concrete bridges. You see on the middle of the slide, there is the Lahn Bridge Baldinstein, and this was the first cantilevered pre-stressed concrete bridge in the world. And Nibelung Bridge was also made by him, and it's just some kilometers away. And for this time, it was the world first bridge, which had a span of 140 meters in the 1950s. So as you see on the right and left-hand side, we still have the old arch system. And after the Second World War, as I already told you, we needed to reconstruct the middle section. And this was done by Ulrich Finsterwalder. And nowadays, we are facing some issues especially with the middle section. In the former days, there was the pre-stress system of Duvidac. Mr. Finsterwalder worked for this company. And in these times, everybody invented those pre-stressed systems. But from a point of view today, there are some or many different deficiencies of the system. So we have a very high chloride level, corrosion, and we have also some thin coating of the pre-stressed motor. So from a nowadays point of view, the old shear resistant is not sufficient. And today we have another model where we are calculating those structures, and we know that existing reinforcement is less in the structure than we would need today. And this brings me to the normal way. So we did some compensatory actions like banning the heavy traffic over this bridge. And we make a special inspection every year. So we made some probabilistic calculations where some cracks could occur, but till now we are very lucky. There are no shear cracks yet seen. But the normal maintenance did not work anymore, and so we made a revision of the maintenance strategy. And we also, as I said, it was the world first bridge, cantilever pre-stressed system bridge with those kind of span. It has become a cultural heritage monument and is now a landmark of engineering in Germany. So it's not, normally the idea was to rebuild this bridge, but as it is now a part of the cultural heritage, we are trying to extend the lifespan of this bridge. So, and how do we do it? So this bridge is part of 100 plus, 100 for the lifespan as you have it now in the codes, and 100 plus so that we extend the service life of this structure through intelligent digitalization. So we are having now digital models, a digital connection, and condition indicators to try to look deep into the structure and to help the structure to extend the lifespan. And this special program is sponsored by the German Research society. So we also got 19 research institutes from Germany making there some structural health monitoring, pilot projects, and the goal is to extend the service life through this intelligent digitalization. So what did we do? We made a digital twin for the Nibelungen Bridge. So you see the middle part here, you see now the new bridge from the 1950s. And behind the tower, there is still the old part with the arches from 1900. So what do? We have some use cases for the global structural behavior, for the inspection, for the humidity, and for the documentation for sure. So we first made a survey about the existing conditions outside and inside. We made a modeling of the different components so that we get an as-built model from this bridge. And so that everything is coming together in a computer, in the program, so that we have one single point of truth also for a new recalculation, for example. So I can show you now how this program works. So here, for instance, you can see the expansion joint. So you can go into the program and check if it's possible to, let's say, to check the special components. But I see it's not running very good. So maybe we can speed it up a little bit. So you see the components up here. You see Fahrbahnübergang means expansion joints in German. And so you can go farther and you see the as-built model and see at the end the different components, and you can click it on your sidebar. And also we have a digital inspection. So the inspector can go into the model and see if there's anything, and can put into the online model, into the tablet, every cracks or whatever it has, you will see outside. So, but that's not all. So we also use drones so that we get picture-based damage assessment. We use crack documentation. We also use AI evaluation of the crack documentation as to estimate where the cracks could go, and so that we get an objective condition of the structure. We also do a high inventory and documentation for this bridge. We also got some expert workshops, especially for this bridge. What do we measure? Concrete compressive strength, concrete structure. We are measuring humidity and chloride concentration, the condition and pre-stressing force of the pre-stressing tendons, so that we get a real base for any recalculation which will be done in the future. We also got some load tests running so that we can validate the model, and so that we also get some real structure reactions, and so that we can have some condition indicators for long-time surveillance. So like that we have some alarm indicators. So what do we do in monitoring? So we got some flexible tube levels for vertical deformation. We got fiber optic sensors for crack detection and strain measurement, so that we can get a good feeling for the condition behavior. And as I told you before, so we defined some limits or thresholds, alarming indicators, so that we know, if there is happening anything, we can, ban more traffic, for example, from the bridge. We also got some continuous measurement of the tension members, and so that we get also a monitoring of global structure behavior. What else do we have? We have some local antennas for real-time surveillance by satellites. We got a DFOS as a patch. So the DFOS enables real-time monitoring of acoustic signals, temperature, and strain via fiber optics. And we got Coda wave interferometry, so that we really can get a good knowledge of the behavior of the bridge. So this leads me to our conclusion. So you see the old construction site, and you see above the as-built model, the digital twin. So we are having now more or less not a normal maintenance. We have a real digital maintenance. We are having diagnostic monitoring and finite element analysis. We are trying to compensate the deficiencies of the former years. So it was built in the 1950s. It was a really good time for inventions everywhere. So, but from nowadays, we made some failures, but well, we are learning. And so today we are now trying to compensate those deficiencies of the time from the 1950s. And as for sure, why do we do it? We try to extend the service life of this special bridge. As I told you, it's an heritage site nowadays. So as the Nibelung Bridge was a pioneer structure for the cantilever pre-stressed structures, it became now a pioneering structure of digital preservation. So thank you for your attention, and I hope you enjoyed my presentation. Thank you very much.
Thank you so much, Siobhan, for the informative session. Please give her a huge round of applause, ladies and gentlemen. We are absolutely delighted to honor you on behalf of International Conference on State-of-the-Art Health Monitoring of Structures, and that will be received by Jai Gopal sir. I now request N.S. Ramesh sir to please kindly come forward on the stage to felicitate and honor our speakers. Good morning, sir. Good morning, sir.
Hey, Gopal.
Yes, sir.
Good evening to all. I'm very happy to chair this session here, and we had three lectures in this session. First one was by Jai Gopal, second one by Madhava, and third one from German. So, as you all know, Jai Gopal is a very passionate person about the bridges and the health monitoring systems. In fact, he has delivered an advanced topic on the satellite imaging and the satellite use of satellite technology for monitoring the bridges. In fact, he has also monitored our Hepal flyover. BDA had assigned him that job, and then he monitored that Hepal flyover, and then he has given the report on the health of the bearings and other things. We replaced the bearings also as per his advice and reports. That's what one thing I can tell. In fact, one more point, what I'm trying to release. I was in charge in the Planning and Road Asset Management Center of the Karnataka. Karnataka has established Planning and Road Asset Management Center, and bridges also is being monitored. In fact, Mahendra Raj Aras was with us when he was doing the entire bridges all along the SH and the MDRs have been completely geographically monitored. All the span details, inch and inch details of the have been digitally monitored. And in fact, we are thinking of putting up the sensors for the major bridges. So satellite imaging and satellite imaging will be definitely helpful in times of inclement weathers like typhoons and cyclones and other things where you can't measure the oscillations, especially the string bridges like interstate and which are So I suggest that his ideas, what he has suggested here, should also be adopted by the Karnataka government. And since we have a robust database of all the bridges in Karnataka which are being monitored, so this aspect can bring in more remedy for the monitoring and the aging of the bridges which we have to monitor very clearly. So second topic is our co-chair.
All, especially satellite imagery for health monitoring, first talk given by the R.K. Jayagopal. The bit what he said that Pandavapur, actually I was there when it was in planning stage. Unfortunately, I was transferred when the execution was there. But nowadays, because we have many mega infrastructures constructed all over the India and also especially in difficult terrain, remote monitoring, real-time monitoring is a need of the hour. Especially remotely located bridges and also dams. Madhav, whatever he has given the talk on the real-time monitoring of the bridges is need of the hour. Many bridges were constructed, more than 50% of the bridges constructed having an age of more than 50 years. So you don't know what is there inside the body of the dam, especially concrete dams and masonry dams which are constructed more than 100 years. There are bridges with dams constructed more than 100 years also. So it is a need of the hour to safeguard the safety of the building, dams, and also high-rise buildings. Nowadays we are constructing many high-rise buildings, especially in hilly areas and all, without giving importance to geology and terrain of the geology of the area. So real-time monitoring, especially during storms and during cyclones, heavy rains and all, it is very much need of the hour. It is very much whatever the technical talk today and tomorrow you are having is very useful for the engineers, especially young engineers. You should know what is the importance of civil engineering. It is not only a brick and mortar now. It has a technology. So we are proud to say that when compared to software engineers, civil engineering has a more interest and also future for the civil engineers. So all young engineers should learn the latest technology by attending such type of conferences, and also nowadays we have many opportunities to learn through internet and all. So everybody should update their knowledge and attending by such workshops and conferences. Thank you.
Thank you, sir. Thank you so much. I now request Mahendra Aras, sir, Shri Kumar, sir, Dr. H.R. Shantarajana, sir, and M. Ganesh, sir, to please receive the guest of honor. Kindly come forward near the stage, please. Music. Thank you so much. And I would like to call our esteemed speaker, Mr. Madhav, sir, to please receive the guest of honors. And I would like to thank Mr. Jai Gopal sir, and I would like to request to please receive the guest of honors and felicitation. And on behalf of Yon Christine Gunnerban, I now request Jai Gopal sir to please receive the felicitation, memento, and a gift hampers. Round of applause. Yeah. Thank you, sir. Thank you so much. Yes. Now, I would like to welcome our next speaker. On behalf of Yvonne Christian Gunderban, and I request Mr. Jai Gopal sir to please receive the guest of honors. N.S. Ramesh, please kindly come forward on the stage. Yeah. Now we are felicitating our esteemed speaker, Mr. R.K. Jai Gopal sir, with a huge round of applause. Let's give him a round of applause, ladies and gentlemen. And now on behalf of your Jai Gopal sir is receiving a guest of honors.
She's online, sir. She's online. She's online. You can.
She's online? Yeah. She's listening? Okay. Can I have a screen that is playing Yvonne is live? She'll be watching live. Thank you, Yvonne. Thank you so much. German lady. Yes, let's welcome our next speaker, Tim Henson, a chartered civil engineer and principal engineer at Atkins Relays. With nearly 2 decades of experience, he has led several technically complex bridge and footbridge projects across the United Kingdom and is widely recognized for his expertise in sustainable and resilient infrastructure. His work spans innovative bridge rehabilitation, active travel infrastructure, advanced inspection technologies, and major highway structure projects, making him a highly respected professional in the field of bridge engineering. We are delighted to have him with us today. Please have your attention towards the screen. Please give him a huge round of applause, ladies and gentlemen.
Thank you very much for a very kind introduction. I hope you can all hear me and see my screen. So good afternoon. My name is Tim Henson. I'm a principal engineer with Atkins Realis. So today I'm going to be presenting the outcomes of the Phase 3 UK National Highways Moonshot programme. Today we'll be focusing on muon tomography trials on in-service structures, although it should be noted at this stage that the project has trialled other NDT technologies such as guided wave trials and for the detection of post-tensioned cable defects, as well as other quantum technologies that are not covered by this presentation, but we hope to be able to present the results of these at a later date. But today we're focusing on muon tomography. So Phase 3 of the Structures Moonshot programme, as it's called, represents a transition point for the programme, moving away from a controlled proof of concept testing towards understanding whether the technology can be deployed practically on live assets and whether the outputs can support engineering asset management decision making rather than remaining purely experimental. To set the scene, a significant proportion of the UK's highway bridge stock was designed and constructed during the 1960s and 70s, and is now operating well beyond its original design assumptions. We're seeing increased traffic loading, more aggressive winter maintenance regimes, and persistent issues associated with water ingress. In many structural forms, critical deterioration develops internally within complex details that are difficult to access, such as half joints or post-tensioned anchors, where traditional visual inspection and non-destructive testing methods offer limited insights. Asset owners are therefore left to manage structural risk with limited information. They often resort to intrusive investigations, which can be unreliable and may introduce new defects and are challenging to justify at a network level. However, the consequences of ignoring these issues can be significant. Phase 3 of the project has therefore focused on priority risk structures where uncertainty around internal condition has the greatest potential consequence. These include post-tension structures, half-joint bridges, and hinge deck arrangements. A central objective of Phase 3 has been to understand not just whether emerging technologies work in principle, but whether they can be deployed safely, repeatedly, predictably, on in-service structures, and whether the information obtained is sufficiently robust to influence engineering decisions. This work has been undertaken in close collaboration with the Estonian technology startup G-Scan, who are the technology provider for muon tomography system used within Phase 3. We have also been trialling other technologies, although this presentation focuses on muon tomography. From a deployment perspective, the system typically uses two muon hodoscopes installed above and below the structural element under investigation. The upper hodoscope records the incoming trajectory of cosmic ray muons, whilst the lower hodoscope measures the path after passing through the structure. By comparing the changes in trajectory and scattering between the two detection plates, it's possible to infer the internal density distribution within the structure. The requirement to access both sides of the element is a key practical consideration and has significantly influenced site selection, access arrangements, and trial planning throughout Phase 3. Muon tomography exploits naturally occurring cosmic ray muons, which continuously penetrate the ground and built environment. In a two-sided configuration, the technique is sensitive to both the muon attenuation and the scattering effects, allowing the inference of internal density and to some extent the material composition within a structure. Muon tomography is passive, it's non-intrusive and offers the potential to deliver three-dimensional insights into otherwise inaccessible regions of complex structural elements. A case study to demonstrate the capabilities of muon tomography on phase 3 deployments was at Greenland Lane Bridge, undertaken with UK National Highways and Belvac as contractor. So this represents a fairly typical highway structure in the UK. This bridge has been closed due to concerns regarding the condition of the half joints, making it a suitable candidate for testing whether muon tomography could provide additional internal information to support further engineering decisions. From a practical perspective, the trial demonstrated that the system could be deployed and operated reliably on a live asset. The scan duration was approximately 13.5 days, with limited downtime, and achieved over 20 million synchronized muon tracks, exceeding the target for the trial. This is a key phase 3 finding in its own right, demonstrating that sufficient data set can be collected within a realistic site constraint rather than under simulated test conditions. One of the most encouraging outcomes from phase 3 has been the level of confidence being achieved in identifying reinforcement arrangements and bar diameters. These are images from the initial reconstructions, where the contrast of the points indicates the material density. You can see clearly the internal arrangement of reinforcement bars within the deck and the half joint. The next step is using machine learning, using reconstruction data to detect objects and produce object detection imagery. At Greenland Lane Bridge, this object detection aligned well with expected layouts, and calibration exercises indicated bar diameters within 1.6 millimeters of known values. While these results could not be considered definitive in isolation, they demonstrate that muon tomography is moving beyond qualitative visualization towards quantifiable engineering relevant outputs. It should be noted here that more recent following Greenland Lane have indicated a even closer tolerance than the 1.6 millimeters that we found here. So there is rapid development in this technology. So we are expecting improvements in that over the near future. This work was particularly valuable in where as-built records are incomplete or unreliable, or where there's concern about the internal configuration that may differ from the original design assumptions. The tolerances are currently within one standard bar size, thereby providing a strong correlation with the as-built drawings. So this histogram here, you can see this bar chart here, you can clearly see how the actual results correlate with the as-built drawing within standard bar sizes. Further work that we've also been looking at is the potential for defect detection within the reinforcement at a half joint, so specifically focusing on the identification of loss of effective cross-sectional area within reinforcement bars. So this was done by masking off cylinders around the selected reinforcement bars, and then analysing the mean scattering angles of the muons within the slices along the length of the cylinders. By analysing the change in mean scattering response within these volumes, localised reductions in density can be identified, which can be indicative of defects or internal deterioration. There is further work to be done with this because there appears to be some interference from other bars within the muon trajectory and from bars that intersect the cylinder masks. This capability is still under development and requires further validation before it could be relied upon. However, the results to date suggest a strong potential for muon tomography to contribute to the identification of internal defects that would otherwise be extremely difficult to detect without intrusive investigation. In addition to the reinforced concrete applications, for which the methodologies are relatively well developed, Phase 3 has also included early stage application for the suspension cable trials, most notably on the Forth Road Bridge in Scotland in collaboration with BEAR Scotland. The post-processing methodologies for these have only just started within the last couple of months. In this case, defects were deliberately introduced into the cable at the scan location to provide a controlled benchmark for evaluation. At present, the post-processing methodologies are not able to reliably detect those defects. However, these trials have been extremely valuable in defining the current limitations and are directly informing ongoing refinement of detection algorithms and methodologies. They also highlight the additional challenges associated with steel cable systems compared to reinforced concrete elements. Here is an image of some of the intrusive investigations that would normally be undertaken, and this is where the artificial defects were introduced for the trials. So alongside the in-service trials, we're also undertaking targeted work to expand the materials library used in the processing software. So this includes dedicated trials on corrosion samples to improve the ability to distinguish corrosion from parent steel or concrete. This development is expected to be particularly important for both reinforced concrete structures and potential future suspension cable applications. Supporting improved sensitivity to materials, to material condition rather than just geometry. So to summarize, Phase 3 has proven that muon tomography can be deployed on in-service structures with rapid advances in the technology's capabilities. The results are encouraging, giving growing confidence in identifying reinforcement arrangement and bar diameters and demonstrating a strong potential for defect detection. At the same time, it is clear that this is a rapidly developing technology. The results are not perfect, and Phase 3 has identified clear limitations in both detection sensitivity and post-processing capabilities, particularly for defect detection and suspension cable applications. However, post-processing methodologies are being refined and showing significant potential over the next few years. Overall, we believe that muon tomography has significant potential as a credible form of non-destructive testing, and that continued improvement in detection methods, post-processing algorithms, and materials library provide a clear pathway towards delivering increasingly reliable information to support structural assessment and asset management decisions. Finally, I just wanted to share that National Highways are currently running a call for ideas, looking at non-destructive testing technologies. So if you have any ideas for that, there's an opportunity for funded trials on a full-scale model, full-scale sample of a half joint, which will be opened up for validation of the testing results during the demolition process afterwards. And also there's further presentations about some of the NDT work that has been done for the Structures Moonshot project on the second QR code. So yeah, I'm happy to take any questions.
Thank you so much, Tim, for giving us your valuable time and inspiring us. I now request Mr. Burji sir to receive the guest of honors on behalf of Tim. And Tim, we have one question from Jai Gopalji.
Yes.
Mr. Tim, the question is regarding, we have seen the ultrasonic pulse velocities, X-rays, and so many other types of rays, but we have not heard about the structures being examined using the cosmic rays, and that too for many days. This is a new type of the method what is being followed by you. In fact, what I have seen, even our president of IABSE has also seen and surprised in the Copenhagen, using a cosmic rays it takes about a week or 10 days for the entire rays to pass through, and exactly we have shown the reinforcement details at various configurations. Now, in fact, when I discussed with you last time, you told me that the decommissioned bridges or decommissioned structures are being cut open, cut neatly, and compared with the time. Like about 70 years back, what was the corrosion levels, pH levels, and other distress conditions, how much it has gone through in the 60 or 70 years. And that decommissioning, in India, I think we do not do that decommissioning, cutting and opening, we don't do that. Now we allow that to have its natural death, and we just throw it out into the ground. But whereas this idea about the decommissioned bridges structures being cut and examined thoroughly for its present condition, like what you people are already doing. In fact, Mr. Tim has invited many of us also, in case you have ideas or you can do some PhDs on that basis. He was very happy. In fact, we can contact any one of you. We have his email address, telephone number. Anyone can contact and be in touch with them. This is absolutely a new type of work, actually. All of us, any one of us who is already into the non-destructive testing and the investigative nature, which I was surprised because we do many this type of investigations, but cosmic rays investigation I not heard of. And they are doing that, especially the decommissioning. In fact, we should also introduce here in the decommissioning, because we should not allow it to simply demolition, throw it out. We should make a comparison. So that will be useful for future our either specifications or to modify our method of working, like materials or whatever in that direction. Thank you. Anybody can kindly contact him. You can open your YouTubes and you can get those details. If you want further details, please come back to us. We will be certainly happy to give you. Thank you.
Is there anything to say, Tim?
Yeah, well, I was just going to say that it's not always very common to decommission structures as we have done as part of this particular project, where we're able to go and undertake testing on a demolished sample. Yeah, I mean, so this really does present a great opportunity for that, for any kind of non-destructive testing or kind of post-demolition type kind of reflective learning on how things have performed over the 50 years of service. So yeah, I mean, it is a great opportunity for people to get involved. So yeah, be happy to hear from anyone who has any great ideas for this.
Yes, thank you. Thank you so much, Tim, for joining us.
Okay, thank you.
Sir, after the peak. Thank you so much. And on behalf of you, Burji sir will be receiving the guest of honors and now request Jai Gopal ji to do the guest of honors. On behalf of Tim, Mr. Burji sir is receiving the guest of honors. Please give a huge round of applause. Thank you so much. So let's take a moment to say gratitude to our beloved sponsors and now request JSL sponsors to please give the presentation.
Am I audible? Thank you for letting us present the solutions for stainless steel today, for bridges particularly. The topic here is the health monitoring. So there are a lot of reasons why it deteriorates. One of the reasons is corrosion. So today we'll talk about corrosion-free structures. We are from Jindal Stainless. We produce all sort of stainless steel. I'll skip this slide. So topic today, we'll be talking about bridge girders, reinforcement bar in stainless steel. And so as we mentioned, the corrosion is the main issue here. 5 to 7% of GDP of India is being invested in maintaining these structures all across. There have been various incidents, and at this point when we are talking about life cycle costing, we are talking about residual value, we are talking about faster execution, safety. So when we keep all these in a one basket, there are certain possible scenarios of choosing a better material which can provide all these benefits. Now one such material is stainless steel. So why stainless steel? As I opened the conversation, that is because of corrosion. As per the corrosion map all across, we have such a large coastal belt. In addition to coastal belt, the pollution, changing in weather patterns, wet and dry cycle exposure, that is more and more letting the material to deteriorate, temperature fluctuations. So more and more now stainless steel is being used. One such good example for using stainless steel for infrastructure is the comparison here, Eiffel Tower versus Chrysler building. Eiffel Tower which is built in wrought iron. And every close to 7 years, close to 500 crore rupees are spent for the maintenance, whereas in Chrysler building, the dome and a lot of other areas are made up of stainless steel. And in last close to 100 years, the maintenance that was done is degreasing and washing of that tower. So that's the kind of difference when you compare the life cycle of a structure. That's the kind of cost impact it will make. Initial cost might be a little high when you choose a better material of construction. But as the life of the structure, you see, the maintenance cost will be drastically low. Coming back to India, this example is from India. This was the first railway bridge. Now, railway was the pioneer to use stainless steel for their girders, and they developed a grade called IRS 350CR with the Stainless Steel Development Association of India. And that happened because couple of bridges in railway, footover bridges collapsed because of corrosion. That was the genesis of using IRS 350CR grade. Now this grade was developed by us, and then first time it was used in 2021 for a railway bridge, footover bridge. That time we were told that the main girders can be made of stainless steel. The other ones are already of mild steel. Let it be like that. That was obviously it was loss of business, but now 4.5, 5 years, it is a good reference. You see the MS structures, same contractor, same location, same everything is same. You can see the difference between the stainless steel IRS 350CR performance versus MS. Even at the bottom, if you see the column bases, there are substantial difference. And as this is just 5 years, as time proceeds, the corrosion will deteriorate. And then the example that I showed earlier, the maintenance cost will come into picture. Initial cost is obviously close to 50% higher, 50 to 55% higher, but that all recovers when it comes to maintenance. In addition to that, safety is a major concern. We can't put a value against safety. So a lot of these bridges have to be safe because they deal with the lives. So now why stainless steel provide corrosion resistance? That is primarily because of the presence of an element called chromium. Now minimum 10.5% chromium should be there. Then at a molecular level, when we have chromium at 10.5%, automatically it will create a chromium oxide layer at the top. That is the basis of why stainless steel provide corrosion resistance. Now the same phenomena in mild steel is done artificially. Multiple coatings are done, metallization are done, which are sacrificial in nature. And because of that, again and again maintenance has to be. And God forbid there is a crack that goes unnoticed, the accidents happen because of those incidences. Now, stainless steel, the grade that we are talking about is structural stainless steel, which has a yield strength of 350 MPa and 450 MPa. So wherever E350 is being used, we can go for IRS 350 stainless steel grades. And it is being used in various bridges now. And the products that I'm talking about today is the plates. These are the structural stainless steel plates, which we call IRS 350CR and IRS 450CR grades. These are ferritic martinistic grades. From 3 mm till 80 mm thicknesses are possible. There is also misnomer that stainless steel, only thin plates are available in the market. That's not the case. From 3 mm till 80 mm plates are available. Girders can be manufactured. We are producing the girders in our fabrication plant and giving it to the contractors. Stainless steel rebars. We are using various projects in India. Then stainless steel roof sheeting. Now, gradually, a lot of players are moving towards stainless steel roof sheeting, paintless solution. Then checkered plates as well as the tubular sections. So how we operate is starting from the consultancy phase, design support we provide, IIT vetting, fabrication, raw material we produce, even fabrication yard we have from where we fabricate and provide the girders and whatever shape we need. Now, there is a lot of work that has happened already around structural stainless steel in terms of infrastructure. Policies from North has come out to use stainless steel rebar. Similarly, Railways has issued policy for stainless steel rebar. Then from courts, BIS has issued IS 16651 rebar standard is there. 6911 has already incorporated all these high strength stainless steel grades. Then the RDSO has published material code as well as the standard drawings, which can be used for FOBs, ROBs. And in addition to that, a lot of cable stayed bridges, composite girder bridges, a lot of bridges which we have constructed, those drawings are available. Schedule of rates in Tamil Nadu, Andhra, various places already it has incorporated. In Karnataka also it is at advanced stage. It is in draft stage. It will be incorporated. So lot of work is happening around it. I just thought today quickly I'll summarize this. So we are talking about these two grade IRS 350CR and 450CR with a yield of 350 and UTS of 450. This is IS 6911 where all these grades are already incorporated. Indian RDSO has issued a standard for the material code, which is they have also issued RDSO standard for standard drawings for footover bridges as well as ROBs. These are ROBs of 30 and 36 meter long, footover bridges of 20 meter, 25 meter, 25, 30 meters. For ductility perspective, it performs pretty well compared to MS. That's a fact. And there are a lot of studies that have been already done around, if I have to put number, what kind of corrosion resistance provides. So there are a lot of studies already done. So one such study is done in South Africa. For 20 years, different materials were exposed. And if you see, we are talking about this grade, type 430 versus mild steel, if you will see, in kind of a severe marine and moderate low pollution, you see 0.001 mm corrosion, that is in bracket, per year that's happening versus 2.1 mm corrosion that's happening in mild seals. To put a number, that's the kind of corrosion that happens annually. So IIT Roorkee is doing a lot of tests. Fatigue test has been done where it is performing well. Fire test has been done, it is performing pretty well compared to the mild steel. So in a nutshell, all these codes are available. Nuts, bolts, washer, welding consumable, everything is established in the market, being widely used. All sort of same welding procedures can be used, methods can be used, only the electrode changes when we are talking about structural stainless steel in girders. In India right now, this is a scenario close to 1.8 lakh tons of steel is being used for multiple types of bridges all across. Some examples, now Kanyakumari Bridge, a lot of footover bridges are made up of these grades. Then going forward, this is at Mumbai. In this, the pylons are made up of these stainless steel grades. Cable stayed bridges are coming up, which will be using composite girder as well as pylons in stainless steel. Yeah, we just talked about this Kanyakumari Bridge, 100-meter long and 20-meter wide. This is happening in Chennai. This is a bowstring girder bridge completely bolted in IRS 450 CR. And one good thing that we have achieved here is earlier the depth was considered in concrete, depth was 2.7 meter, and it is coming on a navigation span, navigation canal. The span 4 meter height was required, and if they would have gone for concrete, approach span itself would have been 42.5 meter on either side. With IRS 450 CR, we were able to achieve the total height from the road top till the bottom only at 850 mm. So 42.5 meter approach spans were saved on either side. So that made a lot of economics viable, as well it is on a canal, so corrosion resistance is very important. It is very near to the sea as well. This is happening, we have proposed this for Thalassery in Kerala. This is completely tubular structure, primarily for the tourism purpose. Then this is happening in Mir Alam Tank, Hyderabad. This sinusoidal wave-like structure will be of IRS 350 CR. It has been awarded to KNR Construction. These are a couple of footover bridges, just for your visualization, which is happening all across cities. This is complete tubular IRS 350 CR. This is in CMRL. We got a pilot project in CMRL for the entry-exit structure, which were earlier done. Most of the time it is done in concrete, so faster execution and long life. This is interesting for flooding all across cities. This is one problem of flooding. So most of the places we find concrete bridges. Now with concrete bridges, these are already existing. Just another 3 minutes, sir, I'll take. So all over these places, we are now going for semi-through girder bridge, thereby reducing the height and giving the more freeboard for the water. And it is helping in corrosion resistance, in the flooding. It says a lot of, I'll just skip all this. Just last thing on the rebar, stainless steel rebar we are already producing. This is the standard IS 16651 for stainless steel rebars, where multiple grades of stainless steel as well as the strength level from 550, 500, 550, 600, 650, and all the dies are available, and which is being widely used all across. So couplers, binding wires, all of these things. Even policies have been supporting this. Railway has issued a policy, Morth has issued a policy. Then compared to the coated rebars, whenever the coating, at site, it will be bent and the coating will crack. So ultimately, be it GI coating or epoxy coating, it actually fails at the corners at site. So that is one of the problem. Also for the coatings, IRC 112 clearly says that for bond value has to be reduced by 20% and the lap has to be increased by 25%. So that also increases the consumption of such coated rebars. And Morth has also now kind of suppressed using the epoxy coated rebars and promoted stainless steel. Now these are very common sites when we go for, because of the positive time I'm running through. One last comparison that I'll do with corrosion resistance, CRS rebar, there lot of builders and consultants have actually made this comparison come out, that the corrosion resisting allowing element in CRS is only 0.4%. That is added, and that 0.4 consists of chromium, copper, nickel, molybdenum, phosphorus. So when you see MTCs of CRS, chromium, that is the main element for corrosion resistance, only 0.02%. So chemistry-wise, it will not sustain the the corrosive environment, and thereby a lot of places now players are coming from CRS to stainless steel, because in stainless steel minimum 11% chromium is there. So that's one fundamental comparison. Now, these are various projects in India already being using stainless steel. And these are some of the railway tenders. Even for high-rise buildings, all the buildings where diaphragm walls have to be constructed, now we are seeing a lot of increase in using stainless steel rebars over there. And from CRS, they are going to stainless steel rebars primarily. Yeah, I'll skip for this. Checkered plates, pipe and tubes. In pipe and tube, there is one critical problem that is of quality. Now at site, people may not identify what grade is it. The hand railing we are using, although it is very trivial for such discussion, but there is a quality issue here. So we have started something called Jindal Sati Seal. We have partnered with all the mills which produces these tubes, and every 1.5 meter there is a marking of the raw material supplier, MOU, and the code that can be identified. For example, this is one such structure of bus stops. All these markings, and there is a number. That number can be traced online, and you will see whether it is authentic or not. So various things. And last point, that is the costing. If we talk about costing, now even the government is allowing life cycle costing to be considered when DPR and projects are being evaluated. One such memorandum, office memorandum is here. So yeah, with that, I will summarize. From life cycle costing perspective, stainless steel is much better. Initial cost is obviously about 35 to 50% higher based on the project, but maintenance cost drastically reduces. With that, I'll summarize. Thanks a lot.
Thank you, sir. Thank you so much. Your support in this conference is truly means a lot to us. Thank you so much. And please. Thank you so much. So, let's start the next session. Okay, let's have a break. After this, the chair will be Hegde sir and the deputy chairman Mohan sir, and there are three speakers, Mr. Tristan Kriyav Tyler and Mr. J.B. Ravishankar and Mr. Alok Bhaumik. Please have a good break and please come at sharp 4:20. 4:20. I mean, 4:20. We are basically 4:20, but using 4:20. No. 4 o'clock, 20 minutes. Exactly at 4:20 p.m. Thank you. I hope all of you had a good break. Get energized yourselves. Can I hear you would shout out? Wonderful. So yes, let's start the next session. And now request our session chairman and a session deputy chairman to please take a seats on the stage. And now request Mohan sir to please kindly come forward to the stage, and session deputy chairman Hegde sir to please grace the stage. It's an honor to welcome our next speaker. Mr. Tristan Craig Taylor is a technical lead and account management professional at Aquila Built Health Spain, with extensive international experience in non-destructive testing, structural health monitoring, and advanced material testing technologies. Over the years, he has worked with the leading global organizations, contributing to innovative solutions for protecting and maintaining critical infrastructure with a strong expertise in business development, technical solutions, and infrastructure health assessment. He brings a valuable global insights into the future of smart and sustainable infrastructure management. Please have a look towards a screen. Over to Tristan Craig Taylor. A warm welcome to you.
Thank you very much for that kind introduction. Confirm you can hear me okay? Great, so I'll get started. I'm here to take you through the role of digital twins in supporting inspection and maintenance of structures, particularly with the use of modern NDT techniques. So a quick overview of the agenda today. I'll take you through the primary challenge with traditional inspections. In the second part, we'll answer how digital twins provide some of the solutions to those challenges, or that challenge. I'll take you through a simple digital twin. Then we'll move on to how we use AI to optimize the use of digital twins for our inspections. And then the benefits of using digital twins in multi-asset networks, followed by a conclusion section. And I believe we have time at the end for a Q&A as well. So we'll start off with the challenge. And of course, when we're managing structural assets, we require all information relating to the asset, available all of the time. So in the past, much of this information was stored, as you can see in the image on the right-hand side. So not always available when needed, unless you happen to be sat next to the filing system. And that lack of information availability can really affect the long-term performance of structures and the associated life cycle costs. Okay, this is through missed information or missed insights due to siloed information. So really we require a data storage solution that optimizes the management of data, securing it long-term and making it available to everyone who is authorized to access it and needs to access it. So this helps to optimize the asset inspection and maintenance for its service life, and also protects the long-term serviceability and of course the asset net value through increasing its longevity. So how do digital twins partly solve this issue? So the digital twin that we use as a platform was specifically developed to support structural inspections, putting all the information at the fingertips of the asset owners and anyone involved in the project. So this software that we're looking at today is available through various platforms, so PCs, iPads, iPhones, etc. So the system isn't just about a digital twin or reporting of results. It also guides the workflow of the whole inspection process. So we start off with the preparation for the digital twin, otherwise known as a desktop survey. We then use the digital twin software to collect or capture data on site, actually during the inspection itself. We then use this to collate all of the data at the end of the inspection so that this data can be analysed. And then, of course, we use its automated reporting functions to increase efficiency and the speed of the reporting. So all the assets that we inspect have their own digital twin. This is usually 2D, but can be a 3D as well. And what we do is we log all of the data or all of the observation data to a numbered spot. So you can see the spots in the image there. So they're the coloured and numbered circles on the screen. And they're typically added to a design drawing. In this case, you can see one deck of a multi-storey car park. And ideally, all digital twin software should really be able to store the data that we collect during the inspection. So in this case, what you can see on screen actually in the airport itself is on the left-hand side, a C-scan view, so looking down from above. And what you can see, the red lines there are the post-tensioning ducts and reinforcement. So this is a GPR scan that we can log directly in the software itself, the digital twin. And then we can also add things like visualizations, like you can see on the right. So this is an augmented reality scan projected into the location in which it was taken. So again, same image actually, just a slightly larger view showing the reinforcement layout and also the post-tension ducts within the car park slab on the right-hand side there. So in addition to visualization tools, we can also use what we would term as vital signs type instruments. These are instruments that deliver primarily number data. So on the left-hand side, you can see rebound hammer data that's logged directly within the twin itself, and also on the right-hand side, some eddy current data. So this is for understanding the characteristics of reinforcement steel, so cover of concrete, spacing of reinforcement bars, and diameter estimation. So the software actually stores the raw data itself, and with one click of a button, anyone with the access and authorization can take that raw data and then use it in any way they see fit. So, of course, these data points or these observations, they're also aggregated for all of the data within them for each asset. And these are stored on an asset dashboard. So this really allows the asset owner or the person managing the project, etc., to see what the condition of the asset is. And this is a live dashboard as well, so it updates during the inspection. So digital twins themselves, they're most beneficial when they're applied through the entire cycle of the asset's life. So from pre-acquisition or purchasing, all of the pre-site surveys can be stored there. Of course, once it's been built, it's always advisable to have a birth certificate. This is also known as an as-built verification survey to ensure that the concrete or the structure meets the design specifications. Of course, end of warranty. So when the contractor's warranty runs out, it's also a good idea to inspect your assets just before that. And of course, regular maintenance and any pre-renovation or pre-sale time. So any previously stored information is available through the whole cycle of the asset's life. So this really solves the issue of all of that data being available at any time. So the solution is optimized to support inspection activities. So this transforms a data lake into a more structured system that we can use for looking across data points across the whole asset. So this immediate centralized storage of all data is required. We minimize the risk of important information being lost or overlooked. This is through the data being stored immediately in the cloud. And then it also makes it easier to oversee and manage a project from the engineer or owner's office directly, because we have these live views that can be used to track the progress of an inspection. And also this facilitates collaboration with people off-site. So if we require the authorization of a senior engineer, previously they would have had to go to site. In some cases now, having all of the observation data available to them on a PC live means that they can approve site works before anyone leaves. So a quick example of a simple digital twin. We don't have so much time today to go through 3D models, but to demonstrate how easy it can be to set up a digital twin. This is a bridge in Dubendorf in Zurich. It's the first span of a railway bridge where we don't have any information. So what we can use is a simple drawing that we did on just a piece of paper, and we took the images that you saw in the previous slide. We popped those into ChatGPT, and it created a quick sketch for us. Okay, so just to show you that it doesn't require a complex 3D model to create a digital twin. This is effectively a digital twin of the first span of this bridge, very simply. And so you can see here that all observations are recorded, and we call those spots. So once a spot has been created, any kind of data can be saved under it. So on the right-hand side in the blue box, you can see across the top some icons. So we can add photos, videos, sketches. We can add NDT data. Some of our devices, or some of the devices that we use, are actually connected directly, so we can import data within a couple of clicks. We also have something called AI defect analysis. So this is for the automated mapping of cracks. We have a document section where we can put in sample results or test lab data, such as crush tests from crushing concrete cores for strength. And then we can also use the LiDAR functionality within the software to create 3D scans of an element or a defect itself. If we scroll down on that spot, we'll see all of the kind of meta fields, we would call them, that we can add data to. Now, all of these fields that you can see on the screen now are completely customizable. So depending on the type of standard or structure that you're working on, we completely customize all of these fields so that we're capturing the relevant data on site. So this is an example here of a different spot here where we've added some eddy current data. So this is concrete cover and spacing information. On the right-hand side there, you can see the graph looking image on the right-hand side. You can see above the picture symbol in the bottom left of the blue box, 2. So you can see 2 images, and then you can see one just above the gauge looking icon that's grayed out, and that's the sensor information. So when I click on that, quick zoomed in view of that, I have the full sensor data information and the images that relate to that observation. Okay. So if I click on that data image on the right hand side, it'll actually import all the data for me so that I have the raw data as well, should I wish to do further analysis on that scan. So just one more example. I told you that we could do various types of equipment, and so this is the same thing essentially, but with some different data from a rebound hammer. And as you can see again, we have all of the sequence information, all of the readings there, so that we can do further analysis as and when it's needed. We can look at the spots in lists, and you can see that we have several types of filter across the top. So this, organizes how we inspect things by severity, of the condition of the defect that we've logged or observed, inspection date reporters, etc. And there's many more that we can add using the little plus button that you can see in the top right of the image. And then, of course, on the dashboard that I briefly showed you, we have this bar chart here with on the x-axis, the type of defect, and the right-hand side, the number of defects of that type on the y-axis there on the right. And so the colouring of these defects are related to the severity, and you can see that on the words on the top right image there. So obviously red is a severe defect or an alarming condition. And then blue is in a good condition there. So just looking at this quickly, we can identify how many cracks we have and how severe they are, for example. So I want to show you a little bit about the AI we've integrated into our software and how that optimizes structural inspections for us. So we're finding that they can be greatly accelerated using AI, and generally for complex technologies or complex NDT data interpretation, we still have to use experts for this, qualified experts. But for photographs, we find that actually AI is quite good at analysing those, and it can accelerate the efficiency of reporting quite significantly. So the first step in this process is to configure the AI spots. So we need to know the sort of standards that we're working to, what type of information we're going to collect. The more information we can give the AI, the better the output, effectively. When we take an image, for instance, we generally do 2 images, one for context. This helps with dimensioning. And then we do one close-up of the defect itself. So as we can see here, we have this cracking. What it then does is asks us to put the position, right? So the location on the 2D drawing in this case of the observation or of the defect. Then you can save this, right? And the AI will then, while you're moving on to the next inspection point, it will then start to auto-populate the fields that's been requested for it to fill in. And so you can see this little star symbol next to the spot number, and that says that the AI has completed its assessment and is now ready for you to review and approve. So then you can review the AI generated outputs, and again these little stars next to the title name of the field heading that indicates that it's done its job. Of course, you can edit these if you like, and we treat it a little bit like a junior engineer. Sometimes it can make mistakes, but it's very good at filling everything out in a consistent way with the similar formatting, etc. But it requires sign-off, so someone has to approve this. So once it's been read and edited, single tap to approve that information, and that's now ready for automated reporting. So just a little bit now about using digital twins for multi-asset networks, because this is where they're extremely valuable. So it's really ideally suited to managing a number of assets. Particularly when the assets are very similar. So power grids, the pylon foundations, they tend to be very similar construction on each line, so it's a very good application. Right, this supports, it supports the data analysis on a consistent basis, and also the planning and reviewing of resources. So each individual asset is managed in its own folder, essentially. With a group of other assets related to that asset network, let's say. So again, we have all of these various pylon foundations here, and it's easy to quickly locate the one that you need. So it's substantial beneficial when we look at the scaling of this. So in terms of managing data, here, we have very old drawings here, and we can again, on the left-hand image, on the left-hand side, we can create root folders, etc. So we can mimic the filing standards that have been used previously, and that's really just to mitigate the time required for the migration of data to the platform. And so you saw previously a dashboard of an individual asset. Well, when we create a multiple asset network group, the software aggregates the data across all of the assets for us, and we can customize this screen. You can see on the top right the customize button there, so we can change the widgets or the things that we're interested in seeing. But this really allows us to prioritize or see network-wide where we might have a particular problem with a particular type of defect. So it then supports the prioritization of maintenance and remediation and the resource allocation associated to that. So in conclusion then, there are lots of benefits to the use of digital twin technologies for structured inspection and maintenance activities. It optimizes the collection of data, its storage and sharing. So it facilitates efficient work planning, safety hazards and disruptions are avoided, saves costly repairs, prolongs the service life, and it's an environmentally friendly way to reduce the asset life cycle. If we can extend an asset's lifetime, then of course the need to replace it is diminished and therefore its carbon footprint is reduced. So a well-maintained asset portfolio also boosts stakeholder confidence or retention of clients for service companies, and it enables or enhances financial stability by giving insights to maintenance planning, etc.
So how many,
it's particularly
how many more
efficient when
slides you
we're
have,
looking
Mr.
at-
Taylor? How many more slides you have, Mr. Taylor?
That's it.
That's it? Okay, thank you very much.
Thank you very much. So, yes, thank you very much. I hope the conference is going well. If there's any questions we can't get to today, my details are there on screen if you have any questions. Okay, so I'll stop the sharing now and pass back to the host.
If there's any questions or doubt, please post to his email ID.
Slide back.
Can you please show the slide, Taylor, which has your email ID?
Sure.
The last one. The last slide. Go to the last slide. Yeah.
Yeah, that's it there. We
Now,
should
then the
have it on
email ID,
screen.
if you have any doubts and questions, you can post. Got it? Thank you. Thank you so much, Taylor, for joining us. It's an absolute pleasure to take an insight from you. Thank you. Thank you so much.
Thank you very much, and I hope the conference goes well. Enjoy the rest of your day. Bye-bye.
Thank you. So, our next speaker is Mr. Ravi Shankar. He's a founder, president of Grips India and pioneer in introducing several breakthrough bridge and construction technologies in India. He has played a key role in landmark infrastructure projects, including the world's highest railway bridge over the Chenab River, Konkan Railway Bridges, Kayaga Nuclear Plant, and India's first extra-dosed bridge at Kharghar. A visionary technologist and entrepreneur, he has also been instrumental in introducing bar grip technology in India, establishing the country's first mechanized precast plant and promoting innovative construction practices across the nation. With a huge round of applause and with the honor, let's welcome Mr. J.B. Ravishankar, sir. Stage.
Thank you. Okay. It's okay. Yeah, Mr. Jayaprakash, Jayagopal, don't go. Where are the students? All of them have gone home. Actually, I wanted to make this presentation mainly for students so that they have a reason to become more entrepreneurs than getting into a job, which is the most interesting today. So I thought, let me just motivate some of the students, at least. So I asked Jayagopal why they have all gone home. I saw them in the morning. Now I could see them very few. But anyway, it's up to them to understand that they should attend this kind of events to get motivated. Okay, this is the bridge which everybody knows. It's a WhatsApp bridge. I don't need to give my card to anybody today. The bridge is so famous, everybody knows about it, everybody talks about it, and we have stopped talking about it. Okay, this is something which, this is the photo which I saw in year 2000. This photo is an artist impression of this bridge. So when we were doing the Richmond Circle flyover, we were doing the post-engineering, I could see this. This is something fantastic. What is this bridge? And it is in India. And what do we do for this? It doesn't have post-engineering, but something has to be, we have to enter. And the designers are from Germany, and the railways as the contractors, and the contractors were not yet finalized. But I could aim something which, I wanted to do something in this bridge, this kind of iconic bridge. So it took 10 years for me to go there. We have done some work by that time. So we could make things easier, possible for us to enter, to start the foundations. So that's when the Afghans infrastructure, they have got the job, they called us, and we did the anchors first. And of course, this is the running in 2026. When we started, it was 2012. We started the anchors. I will go to that one by one. And this is the running of the bridge in 2026 we have, and it is now going from Jammu to Srinagar direct, Vande Mataram bridge. This is something which is fantastic. It's in our lifetime it has happened. Otherwise, nobody thought this bridge will be built. Okay. This is the pointer. Okay. And so this is the bridge which I think now most of the people know that the height of the bridge is 350 meters, and it has got the foundations from two sides, the S40 and S50, where we did the anchors. So that anchors was something special. That is a double corrosion protection anchor done by Dividag. So I bought them here. We supplied everything, we installed everything, and this is a type of anchors which has not been used till now in India. This is, that was 40 meters length, and this was something which was a specialty anchor, which was restressable. Today also we can restress it, next 100 years we can restress it, and up to 100 tons. And that is being monitored. It's okay. This one, pointer?
Pointer. Pointer is not working.
Not working, okay. So this is something which we have the foundations here in the edges, S40 and S50. So here we could do the anchors, which is restressable, and that is being monitored. The monitoring is a little different than our regular monitoring, which I will go next actually. That monitoring is, you just check it, then you restress it. It is not an online system, which earlier the railways did not want to have it. So we could give this, and since it is a high load anchors, it's quite difficult to make the other possibilities also. Now they have asked us, which we can do now. So this is something which I could show, and when we are doing these anchors, we also got the information about the arch erection. This arch erection was something unique. We have the temporary cables, and you have to make the arch closure. By keeping this was the time gap was around 4 years. It was 5 years basically. We started in 2017, and we could finish it in 2022. And all these years, we didn't know how long it is going to stay, how long these cables are going to stay. It was purely temporary, but it is supposed to stay even maybe for 10 years. At that time, we were measuring the stress levels, each cables, because we could remove the first initial small cables, then we could make it. This was something which taken us the business, the riskiest part of this business. Nobody knew if we had failed, and this is something which I enjoyed most. And once we have this completion, the archers could join. We had a party on that arches. This is the size of the bridge, for that matter. It is 80 meters wide, and actually there are 3 tracks. 1 track is only being used, but 3 tracks are there for other reasons. So this is something which, so it was 2023. So all this from 2012 to 23, I enjoyed most. And how we got this bridge and why we did this. And this 10, 15 years, something which was absolutely, we had no other thing in mind. In fact, I took Mr. M.N. Satish once he came to me to site, very initially. Then he was asking me which side the water is going. I said, I don't know. I'm just concerned about the bridge. I am not seen down below. So that is the kind of attention it requires to achieve something great in any of the business or in our life. So this is what I wanted to tell the students, and we make a business out of this. We are small. Today, actually, Mr. Chaudhary was asking me, you are still doing the post-engineering. I said, I will do it on the moon if required today, not here. And so that's how you enjoy what you have done, and then what you have to do next. Now we encourage the entrepreneurs to start a business or even diversification for others, and then we bring them to the global level. That's what is, I put the first precast plant in India. That was in year 2000. So now you can see so many, about 100 plants are there now in India, almost. So it's a revolution. This is what we do, basically. So once it is the arches was closed, the deck was pushed, and this is the anchor part actually. These anchors are double corrosion protection anchors. Their life is about 100 to 125 years, which they have asked, and we have ensured that because it is fully corrosion protection also, and it is being monitored also. This monitoring is something which the load cells which can monitor 100 tons, and you can check the loads, and then you can also restress it. This is a restressing system which doesn't have any other place. Actually, they have some more anchors, which are strand anchors, which they are not restressable, but this is a bar anchor. You can see the load cell around it, and it doesn't touch the bar. That's why its lifetime for this load cell is more than 100 years. Any compression load cell cannot be 100 years. You have to change it. So this has got a different system. That's why we used for the first time. It was something which now we are proud to say that it will remain 100 years. Of course, now I will come to the bridge monitoring system per se, because this was something which will monitor the total structure. Once it is done, the deck is pushed, and then the system of monitoring starts. We have many possibilities, which I will go to the next. So these are all the sensor types, and next the purpose and the location is measured, but I will go one by one. I thought of showing it to the students to have a clarity. What is the purpose of a sensor here in this case? Movement of the tall bridge piers. Tiltmeter will measure this, and it will measure the longitudinal and transverse inclination at S40 and S50. S40 and 50 is what we have made the anchors. So that is the edge where the arches starts. And we have the 4 of them, and this fixing, you can see the fixing system. In fact, all this monitoring system was a strain stall system. It's not us. They have done it. I've just requested them to send me this, so they have shared it with me. And the fixing system, you can see it is something which is going to stay for long time. And then we have the strain gauges to measure the stress at predetermined locations in many places, arches, trestle, and deck segments. And this is being connected electrically. And this can give a value of 100 samples per second. That is what is the minimum things what they expect. And this, you have to protect that so that it will, because you know the bridge area is, a lot of rains will come, a lot of wind, and absolutely inaccessible. Actually, there is access gantry for this bridge. people can go and inspect any time the bottom of the bridge. That is the system which is adopted in this bridge. So it's always available. At that height, you cannot make another system to inspect, so we have a system. And then the main purpose of this LVDT is longitudinal transverse movement of the deck in relation to the PR at the bearing location. This is the bearing locations, what you can see. So this continuously monitors and inspects the bearing, and any reduction in that, there will be an alarm which can give them a suitable alarm system. Then all the other systems will be checked up for any, what is the reason for this kind of movement, less movements. And this is a transducer type, and this is also fixed properly so that this has got no maintenance or anything like that. It needs to be observed and it needs to be monitored. Actually, this place is full of wind. In fact, that is the time when if you just go to the top of the bridge, the intensity of the wind can make you surprised that what is that here and what will happen in case if it exceeds. What they have estimated is around 250 kilometers, but I think it has got a system. That's the type of sensor is ultrasonic, not the mechanical. There's no moving parts. So this anemometer can measure any time, any wind pressure continuously. It can sustain and measure. And this is fixed on the top of the bridge. And it is supposed to give an alarm to all the sensors in case if the speed exceeds 250 kilometers. Like this, we also have the air temperature sensor. The air temperature sensor it measures the ambient, and it correlates the bridge articulation for comparison for seasonal changes, because it keeps varying from summer to winter. And winter we do have quite, the temperature goes even up to -2 sometimes. But I think the extreme temperature, high temperature is much more. And this is enclosed so that it can take care of these changes. The other one is accelerometer. This bridge acceleration vertical and two orthogonal horizontal planes. So it can measure that, and a data acquisition unit is connected with this. And this is fixed on the bridge deck, on top of the bridge deck, S45 and S80. That is the extreme ends, S80 and 100. But S80 it is fixed. It's a post-processing script to report mode change of the shape of the bridge and modes of vibration caused by the leaf loads. That is when the train goes, you can observe that. It gives an indication that it is moving, and you can even correlate the speed with that. And then the next, what is the temperature of the bridge? To measure the temperature is measured, and it's a sensor which it is fixed at S45 and S120 expansion joints, because there are two expansion joints in the end of the bridge. So that measures, that is the most important part, where it shows the temperature and the extension. So it makes the bridge movement with thermal expansion and contraction. It locks it. And then the ultimate seismic, because this bridge is supposed to not get damaged in any kind of known seismic movements. And also it's a blast resistant bridge, because it is designed for that. Because it is very near to the border, it's got a requirement that it is a blast resistant. So many things have been taken care. And this is pure seismic, which can measure the accelerometer, 1000 hertz. And it is fixed in the S40 and S50 foundations, where we have done the anchors. So that is where it can really get the total value. So it can give an alarm in case of any big seismic event. It can give an alarm. All the other systems are correlated with that. And to measure the soil and rock condition below S40 and S50, we have this extensometer. This extensometer is fixed inside a borehole, and then this is fixed in the foundations, 30, 40, 60. And anchor points, this anchors has got rods extending it to then it will have a sensor attached to that. It can measure and it can give you value at different depths. What is the displacement that day? This is the anchor which is fixed for strand anchors. It is a vertical anchor. It is strand anchors also. So this is the load cell fixed by strain stall, and this is the system of load cell. What you can see, the compression load cell. It is an online system. What they have. This is online. The other one is not online. We are trying to make it, but this is pure online. It can be measured in the office. But these loads are much lesser. These are all epoxy coated strands, and it is online system which can measure. But it cannot be restressible. The one which the bars are there, that is restressible. This cannot be restressible. And then ultimately you need a system to take care from a satellite system. So we have the total system for positional accuracies, and it is got a system where 24 satellites in orbit around the Earth can measure it. So this is complete system what they have. It's monitored by railways so that they can take any decision if there is any change. And this is located on the midspan. So this is the location which is a reference. So there is also a reference point on the control area what they have. So in these 2 points it will measure and give a proper system of and this is the communication layout where it is from the space what we have been hearing. It has already been adapted there, and it's a complete system which railway monitors now, and they have a system of AMC for these people. This whole system has costed around 5 crores. And the monitoring, the yearly, maybe it's about 1 crore of rupees they spend. So that is the system. But compared to the cost of the bridge, it is around 1,500 to 1,800 crores. It is not much because so this is the way it is adopted also. And we have got the best systems. What we are talking about, everything is there in this bridge. So this is something which adaptable to any structure. Of course, this is got a system of software which will measure everything, keep it recorded, database is created, and they can go back and see the data for last year, 1 year, or every month wise, everything. It's a very elaborate system which they have, which is railway monitors it.
Ravishankar, you got another 5 minutes.
I think it's good enough. So what we have is this kind of structural monitoring is an iconic bridge, is preserving this for so many years. So it is blast resistant, it is seismic, it is taken care, but I think monitoring system will give a confidence to the clients. And I should thank Mr. Umesh Kaul, who is the manager right now, available, planning and monitoring from Afghans, to give this kind of detailing, to show it to you. And at least we can adopt one of this, not all system, any of the bridge. Even students can go and fix up something. I think nobody is observing. You can take the readings and give them. So that's what I wanted to tell. And then this success is some of all the small efforts repeated day in and out. I want you to have that kind of focus to achieve something big, something good, where civil engineering is not something like which you cannot compare it with a software company, software structure, software business. Even as a business, it is something fantastic. I've been doing it, I've been survived in that, and then we are doing something like this. We do something which others cannot do. So this is, you can speak to me anytime, you have the address, and now you can make some questions. We have 3 minutes for questions. Yeah, we have time. I think that is most important.
It is, Mr. Ravishankar, it is rightly said, I will do the thing which others cannot do.
Yes, that's all.
That is your way of success. In fact, that is being liked by many people, including me. And that's the originality of that.
We have done the terminal 2 earthen mounts, which others cannot do.
Yeah.
Others could not do, so we did that. That's the earthwork.
You were talking about airport.
Yes, T2.
Yeah, T2. Yeah, I myself have seen that, how he has done it. In fact, they could not break that also.
Yeah, that's the complaint. I don't mind that kind of complaints.
Yeah, and especially this, whatever you have done here, that anchors for this iconic bridge is fantastic, and I request all others here to ask you questions. Sir, both are there. He will be very happy to share his views, either in the negative or positive way. Possible, not possible. He is open for answering any question. Thank you.
Yes.
Sir, can you please elaborate on the anchoring system and depth of anchors you adopt?
The anchors are 40 meters in length. The reinforcement, what is the steel in that is about 63 mm. It is imported from Japan, and it has got a double corrosion system, double corrosion protection system. So where a layer of cement grout is on the steel. If you ask me, the best corrosion protection any day is the acidic and basic what you have. That is the best corrosion. That's why cement is the best corrosion protection. If you have something epoxy, see they have done the epoxy coated strands anchors also. That is not the everlasting system because they painted the epoxy, which is not the right way to do it. But anyway, there is a commercial considerations for that. These anchors are, they can take about 100 tons. We have stressed it. You can check it every year, once in a year, or maybe when you feel that you need some data, you can check up. And then if it has gone to 70 tons, you can re-stress it. There's a system possible, and then you can lock it again. We have never done that, but it's supposed to happen maybe some 40, 50 years. Maybe it is required.
You mean to say stressing is not done up to the...
No. See, the ground there is very young. All this geotechnical is the main thing in this bridge.
Yes, correct.
Right? What? No, it is not. Some places it is like this, some places it is like that. It is all mixed. It is actually, that's why we have the IASC to do research on that. And they took 10 years, not less. So I think we have a very complicated ground, no doubt.
Okay. What about the wind load?
Wind load is, yes.
250 to
No, that is extreme.
extreme, yeah.
But I think 100 is very common there.
100 is very common.
You should be very careful when you go out on top of it. Otherwise you will see the water. Yeah. No, this is, the height is so much and it's a valley.
Yes.
This bridge, if you see, it's a valley. So in the valley, the normal wind speed itself is very high.
Thank you.
Yeah, I think that will be the last question. That's what the organizers are hinting to me from the corner there. I think we can go to the next.
Thank you, sir. Thank you so much.
Okay. Thank you.
Thanks, Ravi Shankar ji, for explaining a lot of things and giving a knowledge about. Thank you so much. After this honoring will be there.
Oh, okay.
Thank you. So let's take a moment to appreciate our sponsors who worked for us and who is giving us this opportunity to get a lot of knowledge on this session, on this informative day. Let's give a huge moment of gratitude and please have a look towards Viti about Asian Paints. They are one of our sponsors for today's event. Play.
Structural steel surfaces, be it offshore or onshore, often face a host of durability challenges due to factors such as aggressive chemicals, moisture, UV rays, and saline environments. To combat these, Asian Paints proudly presents ApcoRep Corporate X System, recognized as the most durable protective coating for steel structures by leading corrosion-based research institutes in India. ApcoRep Corprotec has created a revolution of its own. Generally, due to formation of pinholes and subsequent impairment of adhesions, coated steel structure surfaces face a major challenge in achieving desired longevity. While traditional coatings like zinc primer, zinc chromate, zinc ethyl silicate, or red oxide primer are used, they merely act as a physical barrier coating on structural steel. ApcoRep Corprotec has a unique self-healing chemistry. Due to the redox mechanism of action, the pinholes that appear in the thermodynamically unstable steel structure get passivated immediately, thereby preventing further propagation of underfilm corrosion. By drastically reducing the frequency of recoating, ApcoRep Corprotec is not only more environmentally friendly, but also more economically viable. With a dry film thickness of more than 225 microns, ApcoRep Corprotec is a 4-coat system that has a primer and an inter-primer coat with self-healing properties. The third coat of epoxy provides a barrier cover, and the finish coat of polyurethane ensures UV protection. Applicable on all kinds of structural steel, this coating can be used for trusses, gantry girders, steel bridges, steel frames, pipelines, onshore and offshore steel platforms, and many more. With a wide range of application and benefits, ApcoRep Corprotec system is a versatile product crafted to add durability, strength and longevity to steel structures across the board.
Thank you so much, Asian Paints. Your support means a lot to us. So let's skip into the next speaker. Are we all ready? Okay, nice. So I'd like to welcome Mr. Alok Bhaumik, is a structural engineer with over 4 decades of experience in bridge and structural engineering. He is a fellow of the Indian National Academy of Engineering, an international professional engineer, and a FIDIC certified consulting professional. He has made significant contribution to the national and international engineering codes through IRC, BIS, and IABSE, and currently serves as president of the India Association of Structural Engineers. He has also published over 200 technical papers and received several prestigious awards for excellence in bridge engineering. So may I now request Mr. Alok Bhaumik, sir, to please take the stage. Come on, everyone, please give a huge round of applause.
Thank you, you are doing very well.
Thank you, sir.
Yeah. So how do I change the slides? This one? This one?
Yes.
This one to change slide, right?
The slides change, they will do. Yeah, next one. Yes, you can change it. Yes.
Okay. Okay. Okay, good evening. Being the last presenter of the last session, many of the things that is there in the slide would have been a repeat because so many people have talked about this subject. But nevertheless, you may get a different flavor. And before I start, I would like to convey my sincere thanks to the organizers who invited me, and special thanks to Mr. Jayagopal for such an excellent hospitality and organizing this kind of event so beautifully. I think a lot of things to learn for us, because we in Delhi also conduct many such events, but we know how difficult it is. But Mr. Jayagopal seems to have done it with his team So thank you, Jayagopalji. So now let me, you see, at the outset, let me mention that I am not an expert on structural health monitoring. This is a subject which I am also in the learning phase. And what I am going to do is basically share my little experience, focusing more on a few case studies of projects where in some way or the other I am involved, and also giving a little bit of background of structural health monitoring. So here we start. This is the broad outline of my presentation. What is structural health monitoring? Let us hear or let us know. You see, how is it different from the normal inspection that we do? Primarily, when we do inspection, it is periodic, it is discrete. We go maybe once in 6 months, once in a year, and do inspection, put it in the inspection manual, in inspection report, and based on the outcome, we do some intervention if needed. Otherwise, we wait for the next year for again inspection. That is the normal, routine, traditional method that we follow. What is structural health monitoring is little different. Here we are actually continuously monitoring the structure and observing its behavior, either digitally or otherwise. And in case there is a little bit of change in the behavior, we know that the structure is in trouble, and we do so. It is not a replacement of the normal inspection process. It is a supplement. And how much inspection, how much monitoring through this digital mode is a matter, depends on the type of structures that we are doing, the type of bridge, long span, and the intricacies involved, and the decision of the owner. So I think in the morning, our master of ceremony talked about human body analogy, and which is very, very correct. Structural health monitoring is similar, analogous to normal health monitoring that we are, as a human being, we go to the doctor and the doctor sort of does. Now there are two ways again, you can compare. When you are having some problem, fever or any heart-related disease, you go to the doctor and they do the inspection. And if you are seriously ill, maybe they will put something where there will be a continuous monitoring. Your BP, your ECG and everything will be on the display. And I don't know how many of you had the experience of Holter monitoring, where you have your gadgets and you work for 48 hours, and then the doctor goes through the behavior pattern of your heart for 48 hours and then take the call. What is the condition of your heart? Now, structural health monitoring is similar. The only thing is that here you need not do it only on a aged or a patient type of structure, but also on a live new structure. This can be applied on both, in a new bridge or an existing bridge. It has importance in both the cases. So on one case, you do monitor patient's health, use the various equipments to check overall health and prescribe corrective medicine. In case of structural health monitoring, you do the monitor condition of the structure, use various sensors, and if excessive stress or deformation, you correct the situation. There are different, SHM, as I mentioned, is different from the traditional monitoring system. In traditional monitoring system, it is essentially based on collection of data, manual analysis by qualified technicians. A lot depends on who is collecting the data, who is observing, what is his skill level, whether he is, what is his, lot depends on the judgment of the person who is actually supervising. Whereas in case of, health monitoring using the gadgets, then there is less reliance on the human judgment. But again, there are complications as to how to interpret the data, whether you have interpreted correctly. So human intervention there is no substitute to it. That will be required. It will be required at a different level. So basically, a traditional method is mostly done primarily by civil engineers. It is a civil engineers domain, whereas these advanced methods and the combination hybrid methods, it is a multidisciplinary task, and it is not only involving civil engineers. You need electrical engineers, specialists, mechanical engineers, computer science specialists, data analysts, and all these disciplines, have to merge together. So I think somebody in the morning session was talking about, young engineers who are into computer science. They also have some in this particular profession. They have a lot of sort of scope. The artificial intelligence, machine learning, and deep learning has further sort of advanced the structural health monitoring to a large extent. Earlier, the structural health monitoring, even 20, 30 years ago, was different from what it is today. Today, with the help of machine learning, deep learning, etc., you can instrument your bridge and compare it with a parallel bridge maybe somewhere in Spain. And based on that, it will tell you the performance. So it's like, the global database is in the computer, based on which your bridge, with the reading that it is giving, will be compared. And so therefore, you are much better informed. Otherwise, if you are doing by a traditional method, you get certain data, information, and you are left to your own judgment as to how the data is to be interpreted. That's the difference. So what are the advantages of structural health monitoring methods? You have an improved understanding of the field structural behavior, detect damage at the onset of an issue. You don't need to wait for a catastrophic failure. Recently, we had seen a failure in Bhagalpur, Bihar, suspended span, just simply one fine early morning or late night, it just fell. It was a catastrophic. The warnings were given, but warnings were not detected or not acknowledged. But if you have a system like this where there will be a whistleblowing, when there is some threshold value sort of exceeded, then it becomes much easier for the authorities to take prior action. This means that your normal frequency of inspection and maintenance can be increased. Otherwise, if a bridge is required to be inspected every 6 months or every 1 year, maybe if you have the instruments in place, your frequency of inspection can be increased, because you are getting a continuous data in any case from the bridge, but that is not a substitute to inspection. It's not that just because it is instrumented, you don't need any inspection at all. It encourages the use of innovative material based on data intelligence. This is another excellent example of how structural health monitoring can be used when you are using a new material, a new technology. For example, we are talking about ultra-high performance fiber reinforced concrete. If you do an instrumentation on those bridges with UHP FRC, probably based on that behavior, we can update our code. Our code is currently under preparation, but we can definitely take insights from the data, even on a new bridge with a new material, and modify our codes and standards and practices. That is another advantage of using SHM. Encourage prudent management and maintenance approach. Once you know, as a bridge management system is another thing which I think in India it is still under development. And if structural health monitoring is clubbed with the bridge management system, then you would be in a much better position as an authority to decide how many bridges require what kind of repair rehabilitation and what is the priority, once you know this real structural health of these bridges. And this would mean, cost savings and extended lifespan. For example, now that the bridge is, in Bhagalpur bridge I am talking about, the suspended span has collapsed. example, imagine the cost and the inconvenience that is caused to the public at large and to the authorities. And they will end up spending at least 20 times or 30 times more cost to restore the bridge than if only they had taken a preemptive action and if they had known. Reasons for slow progress and implementation of advanced structural health monitoring. It has high installation cost, but I believe that in many of the NHAI projects, cost is not the factor which actually prohibits. It is the other bullets, the lack of skill in choosing the right type of sensors for installation of SHM. It is very important once you decided that your bridge has to be instrumented. You should have the right person to decide what kind of instrumentation is required in this bridge, what is the need. And it's not necessary that we blindly follow certain gadgets, just install that and take some data, which I think the morning Dr. Subbarao mentioned about, excessive data is also a problem. So we should be very clear as to what we need. Lack of adequate research in India on structural health monitoring. I think this is an area, a field where basically the institutions also have to gear up and the practicing engineers have to gear up, and there is huge scope for research in this field. The instruments are susceptible to damage in earthquake activity. There are certain instruments which are, most of the sophisticated instruments are very vulnerable. And for example, the fiber optic sensors, they are very, very brittle and vulnerable. And if not installed properly, during installation itself, it gets damaged. But once installed, it is very reliable for giving the data. So therefore, people who are installing, they have to have this knowledge base as to what kind of sensors require what kind of precautions during installation. Then lack of skill in processing the vast volume of sensor data. In many of the projects where the instruments have been installed, I can tell you that there is a need to get a feedback as to whether those bridges, instruments with instrumented bridges, whether the data is being properly utilized or they are just there, but not utilized properly. Because of their size and complexity, large structures require several sensing points, which adds to complexity, particularly in long span bridges, where we have seen some, for example, a recent bridge in Brahmaputra, where the spans are about 200 meters, extra dose bridge, total length 1240 meters, 1.24 kilometers, expansion joint to expansion joint. There are some 300 instruments, gadgets, sensors installed. So this is a complex bridge, of course, but the data that you get of various types, acceleration, displacement, temperature, all these data, you need a proper system for data interpretation and data acquisition. That has to be taken holistically, and that is where I find there is a lot of work to be done. Why structural health monitoring is important for bridges? I think I have explained it in detail in the last section. We have aging bridges, both rail bridges as well as highway bridges. Many of these bridges are more than 100-year-old. Some of them are, between 50 to 100 year. And all these bridges, the existing bridges, require health checkup. Like humans, when we grow old, we become senior citizens. Our frequency of health inspection, we go to the doctors maybe every once in a month or once in 6 months, we go and do a health checkup. Similarly, the aging infrastructures require health monitoring. The new bridges require health monitoring from some other considerations. Then there is a huge traffic growth. The bridges which are 50-year-old, they would have been designed for a load which is much lower than the loads that is plying today. The recent Bhagalpur bridge collapse, I'm told that the axle loads were 5 times the design axle loads, which was plying because they used to carry trucks, heavy material, and axle loads were far higher. The total load GVW was only 2 times, 2.5 times, but the axle load was almost 4 to 5 times. And then there is a issue of climate change and the climate stress, so that risk also needs to be measured, instrumented. And then lack of investment for infrastructure asset management. That is also causing many of the bridges fail before time. Now, so basically in summary, I would say that the structural health monitoring for bridges is important because it gives you real-time damage detection, unlike your normal procedure, traditional method. It's a, most importantly, any post-disaster like earthquake or floods, if you have the infrastructure with instrumentation, it is very easy to detect post-earthquake or say post-flood as to which structures.
You have got 7 minutes.
Good enough.
A little bit earlier.
Okay, thank you. So which structures would require reconstruction or which requires rehabilitation is sufficient? So instrumented bridges, the decision can be made much faster. Imagine the case, a post-2001 Bhuj earthquake. There were so many buildings and bridges it required a huge effort to assess the condition of those remaining structures to decide whether to demolish them or to reconstruct them. Then optimizing the maintenance, I told you about that. Preventing progressive collapse. Bridges are subject to harsh environmental conditions, and how the stress impact the frequency. For example, I'll give you a simple example of bearings. If you have a bearing and if you have the instrumentation done, you know the stress range, and these kind of elements are highly vulnerable to fatigue. And if you can measure the stress range and check, you may find that the fatigue may become critical, which will not give you any warning through any instrumentation. But if you have the stress range, then you can assess and you can compare with what you have designed for. So by this process, you can extend the service life as well. Traditional health monitoring system has got its following components. I think since morning you must have heard Dr. Subbarao has mentioned very great details, so I would not go into details, but it basically covers constructing a model, analytical model, get the data from the site, field data, analyze the model, and based on the experience of the engineer and the knowledge, you make the judgment. Whereas the advanced SHM, the application, it is a very involved thing where it is knowledge driven, it is data driven, and involvement of AI and deep learning has further improved the situation. So basically, first you have to have knowledge to install the sensor system, then you have to collect the data, and based on the data collection, you have to process the data, analyze the system, and based on that, finally you come out with your recommendations. This is it's a 5-step process that you go through. And these are the various instruments that, depending upon what you are going to measure, environmental aspects, load aspects, or structure. These are the various type of sensors which are used for bridges. Basics on monitoring methodologies and threshold definitions. Data-driven and model-based monitoring, there are 2 methods. This data-driven method involves analysis of the data, anomalies or drifts, which are tracked by monitoring the data, and through statistics, it continuously gives you information and if there is any anomaly, it will give you the threshold vessel. And model-based means, some twin, that digital twin we were talking about, they're all model-based method, where you basically get these site data and correlate with the desktop, and both are used in many projects. It's supplementing each other. Both are useful. So in terms of the sensors, you have vibration-based monitoring, you have strain-based monitoring, and you have acoustic emission monitoring. I think my previous speakers have dealt with it in great detail, and I'm not an expert on this, but just for information, I'm sharing this. Global panorama on structural health monitoring. Basically, it all started in early 50s, but that was in its infancy. Today, the structural health monitoring, because of all these, Industrial Revolution 4, all this system, that has improved the structural health monitoring. It has taken to a different level. And it all started after 80s, I would say. So basically, it gives you a historical, transformation, or how the structural health monitoring has developed. As of today, China is basically most advanced in structural health monitoring of bridges. They have innumerable number of long span bridges. They have put the gadgets, and they are collecting a lot of data. There are highest number of instrumented bridges globally in China. Ranging from the longest span to high-speed railway bridges, name it, it is there. Next is Japan, and specialized regions like Hong Kong. Of course, every country has developed it for their own needs. For example, in Japan, most of these systems are to respond to typhoons and earthquakes, whereas in China, it is more based on the climatic conditions and the loads, stress measurement, etc. So their areas are different. And there are other noble global leaders like North America, Canada, Europe, etc. In terms of worldwide structural health monitoring codes and standards, there are few countries which has got codes and standards on structural health monitoring. China is, the latest code was developed in 2016, way back, of course, but that is on structural health monitoring systems. They have guidelines as to what kind of bridges require structural health monitoring, what kind of bridges may not have structural health monitoring, and then they also have 4 levels, categories. Within the structural, it's a very detailed code, and I think it's very interesting to go through these data. And after this, what is that bridge? Morandi Bridge. After collapse of Morandi Bridge in 2018, Australia came out with a code Italy. Italy came out with a code on their bridges, how to do structural health monitoring and what kind of, and they have started implementing that. So these are important informations which can help Indian Roads Congress also to think of having a code on structural health monitoring. Now I come to case studies. Very quickly I will go through. I have only 2 minutes. Okay, let me see. It is just an information. Hello, yeah. So I will talk about few bridges with where instrumentation is done on the bearings to measure the loads and rotation. So this is a bridge in Odisha where cylindrical bearings are equipped with sensors which is measuring the real-time vertical load, horizontal force, movement and rotation. It's a rail bridge where spans are 76 meters plus, and where in the bearings the sensors have been used. It's a railway bridge. and it measures pressure sensors, strain gauges, inclinometers are there, displacement sensors are there. So translation, rotation as well as loads. And these are some photographs. Then this is another famous case of a collapse of Ultadanga flyover in Kolkata, long back, of course. That happened in March 2013. And what they realized is that the bearings were wrongly placed during construction, so it got dislodged. But post dislodgement, you see, this was the correct as per drawing, but as installed, it was reversed. The uplift bearing and the vertical bearing was reversed. So this was corrected in the new span when it was installed. They provided the monitors. And so the uplift bearings, they have monitors to check whether, what kind of negative reaction is coming. And I mean, they have also confirmed that the loads that are coming corresponds to the design. Then the Vidyasagar Setu refurbishment project in Kolkata. Smart bearings are being used to replace the older bearings to monitor load and movement, and portable structural monitoring used to monitor vibration of stay cables during the maintenance activity. This is another project in Bhutan where pod bearings with inbuilt sensors were used to measure the loads, translation, rotation, etc. A bridge in Assam, again spherical bearings are inbuilt with sensors. This is a bridge where central hinge bearing is there. This is a Tejpur bridge in Brahmaputra, where actually we did the design. And at the central hinge is a modern central hinge where you have a compression by PT, pre-stressing, and that is also having a instrumentation done where the force, the pre-stressing force is actually measurable. And then on expansion joints, there are two locations where expansion joint also is equipped with sort of a instrument gadget for measuring the movement. One is at the Mahi River Bridge. This is a extra dose bridge in Rajasthan where, it was a long span. I mean, the expansion joint is maybe after about, I think, 300 or 350 meters. I don't remember exactly. It's a mid-span joint where you have this instrumentation done to measure the movement. Another is at Ahmedabad Metro extra dose bridge where movements are basically recorded. And this is a bridge which has been recently inaugurated by Honorable Prime Minister Guwahati. This is a 1.24 kilometer long bridge, 200 meter individual span, 5 span, and there are a number of gadgets which are installed there, various types, I think, including even the scour measurement. And these are the various type of sensors which are used there. It covers lower pylon, upper pylon, pier cap, deck slab, stay cable, and scour measurement as well. And that's all. To conclude, I would say that there are many challenges in the structural health monitoring in India specifically. Optimal selection of sensor type and placement is very, very important starting point. If we do the starting point wrong, then the entire exercise may go waste. Installation in the field, it requires a multidisciplinary involvement. This is not happening in many projects. I find that the normal contractor who has little knowledge, they are given a drawing and they simply install. There is nobody to really check whether these instruments have been done. A domain expert is not there at site to check whether it has been done correctly or not. Environmental effects on SHM data, there are measurement errors which I think Dr. Subbarao in the morning mentioned about, where the amplitude of, it's very important to know that the amplitude of vibration and the noise, that ratio is high. If the ratio is low, then the error will start dominating, and that that requires a bit of study prior to installation. And then environmental effects on SHM data. So you need to protect some of the instruments so that the environment is not impacting the information that you collect. Correlation of analytical model to actual structure using SHM data. It is extremely important to utilize the structural data to correlate with the analytical model. And if you do it, you will know that your analytical model, it's the concept which is being used for digital twin. But even otherwise, even if you don't have a digital twin, the designer must have this information to know that in this analytical model, which is the correction needed. Data interpretation techniques often lead to inverse problem. I mean, it's most important, I think. If you have the data, huge data, but you are not able to interpret properly, and if you are wrongly interpreting it, then there is a bigger problem because you will end up with the wrong diagnosis. So how to use the information from SHM, bridge management system? SHM enhances the bridge management system, I mentioned about it. Data fusion to combine the information from inspection with SHM. So you have to correlate the data always. Structural condition assessment and prediction of the remaining service life. This is another important tool which can be used to predict the remaining service life also based on the deterioration model. And as I mentioned, with AI, you can easily correlate it with global data, not just data which you have. Life cycle assessment, providing the real-time data on structural degradation. If you have an instrumented bridge and you have a study of 10 years, you know the degradation process, you can predict the future, extrapolate. That is another advantage. And the real-time structural assessment based on continuous monitoring is what basically is the aim. To end, we will say the future of structural health monitoring is shifting towards autonomous AI-driven and predictive systems, evolving into SHM4. I am saying SHM4 to correlate with the Industrial Revolution 4. So we will be see the trend of using wireless sensor networks, digital twins, 5G enabled cloud-based IoT, use of drones and population-based SHM, which is called PBSHM, to reduce the inspection cost and downtime. As I mentioned, reduce the frequency of actual inspection. In any case, we do not have people to inspect. So that way also structural health monitoring helps. Thank you very much. I think I have exceeded the time.
Thank you, Mr. Bhaumik, for that excellent presentation. I think, Mr. Sinha, you have got a question. I think we'll take one question from the audience.
Not a question. I just want to make comments. Alok has really given a real story behind this lack of or why the system of SHM is failing. Mostly it is failing. Let me tell you honestly. And if I go back, we have this Mandvi bridge instrumented, Varanasi bridge instrumented, and after 20 years, nobody is bothering what is going on. Even the foundation was instrumented in Varanasi bridge, nothing going on. So once the importance of that bridge goes away, the system goes away. So that is one big question, and this is where we go to US condition. There is a separate organization who looks after these inspection or SHM. Unless we have that, and that is what we have in railways. Railways have a separate system. You go for 100 years, even 100 years before what happened in that bridge, you will have the record. We do not have record even for 5 years. I mean, records are there, but it is not traceable. And in fact, there are cases where we go for even the as-built drawing for a bridge which was constructed 5 years earlier, we do not have. So unless we have the system, the organization, we also had this discussion many times, that is a separate organization is needed as far as I know, in accordance with the position in USA. USA has got a separate organization, which is not related to construction. So I think that is one important thing which is missing in our case. Thank you.
Thank you, sir. I entirely agree.
Before the anchor takes over, I think we will just wind up from our side, like chairman as well as this one. After that, we can. Or you have some questions?
Yeah. No, it is again a compliment to Sina Saab. Here, even in Bangalore, sir, whatever SHMs, Ananda Circle, they fixed for the same whole system. I think they took 1 or 2 years readings. Our chief engineer was here only, BDA, Bangalore Development Authority, and that's all. Afterwards, nothing. And we have absolutely failed as far as the SHM is concerned in the entire whole country, except railways. As our Ravi Shankar was mentioning, a strong and supportive, who are dedicated, there only the results will come out. As for the road bridges, no, we are very, very poor.
Jayaprasad Saab, would like to say something? Yeah.
Sir.
Completely structured. Pray God for its long life. For example, entire coastal area
Sir.
from Mangalore to Goa.
Sir.
See the number of structure, which structure there. Have we bothered? He was there, I was also there, nobody bothered. At least now we have woken up. From now on, my request is, let us monitor a few bridges on the coastal area for the first time.
Thank you very much. I think let me, wind up the session because I think 6 o'clock you are supposed to be starting your cultural program, it looks like. And we started with a digital twin with Mr. Taylor explaining as to what the digital twin is all about. I think as you saw the explanation by Mr. Taylor, we could make out that structural health monitoring is an evolving system. It's not really evolved, not only in India, all over the world. Though we have been, lagging behind even in the evolving process itself, that itself. But just to, give an importance of the digital twin, he was talking about basically, for the cable stay bridge alone, it is said that the market as on 2026, the digital twin technology is around $1.81 billion, and it is expected to reach in 2030 $3.71 billion as per the study. That's the way, that's the rate at which the world is moving forward as far as the AI, digital twins, that is the virtual reality we talk about, and also the IoT. IoT is very, very common now. Everybody is following it. It's Internet of Things. And that was followed up by Mr. Ravi Shankar and very beautifully explained about the different strain gauges, not only the sensors, and he related to the physical, the appearances of that, and I think that was the down-to-earth presentation so that everybody can understand. As he himself put it, it was meant for the students, but it was not just meant for the students. Many of us, I think, really benefited from that, your presentation. Coming to Mr. Bhaumik, I think that should have been the first presentation of the day, in my opinion. He explained as to what is structural health monitoring is all about. He started with, and then he went on to explain the various aspects of the structural health monitoring, including some of the case studies which he has done. Ironically, his happened to be the last presentation today. I would have preferred that presentation to be the first presentation because it was very explained very well. It is setting the context. It would have been the setting the context for this particular seminar. Very wonderfully put, Mr. Bhaumik, and really it was a very well explained the importance of it, and where we have to concentrate more, and what is the status quo of the structural health monitoring in the country. I think you have explained very beautifully. And of course, to complement that, Mr. Sinha as well as Jayaprasad has given their comment. I think in line with what Mr. Bhomik said, I think it was really in line with that. So that is it from my end. Mr. Mohan, you want to add on something, you can just add.
Thank you, sir. So Mr. Taylor, Mr. Ravi Shankar and Mr. Alok, all the three have given a very good insight to the latest instrumentation that has to be in place regarding the structural health monitoring. Thank you all, sir. Thank you.
Thank you so much. I would like to call Professor Galgali, sir, Technical Advisor to the Industries, to do the guest of honors, Industries Minister, to do the guest of honors to our esteemed speakers. So I would like to say huge thanks to Mr. Tristan Craig Tyler, who has joined online. So on behalf of him, Vinita ma'am will be receiving the guest of honors. Please appreciate our speakers. They have given us a valuable time and insight, ladies and gentlemen. Please give a big round of applause. They are receiving a memento, bouquet, and the gift hampers. Thank you so much. I would like to request Mr. J.B. Ravishankar, sir, to please come on the stage and receive the guest of honors. Thank you so much, sir, for joining us and sharing invaluable insights to us to develop. I now request Mr. Alok Bhomik, sir, to please come forward to receive the guest of honors. Thank you so much, sir. Thank you so much. Thank you, Galgali, sir. I now request I.K. Pandey, sir, to please come forward, to please grace the stage to do the guest of honors to our esteemed session chairman and co-chairman. I now request Hegde sir and Mohan sir to please receive the guest of honors and felicitation from our side. Thank you so much. Your presence means a lot to us. I hope you all got the insights, got a very good knowledge about the subject. Hope so. Is it? Can I hear some voices at least? Wonderful. Thank you so much. Thanks to all our esteemed speakers and the amazing leaders, chairmen and deputy chairmen who are present here. And take a quick short break and assemble quickly. We have a cultural program. So there's a lot to celebrate our culture, connection and contributions. Please take a short break and come quickly. Thank you so much. There's a wonderful performances are there. So we need to enjoy this cultural program. I request each one of you to please come and assemble quickly. I request each one of you to please take your seats, get settled quickly. In next 2 minutes, we'll be starting a cultural program. Yes, ladies and gentlemen, good evening. Can you please make some noise? After the insightful conversation, insightful conference, let's relax, rejoice, and celebrate the spirit of our culture. I request each one of you to give a thunderous round of applause now. Wow, wow. The spirit of culture and the spirit of relaxedness and that joy is looking through your eyes. Wonderful. So yes, with a huge round of applause, let's welcome our wonderful students who are here to perform Bharatanatyam from Kala Dhyana Institute for Arts. With a huge round of applause, ladies and gentlemen, enjoy this evening.
Hello. Namaskaram. How are you all doing? I hope you're all doing well. What is it? You're asking me who I am. And what is with this ridiculous attire? You're right. This is no time for small talk. Let us get into it right away. The reason you find this attire so strange is that I do not belong to the Bhuloka. I am a Kinnara. In our kind, Kinnaras and Kinnaris are inseparable, everlasting lovers. We are also skilled in music and poetry. One fateful day, my consort and I were traveling through the worlds, singing of our everlasting love for each other. प्यार हुआ इकरार हुआ है प्यार से फिर क्यों डरता है दिल. We sang and flew and sang until we bumped into someone. It was a rishi who was meditating in the antariksha, the space between the worlds, because he was sick and tired of the disturbances on the ground. Thanks to you guys and your traffic. He was so furious that we interrupted his meditation that he cursed us. You will be separated from one another until you finish telling 1,000 stories to educate the people of Bhuloka. Only then shall you be free of this curse and reunite with your lover. Ever since, I have been longing to finish 1,000 stories. So far, I have completed 990 stories. I was looking for the right time and people to tell the last few stories. This morning, I learned that there is a group of Rasikas who have assembled in this fine auditorium at KRDCL. I spoke to the organizer. I begged him to give me some time with all of you. He did not agree. He said he has no time. But I thought, he must be a busy man. Even if I performed anyway, he would not notice. So here I am with a group of dancers to help me tell my stories. We only have time till he finds me here. So let us begin quickly. Huh? Yes. It was the beginning of the Treta Yuga. The people were too absorbed in worldly pleasures like Kama and Lobha, greed and desires. The gods, led by Indra, wanted to remedy this. So they approached the creator Brahma. Brahma meditated upon the 4 Vedas. He extracted speech from the Rig Veda, music from the Sama Veda, acting and direction from the Yajur Veda, and emotions from the Atharva Veda. Combining these and the Upavedas, Brahma Ji created performing arts. Thus was born Natya. Neither the gods nor the humans were capable of practicing Natya. So it was given to the equanimous-minded sage, Bharata Muni. Bharata Muni directed the first ever performance of the universe, depicting the story of Amrita Manthanam, the churning of the milky ocean. Ever since, Natya has undergone several refinements until it finally reached the people of the earth as Bharata Muni's greatest offering to mankind, the Natya Shastra. This is the glorious origin of Bharata's storytelling tradition. Would you not say it is fitting that the beginning of a storytelling tradition is in itself a story? Stories are how we make sense of the chaotic world around us, our lives, the people that surround us, and finally, ourselves. So, my dear Rasikas, welcome to Navarasa Kathanam. Have you ever wondered what is the purpose of arts? The Natya Shastra gives a definitive answer: to create an emotional impact on the audience. In other words, the success of a piece of art lies in the rasanubhava it can create. So today, we shall be looking at our stories through the beautifying lens of the 9 primal emotions, the Navarasas. So, what should be the first emotion? Anger. No. A meal cannot begin with spicy food. Sadness. Do you want to drive my audiences away? What should it be? Shringara. Yes, the king of the rasas. That is fitting, since this rendition is solely in purpose of my reunion with my consort, my beloved, my Kinnari, my eternal love. Right. So, let us immerse ourselves in the love, the ocean of love. When one speaks of love, one invariably thinks of Bhagavan Shri Krishna. Bhagavan Shri Krishna, when he was in Gokula, was the beloved of thousands of gopikas. Later, in Mathura, he was a formidable young man who slayed a demon called Kamsa. In Hastinavati, he became the unfailing brother to Draupadi and a trusted friend to Arjuna. In the Kurukshetra, he became the Jagat Guru to the entire world. But before all of this, he was the beloved to thousands of gopikas in the Gokula. When Krishna plays his flute, the gopikas are left with no choice but to rest their heads on his shoulder as they lose themselves in the mellifluous trance of the music. Such is the madness of attraction that Krishna creates. After all, it is right in his name. Karshati iti Krishna. Krishna is the one who attracts. Come with me as I take you to Gokula, where Krishna danced with his greatest devotees, and he brings them gifts of fragrant flowers for their heads and undying love for their hearts.
ಶ್ರಾವಣದ ಸೋಗಿ ಗೊಲ್ಲರ ಹುಡುಗ ಅವನುಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಹುಚ್ಚು ಕೆರಳಿಸುತ್ತಾನ ಅಂಗಾಂಗದೊಳಗ ಅವನುಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಹುಚ್ಚು ಕೆರಳಿಸುತ್ತಾನ ಅಂಗಾಂಗದೊಳಗ ಹೆಗಲಿನ ಗೊಂಗೊಡಿ ನೆತ್ತಿ ತುರಾಯಿ ಹೆಗಲಿನ ಗೊಂಗಡಿ ನೆತ್ತಿ ತುರಾಯಿ ಗರಿ ಬಿಚ್ಚಿ ಕುಣಿದಾಂಗ ಶ್ರಾವಣದ ಸೋಗಿ ಗರಿ ಬಿಚ್ಚಿ ಕುಣಿದಾಂಗ ಶ್ರಾವಣದ ಸೋಗಿ ಅವನೋಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಕಲ್ಲೆಂದು ಮೆಲ್ಲಗೆ ಸೊಲ್ಲಿಲ್ಲದೆ ಬಂದ ಕಲ್ಲೆಂದು ಮೆಲ್ಲಗೆ ಸೊಲ್ಲಿಲ್ಲದೆ ಬಂದ ಎಡದ ಕೈಲಿಯನ್ನ ಸೋರ್ಮುಡಿಯ ಹಿಡಿದ ಎಡದ ಕೈಲಿಯನ್ನ ಸೋರ್ಮುಡಿಯ ಹಿಡಿದ ಬಲಗೈಲಿ ಮುಡಿಗೆ ಮಲ್ಲಿಗೆ ಸುತ್ತಿನಲಿದ ಬಲಗೈಲಿ ಮುಡಿಗೆ ಮಲ್ಲಿಗೆ ಸುತ್ತಿನಲಿದ ಮುಂಗುರುಳು ನ್ಯಾವರಿಸಿ ಮುಂಗುರುಳು ನ್ಯಾವರಿಸಿ ಮುಂಗುರುಳು ನ್ಯಾವರಿಸಿ ಕಣ್ಣು ಹಬ್ಬದ ಮುಂಗುರುಳು ನ್ಯಾವರಿಸಿ ಕಣ್ಣು ಹಬ್ಬದ ಅವನೋಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಹುಚ್ಚು ಕೆರಳಿಸುತ್ತಾನ ಅಂಗಾಂಗದೊಳಗ ಅವನೋಡ ಕೊಳಲುದಿ ಅವನೋಡ ಕೊಳಲುದಿ ಅವನೋಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ನಿಲ್ಲೋ ಗೊಲ್ಲರ ಹುಡುಗ ಕೊಳಲುದ ಬ್ಯಾಡ ನಿಲ್ಲೋ ಗೊಲ್ಲರ ಹುಡುಗ ಕೊಳಲುದ ಬ್ಯಾಡ ನಮ್ಮ ರಾಗದ ಹುಚ್ಚ ಕೆರಳಿಸ ಬ್ಯಾಡ ನಮ್ಮ ರಾಗದ ಹುಚ್ಚ ಕೆರಳಿಸ ಬ್ಯಾಡ ಮಂದಿ ಏನಂದಾರು ನಾ ಹಿಂದೆ ಬರಲು ಮಂದಿ ಏನಂದಾರು ನಾ ಹಿಂದೆ ಬರಲು ವಾರಿಗೆ ದೇವರು ಕೋಪಗೊಂಡಾರು ವಾರಿಗೆ ದೇವರು ಕೋಪಗೊಂಡಾರು ಅವನೋಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಹುಚ್ಚು ಕೆರಳಿಸುತ್ತಾನ ಅಂಗಾಂಗದೊಳಗ ಅವನೋಡ 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 ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಅವನೋಡ ಕೊಳಲುದಿ ಕುಣಿಯುವ ಹುಡುಗ ಹುಡುಗ ಕೊಳಲೂದಿ ಕುಣಿಯುವ ಹುಡುಗ 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 ಹುಡುಗ
What a sweet pain it is to be lost in the ocean of love for Krishna. Well, did you all see how the Gopikas did not even fear risking the wrath of the gods just so that they could spend a little bit more time with their Krishna? And can you blame them? After all, they were the ones who truly understood what it means to be a bhakta of Krishna. It is almost too easy to forget that the arms that held these Gopikas were the same ones that reined in the horses in the Kurukshetra. As Krishna was busy reining in the horses on Arjuna's chariot in Kurukshetra, there was yet another fearless warrior who stood along with them. He was present there, not in the flesh, but in spirit, hidden in plain sight, as Arjuna's chariot and his flag fluttered through the battlefield. It was none other than the Vayuputra himself, Hanumanta. He is rightly called Veera Hanuma, the valorous Hanumanta. There could be no one better to embody the emotion of courage. And his courage is even stronger because it comes from his devotion to Lord Rama. So, when the time came to decide who would be Rama's messenger, it was a no-brainer. Hanumanta grew to the skies and crossed the mighty ocean to reach Lanka. And yet, as soon as he saw Mother Sita, he bowed down, went on his knees and prostrated in front of her. Hanumanta was the one who taught us that courage does not scream. It takes the stage when it is necessary, and as soon as its necessity is over, retreats to the shelter of humility. In the Dwapara Yuga, it was Hanumanta's brother Bhima who was the powerful one. And just like Hanumanta, Bhima too never shied away from helping the needy. In Ekachakra Nagara, he saw a poor Brahmin family in distress, and he killed off a demon who was eating the people of Ekachakra Nagara, whose name was Bakasura. And when the Pandavas were in their exile in Virata Nagara, the lecherous Kichaka was tormenting Draupadi. Bhima risked exposing all of their identities just so he could come to the aid of Draupadi. Here too, Bhima teaches us that true courage comes from love, not hatred. Sri Purandaradasaru beautifully sings the praises of these fearless protectors along with the praise of Sri Madhvacharya. It is now time for us to feel their strengths in our hearts.
ನೆನೆಸಿಕೊಂಡೆನಿ ರಾಕ್ಷಸರ ವನವನೆಲ್ಲ ಕಿತ್ತು ಬಂದೆನಿ ರಾಮದೂತ ನೆನೆಸಿಕೊಂಡೆನಿ ರಾಕ್ಷಸರ ವನವನೆಲ್ಲ ಕಿತ್ತು ಬಂದೆನಿ ಜಾನಕಿಗೆ ಮುದ್ರೆಗಿತ್ತು ಜಗತ್ತಿಗೆಲ್ಲ ಹರುಷವಿತ್ತು ಜಾನಕಿಗೆ ಮುದ್ರೆಗಿತ್ತು ಜಗತ್ತಿಗೆಲ್ಲ ಹರುಷವಿತ್ತು ಚೂಡಾಮಣಿಯ ರಾಮಗಿತ್ತು ಲೋಕಕ್ಕೆ ಮುದ್ದೆನಿಸಿ ಮೆರೆವ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ ಸುಜ್ಞಾನವಿತ್ತು ಪಾಲಿಸಿ ಪಾಲಿಸೆನ್ನ ಜೀವರೋತ್ತಮ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ. ಸುತನ ಪಾದ ಪೂಜಿಸಿ ಗದೆಯ ಧರಿಸಿ ಬಕಾಸುರನ ಸಂಹರಿಸಿದೆ. ಗೋಪಿಸುತನ ಪಾದ ಪೂಜಿಸಿ ಗದೆಯ ಧರಿಸಿ ಬಕಾಸುರನ ಸಂಹರಿಸಿದೆ. ದ್ರೌಪದಿಯ ಮೊರೆಯ ಕೇಳಿ ಮತ್ತೆ ಕೀಚಕನ್ನ ಕೊಂದು, ದ್ರೌಪದಿಯ ಮೊರೆಯ ಕೇಳಿ ಮತ್ತೆ ಕೀಚಕನ್ನ ಕೊಂದು, ಭೀಮನೆಂಬ ನಾಮ ಧರಿಸಿ ಸಂಗ್ರಾಮ ಧೀರನಾಗಿ ಜಗದಿ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ. ಸುಜ್ಞಾನವಿತ್ತು ಪಾಲಿಸೆನ್ನ ಜೀವರೋತ್ತಮ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ. ಮಧ್ಯಗೇಹನಲ್ಲಿ ಜನಿಸಿನಿ, ಬಾಲ್ಯದಲ್ಲಿ ಭಸ್ಕರಿಯ ರೂಪಗೊಂಡಿನಿ. ಮಧ್ಯಗೇಹನಲ್ಲಿ ಜನಿಸಿನಿ, ಬಾಲ್ಯದಲ್ಲಿ ಭಸ್ಕರಿಯ ರೂಪಗೊಂಡಿನಿ. ಸತ್ಯವತಿಯ ಸುತನ ಭಜಿಸಿ ಸನ್ಮುಖದಿ ಭಾಷ್ಯ ಮಾಡಿ, ಸತ್ಯವತಿಯ ಸುತನ ಭಜಿಸಿ ಸನ್ಮುಖದಿ ಭಾಷ್ಯ ಮಾಡಿ, ಸಜ್ಜನರ ಪೊರೆವ ಮುದ್ದು ಪುರಂದರ ವಿಠಲನ ದಾಸ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ. ಸುಜ್ಞಾನವಿತ್ತು ಪಾಲಿಸೆನ್ನ ಜೀವರೋತ್ತಮ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ. ಸುಜ್ಞಾನವಿತ್ತು ಪಾಲಿಸೆನ್ನ ಜೀವರೋತ್ತಮ ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ. ವೀರ ಹನುಮ ಬಹು ಪರಾಕ್ರಮ.
Dear subjects, I hereby proclaim that all the strength in my arms shall forever be in the service of this kingdom. Pardon me, I was practicing how to be a Veera. You see, the thing is, when I reunite with my Kinnari after tonight, I want to sweep her off her feet with my courage. Well, it is still a distant dream. Oh Veera Hanuma Bahu Parakrama, you are truly lucky. You never had to bear the pain of separation from your loved one. But do you know who had to? Shiva. Shiva always lived without any attachments. And yet, when he learned that his beloved Sati had sacrificed herself in the fire, he withdrew himself from the world and immersed himself in intense penance. But when Shiva closes his eyes, the world is engulfed in darkness. Manmatha, out of dire need, had to interrupt Shiva's meditation. Poor Manmatha did not know what was coming next. Before he knew it, he was burned to the ashes by the fire emanating from Shiva's third eye. Shiva's rage knew no bounds that day, and if it was not for Rati Devi, even the gods could not have calmed Shiva's anger that day. He is Rudra, the deity of Raudra. His rage too is a blessing. We remember Manmatha today as we do, precisely because he was blessed by Shiva, the most auspicious one.
Shankara Abhayam Kuru Abhayam
Rasikas, speaking of rage, I have a question to ask of all of you. How do you manage to pacify your spouses when they're angry? Huh? What is it I hear from the back? Apologize, no matter whose fault it is. You, sir, are a genius. I shall carry this piece of earthly wisdom home. But back in my loka, things work a little differently. When my queen is angry, I ask her, what pains you, my love? Because what is anger if not sorrow in disguise? Anger may be aggressive, explosive even. But when the aggression drains away, what remains is pain and sadness. The saint poet Kanakadasa sings of a pain experienced by a bhakta. In the mountain of Trikuta lived a herd of elephants, and they were ruled by the mighty Gajendra, a devout Vishnu Bhakta. One day, he set out to look for some flowers to offer to Vishnu. He found a beautiful lotus flower in the middle of a lake. He entered the lake and he was about to get to the flower. Just then, a great pain engulfed him. A mighty crocodile had taken hold of his leg and refused to let go. He called out to his Lord, "Oh Vishnu!" who wasted no time in rescuing the Bhakta. I have traveled through several worlds, and I have never found a more potent antidote to sorrow than absolute surrender to the divine.
ಕೂಗಿದರೂ ಧ್ವನಿ ಕೇಳಲಿಲ್ಲವೇ ನರಹರಿಯ ಬಾಗಿಲನು ತೆರೆದು ಸೇವೆಯನು ಕೊಡೋ ಹರಿಯೇ ಕೂಗಿದರು ಧ್ವನಿ ಕೇಳಲಿಲ್ಲವೇ ನರಹರಿಗೆ ಬಾಗಿಲನು ತೆರೆದು ಸೇವೆಯನು ಕೊಡೋ ಹರಿಯೇ ಕೂಗಿದರು ಧ್ವನಿ ಕೇಳಲಿಲ್ಲವೇ ನರಹರಿಗೆ ಬಾಗಿಲನು ತೆರೆದು ಸೇವೆಯನು ಕೊಡೋ ಹರಿಯೇ ಕೂಗಿದರು ಧ್ವನಿ ಕೇಳಲಿಲ್ಲವೇ ನರಹರಿಗೆ ಬಾಗಿಲನು ತೆರೆದು ಸೇವೆಯನು ಕೊಡೋ ಹರಿಯೇ ಕೂಗಿದರು ಧ್ವನಿ ಕೇಳಲಿಲ್ಲವೇ ನರಹರಿಗೆ ಬಾಗಿಲನು ತೆರೆದು ಪರಮ ಪದದೊಳಗೆ ವಿಷಧರನ ತಲ್ಪದಲ್ಲಿ ನೀ ಸಿರಿ ಸಹಿತ ಕ್ಷೀರವಾರಿದಿಯೊಳಿರಲು ಪರಮ ಪದದೊಳಗೆ ವಿಷಧರನ ತಲ್ಪದಲ್ಲಿ ನೀ ಸಿರಿ ಸಹಿತ ಕ್ಷೀರವಾರಿದಿಯೊಳಿರಲು
ತರಿಕು ಝೇಕು ತಕ್ಕ ಝೇಕು ಝಣಕು ತಕ್ಕ ಝಣಕು ಕಿಣಕು ತಕ್ಕ ತರಿ ಕಿಟ್ಟ ತಾಂ ತರಿ ಕಿಟ್ಟ ತೈ ತರಿಕು ಝೇಕು ತಕ್ಕ ಝೇಕು ಝಣಕು ತಕ್ಕ ಝಣಕು ಕಿಣಕು ತಕ್ಕ ತರಿ ಕಿಟ್ಟ ತಾಂ ತರಿ ಕಿಟ್ಟ ತೈ ತರಿಕು ಝೇಕು ತಕ್ಕ ಝೇಕು ಝಣಕು ತಕ್ಕ ಝಣಕು ಕಿಣಕು ತಕ್ಕ ತರಿ ಕಿಟ್ಟ ತಾಂ ತರಿ ಕಿಟ್ಟ ತೈ ತರಿಕು ಝೇಕು ತಕ್ಕ ಝೇಕು ಝಣಕು ತಕ್ಕ ಝಣಕು ಕಿಣಕು ತಕ್ಕ ತರಿ ಕಿಟ್ಟ ತಾಂ ತರಿ ಕಿಟ್ಟ ತೈ
ಧಿಂ ಧಿಂ ತತಕತಾಂ ಧಿಂ ಧಿಂ ತತ ತಕ ಧಿಂ ಧಿಂ ತತಕತಾಂ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ದೃಗಡ ತಕತ ತತ್ತಾಂ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ದೃಗಡ ತಕತ ತಕತಾಂ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ತಾಂ ತಕತಾಂ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ತೈ ತಕತೈ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ತಾಂ ತಕಿಟ್ಟ ಧೀಂ ತಕಿಟ್ಟ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕಿಟ್ಟ ತಾಂ ತಕಿಟ್ಟ ಧೀಂ ತಕಿಟ್ಟ ತೋಂ ತಕಿಟ್ಟ ನಂ ತಕಿಟ್ಟ ದೃಗಡ ತಕತ ತಾಂ ತಕಿಟ್ಟ ಇಟ್ಟ ತಕಿಟ್ಟ ಧೀಂ ತಕಿಟ್ಟ ದೃಗಡ ತಕತ ತೋಂ ತಕಿಟ್ಟ ಇಟ್ಟ ತಕತ ನಂ ತಕಿಟ್ಟ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ದರಗಡ ತಕ ದನಗಡ ತಕ ದೃಗಡ ತಕತ ಕಿಟ್ಟ ತಕತ ದರಗಡ ತಕ ದನಗಡ ತಕ ದರಗಡ ತಕ ದನಗಡ ತಕ ಜೋಣ ಕಿಡ ತಕ ದೆಮಿ ಕಿಡ ತಕ ದರಗಡ ತಕ ದನಗಡ ತಕ ಜೋಣ ಕಿಡ ತಕ ದೆಮಿ ಕಿಡ ದರಗಡ ತಕ ದನಗಡ ತಕ ಜೋಣ ಕಿಡ ತಕ ದೆಮಿ ಕಿಡ ತಕ ದಾ ಕರಿರಾಜ ಕಷ್ಟದಲ್ಲಿ ಆದಿಮೂಲ ಎಂದೋ ಕರಿರಾಜ ಕಷ್ಟದಲ್ಲಿ ಆದಿಮೂಲ ಎಂದು ಕರೆಯಲಾಕ್ಷಣ ಬಂದು ಒದಗಿದೆಯೋ ನರಹರಿಯೇ ಬಾಗಿಲನು ತೆರೆದು ಬಾಗಿಲನು ತೆರೆದು ಬಾಗಿಲನು ತೆರೆದು ಸೇವೆಯನ್ನು ಕೊಡೋ ಹರಿಯೇ
My dear Rasikas, why do you look so forlorn? Have I pushed you too far away into sorrow? Forgive me. I know how to remedy this. I know exactly where to take this journey next. Problems and sorrow are inevitable. But the best way to handle them is to laugh at it and at ourselves. And there could be no one better than Ganesha to teach us this. He even looks and walks funny. Sorry. It is particularly funny when Ganesha found a witty way to overpower his brother. One day, the two brothers were fighting over a fruit. So, the Divine Mother Jagannmate Parvati Devi said, the fruit will go to the one who goes around the world quickly. What did Ganesha do? I will let him say it himself. Ganesha, I have a question. Your father is the cosmic dancer himself, Lord Nataraja. Have you never felt the urge to learn dancing from him? You have? Sorry. This huge tummy is not just for show. Once, when Kubera, out of his arrogance, invited Lord Shiva and Parvati Devi to dinner, they decided that they would not go for it. Instead, they said, Kubera, we cannot make it, but Ganesha will come in our place. And when Ganesha got there, he consumed everything. And I mean everything. Thank you, Ganesha. May your blessings keep teaching us not to take ourselves too seriously. Who doesn't like to laugh? You see, as long as we are laughing, we feel light and we forget about all our troubles. So now, I am going to practice my laughing. Why are you making faces? My laugh is disgusting. My Kinnari also says so. But you know what is really disgusting? Raktabijasura. And the way he met his end in the Asura Deva war. Raktabijasura had attained a boon from Lord Shiva. Every drop of blood that touched the ground would give rise to thousands of new Raktabijasuras. In the war, when Devi Durga struck him with her weapon, injuring him, his blood touched the ground and the battlefield was filled with thousands of Raktabijasuras. In the verge of defeat, Mata Kalika had to step in. She stuck out her tongue and drank all of the blood from the battlefield. She ran across the battlefield and cut the head off from every Raktabijasura that approached her. She drank all of the blood before even a drop could touch the ground. She played with the head, throwing it around. And that's how she finally finished off Raktabijasura. O Devi, Jagannathe, what is this unbelievably ferocious form of yours? Why do my knees tremble as I stand before you? Why do I shudder so? What is this darkness that engulfs my heart, stopping me from approaching you, though I know you are the mother? It is fear, bhaya, the darkest of emotions. It dirties my mind. The more I try to clean it, the worse it gets. It's like attempting to wipe one's face with a dirty cloth. Please rid my heart of these fears, Mate. You are my only refuge. Anyatha sharanam nasti, tvameva sharanam mama. Indeed, as long as we put our faith in her, there is no reason for us to be scared. Forgive me, dear Rasikas. I was momentarily handicapped by my own fears. But now, I am feeling a peace that I've never experienced before. It seems I had 6 enemies: desires, anger, greed, attachments, pride, and jealousy. To defeat these 6 enemies, the Devi's blessings gave me 9 weapons. The Navavidha Bhakti. These are 9 ways in which we can strengthen our relationships with the Supreme and invite the Supreme to permanently reside in our hearts. Sadayanna hridayadalli vasamadu Shri Hari.
ಹೃದಯದಲ್ಲಿ ವಾಸ ಮಾಡೋ ಶ್ರೀಹರಿ, ಸದಾ ಎನ್ನ ಹೃದಯದಲ್ಲಿ ವಾಸ ಮಾಡೋ ಶ್ರೀಹರಿ. ನಾದಮೂರ್ತಿ ನಿನ್ನ ಪಾದ ಮೋದದಿಂದ ಭಜಿಸುವೆನೋ, ಸದಾ ಎನ್ನ ಹೃದಯದಲ್ಲಿ ವಾಸ ಮಾಡೋ ಶ್ರೀಹರಿ. ನಾದಮೂರ್ತಿ ನಿನ್ನ ಪಾದ ಮೋದದಿಂದ ಭಜಿಸುವೆನೋ, ಸದಾ ಎನ್ನ ಹೃದಯದಲ್ಲಿ ಹೃದಯದಲ್ಲಿ ಜ್ಞಾನವೆಂಬೋ ನವರತ್ನ ಮಂಟಪದ ಮಧ್ಯದಲ್ಲಿ ಶ್ರವಣಂ ಕೀರ್ತನಂ अर्चनम् वन्दनम् दास्यम् सख्यम् आत्मनिवेदनम् ज्ञानबिम्बो नवरत्न मण्टपद मध्यದಲ್ಲಿ ಗಾನಲೋಲನ ಕೊಳ್ಳಿರಿತಿ ಗಾನಲೋಲನ ಕೊಳ್ಳಿರಿಸಿ ಸದಾ 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 ಧ್ಯಾನದಿಂದ ಭಜಿಸುವೆ ಸದಾ ಎನ್ನ ಹೃದಯದಲ್ಲಿ ವಾಸ ಮಾಡು ಶ್ರೀಹರಿ ನಾದಮೂರ್ತಿ ನಿನ್ನ ಪಾದ ಮೋದದಿಂದ ಭಜಿಸುವೆನೋ ಸದಾ ಸದಾ ಹರಿ ಹರಿ.
Ah, my dear Rasikas, what a wonderful journey we have been on. We traveled to several lokas. We met so many people. We spoke to them, learned of their stories. We sang and we danced along with them. And we did all of this together. In the end, all I am left with is awe, a wonder at this glorious storytelling tradition, at the great civilization of this holy land, and the all-encompassing art form of Natya. Think about it, dear Rasikas. An artist adorns herself with beautiful costume and jewelry, attains the blessings of the Guru, and immediately transforms into a character. They experience dizzying heights and suffocating lows, all the while never losing their inner balance. They do all of this so that they can take you, the Rasikas, on a journey beyond space and time. That is the power of Natya. Come with me, dear Rasikas, one last time as we share the Adbhuta towards this wonderful art form, Natya.
ತಾಂ ತಕತರಿಕಟ ತಕ ತಾಂ ತಕತರಿಕಟ ತಕ
ಜಗದೀಶ ಗರ್ಪಿಸಿದ ಹೂಮಾಲೆ ನಾಟ್ಯ ಜಗದೀಶ ಗರ್ಪಿಸಿದ ಹೂಮಾಲೆ ನಾಟ್ಯ ಕಂಡು ಕುಣಿದಿಹನವನು ಈ ದೃಶ್ಯ ಕಾವ್ಯ ನರ್ತಕಿಗೆ ಶ್ವಾಸವನು ಕೊಡುತ್ತಲಿದೆ ನಾಟ್ಯ ಜಗವು ಕೊಂಡಾಡಿಲರು ಇನ್ನಾವ ಭಾಷಾ ಜಗದೀಶ ಗರ್ಪಿಸಿದ ಹೂಮಾಲೆ ನಾಟ್ಯ ಕಂಡು ಕುಣಿದಿಹನವನು ಈ ದೃಶ್ಯ ಕಾವ್ಯ ನರ್ತಕಿಗೆ ಶ್ವಾಸವನು ಕೊಡುತ್ತಲಿದೆ ನಾಟ್ಯ ಜಗವು ಕೊಂಡಾಡಿರಲು ಇನ್ನಾವ ಭಾಷಾ ಇರಿಗಮ ಗಮದ ಮದನಿ ದನಿ ಸ ನಿಗರಿ ಸನಿದ ನಿರಿಸ ಸನಿದಪ ಸನಿದಪಮ ನಿದಪಮಗ ಗಮದನಿ ಜಗದೀಶ ಗರ್ಪಿಸಿದ ಹೂಮಾಲೆ ನಾಟ್ಯ ವರ್ಣದಲ್ಲಿ ಮಿಂದೆದ್ದ ವಸ್ತ್ರಗಳನ್ನೂಟು ವರ್ಣದಲ್ಲಿ ಮಿಂದೆದ್ದ ವಸ್ತ್ರಗಳನ್ನೂಟು ರವಿಚಂದ್ರ ತಾರೆಗಳ ಭೂಷಣವ ತೋಟು ರವಿಚಂದ್ರ ತಾರೆಗಳ ಭೂಷಣವ ತೋಟು ಗುರುವು ತಾ ಪ್ರೇಮದಲ್ಲಿ ಅಭಯವನು ಕೊಟ್ಟು ಮೂಳುನಗೆ ಮೂಡಿದರೆ ನರ್ತಕಿಯ ಹುಟ್ಟು ಮೂಳುನಗೆ ಮೂಡಿದರೆ ನರ್ತಕಿಯ ಹುಟ್ಟು ವರ್ಣದಲ್ಲಿ ಮಿಂದೆದ್ದ ವಸ್ತ್ರಗಳನ್ನೂಟು ರವಿಚಂದ್ರ ತಾರೆಗಳ ಭೂಷಣವ ತೋಟು ಗುರುವು ತಾ ಪ್ರೇಮದಲ್ಲಿ ಅಭಯವನು ಕೊಟ್ಟು ಮೂಳುನಗೆ ಮೂಡಿದರೆ ನರ್ತಕಿಯ ಹುಟ್ಟು ಮಾಮ ಗಮ ಗದ ಮಗಸ ಗಮದನಿ ಸ ಧನಿ ಸಾ ಸಗಮ ಸಗಮ ನಿಸಗ ನಿಸಗ ಧನಿ ಸ ಸನಿ ದ ಮಗ ಮದನಿ ಸ ಸನಿ ದ ಮಗ ಮದನಿ ಸ ಸನಿ ದ ಮಗ ಮದನಿ ಸ ಜಗದೀಶ ಗರ್ಪಿಸಿದ ಹೂಮಾಲೆ ನಾಟ್ಯ ಕಂಗಳಲ್ಲಿ ತುಳುಕುವುದು ಅಪರಿಮಿತ ಭಾವ ಅಂಗವಿದು ಜನಿಸಿಹುದು ರಸ ತಳೆದು ಜೀವ ಅಪರಿಮಿತ ಭಾವ ಅಪರಿಮಿತ ಭಾವ ಅಪರಿಮಿತ ಭಾವ ಅಪರಿಮಿತ ಭಾವ ರಸ ತಳೆದು ಜೀವ ರಸ ತಳೆದು ಜೀವ ರಸ ತಳೆದು ಜೀವ ರಸ ತಳೆದು ಜೀವ ಕಂಗಳಲ್ಲಿ ತುಳುಕುವುದು ಅಪರಿಮಿತ ಭಾವ ತಿಳಿದು ಗತಿಯನು ಸರಿಪಯೋಕ್ತಿ ಶಬ್ದ ಶಿಲ್ಪದ ಚಲುವ ಅರಿವಧೀಶಕ್ತಿ ಲಯದ ಹದ ತಿಳಿದು ಗತಿಯನು ಸರಿಪಯೋಕ್ತಿ ಶಬ್ದ ಶಿಲ್ಪದ ಚಲುವ ಅರಿವಧೀಶಕ್ತಿ ಮೇಲೈಸಿ ಹೋಗುವುದು ನೃತ್ಯ ಮಕರಂದ ರಸಿಕನಿಗೆ ನೆಮ್ಮದಿಯ ನೀವೇ ಅದರಿಂದ ಲಯದ ಹದ ತಿಳಿದು ಗತಿಯನು ಸರಿಪಯೋಕ್ತಿ ಶಬ್ದ ಶಿಲ್ಪದ ಚಲುವ ಕರಿವ ಶಕ್ತಿ ಮೇಳೈಸಿ ಹೊಂಗುವುದು ನೃತ್ಯ ಮಕರಂದ ರಸಿಕನಿಗೆ ನೆಮ್ಮದಿಯ ನೀವೇ ಅದರಿಂದ ಲಯದ ಹದ ತಿಳಿದು ಗತಿಯನು ಸರಿಪಯೋಕ್ತಿ ಗಮನಿದ ಮಗರಿ ಗಮ ಪಗರಿ ಸರಿ ಸರಿ ಧನಿ ಸಮಗಮ ಸಮಗಮನಿದ ನಿಪದ ನಿ ಸರಿ ಗಮಗಸ ಮಗಸ ನಿದ ಗಸ ನಿದ ಮಗಮ ಮಗರಿ ಮಗಸ ನಿದ್ದ ನಿ ಸರಿ ಗಮಗಗ ಸರಿ ಗಗ ಮನಿದಗ ನಿ ಪದ ನಿ ಸರಿ ಸ ಸರಿಕ ಮರಿಕ ಮದಕ ಬತ್ತನಿ ಮತ್ತನಿ ಮತ್ತನಿ ರಗತ್ತನಿ ಮಗತಿ ಮಗಗ ಬತ್ತನಿ ಸ ಸಮಗಮನಿದ ನಿ ಪದನಿ ಸರಿ ಗಮಗಸ ಮಗಸ ನಿದ ಗಸ ನಿದ ಮಗಮನಿದ ಜಗದೀಶ ಗರ್ಪಿಸಿದ ಹೂಮಾಲೆ ನಾಡ್ಯ ಆವೇಶವನು ತರುವ ಭಾವದ ಉದ್ವೇಗ ಆವೇಶವನು ತರುವ ಭಾವದ ಉದ್ವೇಗ ಆವೇಶವನು ತರುವ ಭಾವದ ಉದ್ವೇಗ ಆವೇಶವನು ತರುವ ಭಾವದ ಉದ್ವೇಗ ಶಾಂತಿಯನೇ ಸುರಿಯುವುದು ನಾಟ್ಯವಾದಾಗ 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 ಆವೇಶವನು ತರುವ ಭಾವದ ಉದ್ವೇಗ ಶಾಂತಿಯನೇ ಸುರಿಯುವುದು ನಾಟ್ಯವಾದಾಗ ಆವೇಶವನು ತರುವ ಭಾವದ ಉದ್ವೇಗ ಶಾಂತಿಯನೇ ಸುರಿಯುವುದು ನಾಟ್ಯವಾದಾಗ ಹರನು ನರ್ತಿಪನಿಲ್ಲಿ ಭೂಮಿಯ ಬಗೆಗೆ ಹರನು ನರ್ತಿಪನಿಲ್ಲಿ ಭೂಮಿಯ ಬಗೆಗೆ ಎನ್ನ ಭಾಗ್ಯವು ಇಲ್ಲಿಡುವ ಪ್ರತಿ ಹೆಜ್ಜೆ ಎನ್ನ ಭಾಗ್ಯವು ಇಲ್ಲಿಡುವ ಪ್ರತಿ ಹೆಜ್ಜೆ ಸರಿಗಮ ಗರಿ ಸರಿಗ ರಿಗಮ ಗ ಮಗ ಮದನಿ ಸರಿಗಮ దని స దని సరి గ సరి గ మరి స ని స దని స సని ద ప మ గ మ ని ద ప మ గ రి స సరి గ మ ప దని స ని స దని స సని ద మ గ స ని ద ని సరి గ మ స మ గ మ ని ద ని ప దని సరి స సని ప మ రి రి ప మ రి స ని సరి మ ప ని సరి మ ప రి రి స సరి ద మ గ సరి ద ని స గ మ ద ని స గ మ మ గ గ స స ని ని స ని ద ని స ని ద ప మ గ రి గ మ ప ద ని స రి గ గ రి స ని ద రి స ని ద ప గ మ ప ద ని రి స ని ద ప స ని ద ప మ గ మ ప ద ని గ రి గ రి ద రి ద రి స ని ద ప గ మ ప ద ని జగదీಶ ಗರ್ಭಿಸಿದ ಹೂಮಾಲೆ ನಾಗ ಕಂಡು ಕುಣಿದಿ ಹದವನು ಈ ದೃಶ್ಯ ಕಾವ್ಯ ನರ್ತಕಿಗೆ ಶ್ವಾಸವನು ಕೊಡುತ್ತಲಿದೆ ನಾಗ ಜಗವು ಕೊಂಡಾಡಿರಲು ಇನ್ನಾವ ಭಾಷಾ ಇನ್ನಾವ ಭಾಷಾ ಜಗದೀಶ ಗರ್ಭಿಸಿದ ಹೂಮಾಲೆ ನಾಟ್ಯ
Hello? What is it I hear? Is it the Rishi talking? Huh? Yes? Really? Are you telling the truth, Rishi? Promise? Thank you, Rishi. Thank you so much. Dear Rasikas, it seems I have completed my 1,000 stories today. I am finally flying back to my world to reunite with my Kinnari. I shall forever and eternally be grateful to all of you for listening to my stories tonight. Thank you so much. The organizer, he is staring at me through the side wings. He seems to be furious. I'm almost done. Just a minute. I'm saying thank you. No. Threatening violence is adharma. Shantam papam. Rasikas, it seems my time here is over. I shall take your leave. Dancers, you also go home. Bye-bye. Good night. Kinnari, here I come. Thank you. Thank you, dear audience. ಆಗ್ಬೋದು ಸರ್ ಆಗ್ಬೋದು ಒಂದು ಹೆಸರು ಹೇಳ್ಬಿಡ್ತೀನಿ ಪರಿಚಯ ಮಾಡಿಸ್ಬೋದಾ Dear audience, thank you for your patience and your enthusiastic participation in today's performance. This was Kala Dhyana Institute for Arts. We will take quickly 2 minutes to introduce the artists. From that way, Sarayu, Yagnika, Pragna, Diksha, Chinmayi, Adya, and Anarghya. We have Shilpa with us for technical support and audio. And we sincerely thank Mr. Sunil Kumar for his beautiful lighting. This is Ranjana, the co-founder and the teacher at Kala Dhyana Institute for Arts. And myself, I am Viveka. Namaste. On behalf of Kala Dhyana Institute for Arts, we would like to sincerely thank Jai Prasad sir, Jai Gopal sir, Burji sir, and Mohan sir. And we also thank Bharti ma'am and Vinuta ma'am for all their continuous cooperation and coordination with us, ensuring that this was a smooth journey. And Kala Dhyana has been working for the last 10 plus years in educating younger and younger people and adults in the performing arts. We have been primarily working in the field of classical dance and theater. So we are also recently, we have also started venturing into applied theater for corporates and other working professionals. So if you would like to get in touch with us, we are available with you, and you could also contact us at Kala_Dhyana. Kala Dhyana on Instagram and kaladhyana@gmail.com. Thank you so much. We would like to hear a few words. Thank you.
Fantastic, your performance. And this is ma'am.